What if you could automate any website? Watch this. I'm going to give my agent one goal. Configure a Porsche 911 for me, and then email me the link. Watch how the agent opens the site, chooses the paint, the wheels, the exhaust, all on its own. I never told it where to click. I just told it what I wanted. Seconds later, the finished build lands in my inbox. This is Relay, a platform where you and your team use AI agents to automate the web and actually get work done. And in this tutorial, you're going to learn how to build this entire platform yourself. The heart of Relay is the canvas, built with React Flow. You start with a trigger and then chain together action nodes into a workflow. Some are simple, like opening a URL or sending an email through resend. Others are more powerful. The Act node clicks and types for you. Observe finds elements on the page, and Extract pulls out exactly the data you need. And then there's the star of the show, the Agent node. You give it a goal in plain English, and it takes over the browser completely, deciding what to do, clicking, scrolling, and figuring out each step on its own until the job is done. Every node has a configuration panel, and you pass data from one step to the next using simple template tokens. Now here's where it gets satisfying. While your workflow runs, every node shows its status in real time. You see exactly which step is working, when it completes, and if anything fails. The agent lights up and goes to work, and down in the logs panel, you can watch each step finish with its exact duration and output. And all of this runs as a durable background job, so even if you close your tab, your workflow keeps running reliably until it's done. But how is this even possible? Let's break it down. When you hit run, the agent spins up a real Chrome browser in the cloud, powered by Browserbase and Stagehand. That's how it can handle any website. It's driving an actual browser, not just calling an API. The entire run executes in the background using Trigger.dev, which streams every step back to the canvas in real time, while your workflows and their results are saved to a Postgres database with Drizzle and Neon. And because it's a real browser session, the whole thing is recorded, so once it finishes, you can replay and watch exactly what the agent saw and did, step by step. Nothing is a black box. And the entire canvas is multiplayer. Those cursors you've been seeing this whole time, that's your team. Powered by Liveblocks, you can build and edit these workflows together in real time, just like a Figma file. Everyone on the same canvas at once. And building a Porsche is just one example. You can point an agent at almost anything. Have it play a full game of chess. Make it solve today's Wordle. Plan a road trip across the country or put together a morning news briefing and email it to you. If a human can do it in a browser, you can automate it with Relay. And of course, this is a real product. Authentication, organizations, and billing are all built in with Clerk, so users can sign up, create a team, and upgrade to a paid plan. Everything you need to charge for this product from day one. And once it's ready, we deploy the whole thing to production on Railway. And this is more than just a coding tutorial. We're going to build our app the way software is actually written in 2026, using agentic coding. We are going to use coding agents like Claude Code and MCP tools as we build. So along the way, you won't just learn how to build this app. You'll learn how modern software engineering really gets done today. And to keep all of this running smoothly in production, we'll wire in Sentry. Most people know Sentry for error tracking, but it's grown into a full observability platform. Logs, performance tracing, and even AI agent monitoring. And since our app is constantly running AI agents in the background, that's exactly what we need. We can trace any workflow run from start to finish, see precisely what happened at every step, and catch problems long before a user ever runs into them. My name is Antonio, and I will be your instructor for this course. I couldn't be more excited to build all of this together. Let's get started. Let's get started by making sure we have the system requirements and tools needed to develop this project. The runtime in which we are going to develop our application is Node.js, which makes this an absolute requirement to have installed on your machine. You can verify your installation by running the command node-v in your terminal, which should output the version of Node which you currently have. If you're wondering which Node version you're supposed to have to be able to develop this project, the best way to check is to go to next.js documentation inside of installation and find the system requirements. And in here you will find the minimum Node.js version. As you can see, it says 20.9, which means as long as you have this Node version or higher, you're good to go. So you don't need to have the same version as me, and you don't need to have the latest long-term support version. It's only important that you don't have a version lower than 20.9. The second requirement is some kind of version control. The one you're probably familiar with, which is also the most commonly used one, is Git. You can verify whether you have that by running git-v. This will be very important for us to have so we can maintain proper version control so we don't lose the progress of our project's development. Next step is to cascade a brand new Next.js project. Now, usually what I would do is I would direct you to the documentation of Next.js, tell you to find the installation, and guide you through the quick start installation script. But recently I found myself doing something else. As some of you might know, every time I set up Next.js, the second thing that I do is immediately add Shadcn UI design system. And I've recently found out that we can actually save us a step by initializing a brand new project using Shadcn installation script instead. So instead of running npx create next app, you can actually run npx Shadcn latest init. But instead of using latest, I would highly recommend that you use the same version that I'm currently on, 4.12.0, which is the current latest version. The reason I recommend doing this is because depending on when you're watching this tutorial, a new breaking change can be introduced in the later versions, which I have no control over. So to make this tutorial easier for you to follow, I would recommend being on the exact same version as me, so we have the exact same code base. Let's go ahead and initiate this command. Let's select a template, Next.js. Let's select no for the monorepo option, select radix for the component library, Nova for the preset, and let's go ahead and call our project Browser Automation. And now let's go ahead and let it install. Once the installation is complete, go ahead and open that project in your IDE. You might be greeted with a banner like this one. Restricted mode is intended for safe code browsing. Trust this folder to enable all features. So just go ahead and find the restricted mode button, and in here you can verify that you trust this folder. There we go. And that will enable you to manage this project and its code base completely. Once you open your project in your IDE, it's also important that you enter this project in your command line interface. If you're using the CLI, which is built into your IDE, chances are you are automatically going to be in that folder. But for those of you who are using a CLI outside of this project, make sure to do change directory and then enter the correct project. This way, if we do a command like npm run, you're not going to be greeted with script not found, but instead it's going to read from this project's package JSON and it's going to find that exact script. So just make sure that in whatever command line interface you are using, you have entered the correct project. And once you've established that you are inside of your project, go ahead and run npm run dev. What this is going to do is it's going to start this project on localhost 3000. And if you visit that in your browser, it's going to look something like this. A message project ready. You may now add components and start building. We've already added the button component for you. Clicking the button does nothing, but clicking the letter D on your keyboard will toggle between dark and light mode, which is pretty cool. They've built in that for us. So if you take a look at the app folder, page.tsx is exactly where you're going to find the code from that homepage. So project ready, and then the 2 paragraphs describing that we can now add components. At this point, I would recommend creating a new repository so that we can commit this project and start keeping track of every single change that we do. So let's go ahead and give this repository name something like Browser Automation App. I'm going to keep it private, and I'm going to click Create Repository. Once you've created a repository, go ahead and copy the second option, push an existing repository from the command line. Then let's go ahead inside of here, make sure that you have no uncommitted changes. If by any chance you do, you are going to have to do git add, and then you're going to have to do git commit with a message inside. But if you have done all the steps like I did, you are not going to have any uncommitted changes, and you will have just one commit, which is the initial commit, which was added once we run the command npx shadcn init. So the only thing you actually have to do is within this project, go ahead and paste those 3 commands. What this is going to do is it's going to push this entire project into this GitHub repository. So from now on, we can create branches, we can create commits, we can backtrack, and most importantly, we ensure that we don't lose changes to this project. Now that we have a Git repository set up, we can safely add all components from shadcn UI. So I would once again recommend using the exact version as me, which is also the same version we used to cascade this project. The reason we are adding all components at once is so that we don't waste time adding components whenever we need a new one, and so we don't have to remember this version every single time. Once we finish the project, we can easily use AI and agentic coding to simply remove all components which we are not using. So let's go ahead and execute this command in our project. After the command finishes, you might see a couple of messages like these, which are basically instructions for components which need a little bit additional setup, like adding them to the root layout. We can forget about this for now, and we can add this when we actually need this component. You can also see one information here that it skipped a button file because the file is identical. So what does that mean? Well, if you remember, inside of our app page.tsx, we already used the button component from components UI button. So that was one component which was already added for us. So now if you go inside of your UI folder inside of components, you should see a bunch of new components available here. And it's normal that some of them have some kind of lint errors. You don't really have to worry about this for now. We can easily resolve that later. So if you go ahead and just, play around with them, there is a chance some of them have some type errors or things like that. You don't have to worry about that. We are going to resolve if any of those are actually breaking our build. For now, it's just important that you have added all of these components here. So as you can see, I have 62 changes, and I would suggest, I would guess that you have a similar amount, if not exactly the same. You can even see that we have one hook added, use mobile, which is quite useful even outside of these components which have been added. But as I said, you can see that some of these files have some lint errors. We can ignore that for now. And what we are going to do is just commit these changes so that we are starting to utilize this GitHub repository, which we have just initialized. So I'm going to go ahead and do git add, git commit, and I will do feature add all shadcn UI components. As simple as that. And let's do git push. So all of that is on our main branch. And if you go ahead and refresh your GitHub repository, you will see that the latest commit is that we have added all shadcn UI components. Brilliant. That brings us to the end of this first chapter. In the next chapter, we're going to learn how to set up agentic coding for this project. Now that our GitHub repository is set up, it's the perfect time to connect it to Railway. So every push we make from here on gets deployed automatically. One thing that really sets Railway apart is that they are running on their own infrastructure instead of simply reselling AWS. That gives them much tighter control over performance, pricing, and scaling, so you can start with a single instance and grow all the way to a globally distributed deployment without the usual cloud complexity or pricing. If you'd like to follow along, you can use the link on the screen to get $20 in Railway credits on a new account. Once you've created your Railway account, head into the dashboard and create a new project. You can use the GitHub repository feature to find the new repository we just created and pushed our files into. Once you select it, it will automatically detect that this is a Next.js application and start building it. Once your app has deployed, go inside of Settings and scroll down until you find Networking. In here, you can click on the button Generate Domain and go ahead and enter 8080 for the port and click Generate Domain. That's going to create a public domain that anyone can now access. Visiting that domain will give you the exact state of the application we've had so far, along with a fully working light and dark mode toggle. From now on, every commit you push to this repository is going to be automatically rebuilt and redeployed. If for whatever reason your builds are not succeeding and have similar errors like this, rest assured that we are going to fix all of that in periodical checks throughout this tutorial. What's important right now is that you have established a connection from your GitHub repository to Railway. So regardless if your builds are succeeding or failing, rest assured we are going to have several chapters dedicated to resolving any build errors that our app might have. Now that our project and repository are set up, it's time to choose the tool which we're going to use to perform agentic coding. The tool that I'm going to be using is Claude Code with Opus 4.8. That being said, you are not required to use the same tool and model as me. If you prefer using OpenCode and their models, feel free to do so. Or if you prefer using Codex and GPT models, you can do that as well. Of course, it is preferable to use Claude Code with Opus 4.8 if available for you, because that will give you the closest output to what I will be getting throughout this tutorial. If you ever do find yourself in a position that your AI is producing significantly different output from my AI, rest assured that this entire project is open source, and every chapter that we are going to do after this one will have a corresponding branch in GitHub. So no matter where you find yourself, you will always have a way to point your AI to how the code is supposed to look like, or you can just skip that entirely and just use the branch as a checkpoint so you immediately get that code in your codebase and then continue from that chapter onwards. So don't worry, I'm doing my best to mitigate, or should I say improve, the deterministic output of this tutorial, even though we are going to be using agentic coding. As you can see from these three examples, you can run a lot of these tools inside of command line interfaces, but you are of course welcome to use any graphical user interfaces if you prefer them, or desktop tools equivalents of these apps. For example, I personally prefer using Claude Code for VS Code, which is a really cool extension which allows me to open Claude Code, as I said, the tool which I will be using, in a graphical user interface which looks like this. It's easier to read and it will be easier for you to follow along. So if you're using Claude Code and Visual Studio Code, make sure to install this extension. It's pretty neat and it will help you a lot. So let's perform our first agentic coding task. There is one problem in our codebase. I have a file called agents.md. This is a pretty standard file which a lot of coding tools use to get some necessary instructions on how to behave in this project. The problem is agents.md isn't always read by Claude Code. So what people usually do is they copy and paste this and then they rename it to Claude.md. But that can be pretty tedious to do, especially if we plan on adding changes to these files, which we actually do. So how about we create a symbolic link which basically references the agents.md inside a file named Claude.md. There is technically a way of just doing agents.md, I saw that, but why don't we just do a real symbolic link? So I'm going to go ahead and do the following. I'm going to open Claude Code. I'm going to switch to auto mode so I don't have to allow everything. And I'm just going to tell it, create a symbolic Claude.md file that references agents.md. So this will be our first prompt. If you've never done a symbolic link before or don't know how to do that, you can just ask AI to do that instead. There we go. So now Claude Code is a symbolic link which references agents.md. So if I click inside of Claude.md, you can see the exact same output inside. To test if the symbolic link actually works, I would recommend going inside of agents.md and do something like test123 and save this file. Then let's go inside of Claude.md, and if it is correctly set up, you should see that content immediately available here in Claude.md as well. And if you remove it from here, I think it should work vice versa. There we go. So you can see that whatever I type in one file is immediately available in the other file. So with this very simple prompt, we have now created a symbolic link between these two instructions. So regardless if you're using OpenCode, Codex, Claude Code, or maybe switching between all three at the same time, you will rest assured that all of your prompts will get the exact same project instructions. And these ones are pretty important, for example. So what we have in our Claude.md and Agents.md is the instruction which is now built in every new Next.js app. This is not Next.js, you know. It's basically instructing the AI to tell it to ignore its training data and instead to use the node modules inside of here. So it's telling the AI, hey, if you are ever wondering about how to do something with Next.js, don't try to use your training data, but instead go inside of here and find Next.js and find the documentation wherever they have added it, right? And then it can read the up-to-date data about this project that we are in. So that's the kind of stuff that we are going to be adding here. Now let's do our first code change, which actually alters the project. So make sure you do npm run dev and make sure the project is running on localhost 3000. And what I'm going to do now is the following. I'm going to start a new conversation and I'm going to tell it set up Sonar, which is a component which we've added through ShatCNUI, in layout, because Sonar is basically a toast component which first needs to be added to the layout file, and alter the existing page.tsx so that when we click on the button, we use Toast API. I'm using auto mode, so I don't have to approve anything manually, so you can just click here and then add that. As you can see, it immediately recognized what it has to do, so I'm just going to let it finish and then we're going to look through the code changes. This shouldn't be a big change, so that's why I'm doing it this way, because we can just take a look at the git diff and then we are going to see if it did it correctly or not. There we go, so it's finished. So I have a couple of files changed here. Layout.tsx is the first one. So what was done here is that we have a brand new import toaster from components UI Sonar, and it was rendered right beneath the theme provider. So here's what I would actually do first. It's made a mistake, and the mistake is that the toaster should be inside of the theme provider, right? I think this will still work. Let's take a look at the page.tsx. So we have toast here. It's changed this to use client, perfect. And this button now has an on click, which basically calls the toast button clicked. So if I click this, there we go, button clicked. And looks like even though it wasn't added in the theme provider, in the layout, it still works. That's interesting. So it looks like the theme provider doesn't need to encapsulate the toaster. So I'm just going to go ahead and ask AI whether this is required or not. I see the toaster component wasn't added within the theme provider. Is that necessary? I can see that regardless of this, the theme switching still works on the toast component. Is it because we are using CSS class name for theme change? So let's get an answer for this, right? Why is this working? This is what you can use AI for. Whenever you don't understand something, go ahead and ask it a question, and then we're going to see the answer. So this is how I intend to use AI in this tutorial, not as a vibe coding, but as agentic coding to speed up what we would usually do by hand. So you will see that the curriculum for this project is very similar to all other projects that I have, meaning that we are not just going to randomly prompt, finish the whole app for me. And do some weird loop and let it do its work autonomously. No, we are staying in control. You can see that I'm not satisfied with the way it rendered my toast component, so I'm asking it, is this the correct way to do so? So let's see what it answered. Right on both counts. The reason it works is because attribute class is what actually changes on the HTML tag. So what is it talking about? We have this component called theme provider, which was built in, and you can see that the attribute for next themes provider was set to class, meaning that whenever the theme changes, we don't programmatically change it using some API, we change the whole CSS attribute. I mean, we add a CSS attribute to the HTML tag. So that's why it worked. But I still think that it makes sense to render the toaster inside of here. So yes, it's not necessary, but it is semantic. So the use theme value, if ever used within Sonar, gets the real value inside. And this is how it should look at the end. So let me close this. In the layout.tsx, the toaster component should be rendered within the theme provider after the children. And the page.tsx doesn't need any changes. Let's confirm one more time that this works. There we go. So nothing has changed because it uses the class attribute to change the theme, but now it is semantically correct, and if we ever want to access the API within the toaster component, it will have the correct theme status. Brilliant! So you just performed your very first agentic coding task. Let's go ahead and commit these changes. Git add, git commit, git push. Brilliant! Amazing job, and see you in the next chapter. Now that we have our project set up ready and we've prepared the environment for agentic coding, let's go ahead and add authentication. Building this yourself means creating login screens, registration screens, consent flows, client-side logic, token validation, and user management. Realistically, months of work before you even get to your actual product. Clerk reduces all of that to a few lines of code. Using the link on the screen, you'll land on Clerk's website. Once you're there, you can click the Start Building button, which will take you to the documentation, where you can grab the agentic prompt to paste straight into Claude code. On their documentation page, you can find the prompt needed to install Clerk in your project. You can of course also find the manual setup. If you've ever set up Clerk before, you're probably familiar with this. You install Clerk Next.js package, you add the Clerk middleware to the proxy file, you then import the Clerk provider, and you add the sign in, sign up buttons, and other Clerk components. But recently, I've been seeing more and more of this trend of software as a services adding a prompt to their documentation. So you can see that it is becoming increasingly relevant for us to learn agentic coding. So let's do exactly that. I'm going to go ahead and copy this prompt, and then I'm going to go into a new session in Claude Code, and I'm going to paste it here. And whenever you copy and paste prompts, make sure to at least skim through the entire prompt to be aware of what you are instructing your agent to do. Since this prompt came from a very reputable source, we can safely run it. But it's always a good idea to simply go through the prompt to make sure that it is what you expect it to be. And in this case, it is exactly what we need, a prompt to set up Clerk within our Next.js app router project. So I am in auto mode and I'm just gonna go ahead and let it do its thing. So before it did anything itself, it actually told me what it's going to do. It's going to install or update the Clerk CLI. It's going to set up Clerk in this project, or it's going to scaffold a new app if the directory is empty. Since we are not in an empty directory, it's just going to add Clerk to this project. And then it's going to start the app with the Clerk install. Great, so this seems fine to me. And I also just want to tell you that I'm using high effort in case that is relevant to you. So I'm just gonna go ahead and say proceed. Let's take a look what happened after I let it proceed. So the first thing it did is it checked whether I have the Clerk CLI installed. Since I didn't have it installed, the first thing it did is it globally installed the Clerk CLI. After that, it attempted to run Clerk Auth login. This is where some of you might have this entire setup interrupted because you needed to open a browser and actually log in. So if that happened to you, feel free to just say proceed once again, or just tell it I have now authenticated with Clerk. Or maybe just open a brand new session and paste the entire prompt again now that you are authenticated with Clerk. So once the Clerk CLI has authenticated, you can see that it used Clerk init framework next. And it uses npm as the package manager because it recognized that that is what we are using. It successfully created a proxy.ts file, sign in and sign up pages, and it wrapped the layout with Clerk provider. Then it read through the layout and through the page, and it also detected a SHA-CN configuration, which is very interesting, and I'm going to show you why. So here's a cool thing. It added Clerk UI component, and from Clerk UI themes, it imported SHA-CN. So it added the appearance theme SHA-CN to the Clerk provider, which basically means that it has completely synchronized the theme to whatever our SHA-CN theme is. It also added the expected sign-in buttons and buttons here. My apologies, and other components here. It then ran Clerk Doctor to verify the setup, which is a very cool thing. I'm assuming it's some kind of CLI tool which just ensures that everything is as expected. And since it couldn't verify that the server was reachable, what it did is it modified the proxy.ts file such as that it added the home page as a public route. I'm assuming you have something similar like this. The end result should be a successful Clerk sign up. My apologies, setup. So now let's go ahead and read through the actual diff instead. So in the package JSON, I have Clerk Next.js and I have Clerk UI added here. Let's go ahead and check the proxy.ts. So Clerk middleware, create route matcher from Clerk Next.js server, and we have a few public routes here. So we have the sign in, the sign up, and it also added the default homepage as the public route, which is, I guess, a smart idea so we can test whether it works or not. But we're gonna see if we're gonna remove this or not. In here, it's just a regular Clerk middleware, nothing special here, and just a regular config. Great. So that is the proxy.ts file, which is located in the root of our application, as you can see right here. Next, we have a layout.tsx update. So in here we have a lot of changes. So it imported a bunch of components from Next.js, from Clerk Next.js. It imported SHA-CN from Clerk UI themes. It even imported Clerk UI themes SHA-CN.css. It also added a button here. So I have some changes here which are unrelated, which I'm guessing is just my formatting, so you can ignore that. But let's go ahead and actually focus on adding the Clerk provider here. And then it just added the show component, which only shows when we are signed out, and another show component, which is only visible when signed in. And when it's signed in, it renders a user button, and when it's signed out, it renders the sign in button or the sign up button. Very, very simple. If you want to see the full code because yours looks different, this is my entire body element. Let me even zoom in so you can see the entire HTML element. There we go. But also, source code is available, and at the beginning of this chapter, you can actually see how this chapter will be named and the branch which you have to access to see this exact code. So if yours looks drastically different or something is broken, you can simply copy the exact branch which this chapter is on, Or maybe more interesting for you to learn something, point your agent to this project's open source branch for this chapter, which I'm assuming would be 03 Auth Setup. So try and do that instead, and maybe ask your agent, how can we get to this state? And then it will tell you what are the differences and what it has to do to achieve this state. And the other things it did is it added 2 page files. Those 2 page files are inside of the app folder sign in and sign up, both with their nested folders inside. There we go, page.tsx. If you've ever set up Clerk before, you are probably aware that this is just normal Clerk setup, but we didn't have to do anything by hand. It did all of this for us. Now it's time to check if this works or not. So make sure you have your app running. So the port is actually running. This might happen to you as well. So what we can do here is just say kill port 3000, or if you know a command, you can do it yourself. There we go, port 3000 cleared. Let's go ahead and do this again. There we go, localhost 3000, and there we go. So you can see we now have a header which asks us to sign in or sign up. So if I go ahead and click sign in, there we go. I have to continue with Google to continue. And once I am signed in, I have a beautiful user button here. In one prompt, we added authentication to this project. Amazing job. Now let's go ahead and play just a little bit more with this and do something else. How about we add a test route which is supposed to be protected? So right now all of our routes are public. So I'm just going to tell it to do the following. Add a dummy page under test name which will be protected. Do not make it public in the proxy.ts. So add a dummy page under test name, which will be protected, to test if redirect works. Do not run the server. I will be testing manually. So I'm asking it to create a brand new Next.js route on the client test page, and I just don't want it to be public. So as you can see right now, I have a brand new page.tsx under the test folder inside of app. The content inside does not matter at all. So don't worry if yours wasn't generated like this. So what do we want to test now? Well, we want to test whether we can go to test. There we go. This is what I expected would happen. I'm redirected to the login screen. So no matter what I do, I cannot enter this test page unless I go into proxy.ts and add test here. If I do that, then I'm able to see the test page, but that's not what we want, okay? So I'm just testing whether everything truly works. There we go. And if I go ahead and log in again, there we go, protected test page. And if I sign out from here, I'm redirected back to the root and I cannot access the test page. Brilliant. So we can now delete this test page because we don't actually need it, and we can leave the state of the authentication as is. So even though we're not really gonna have this header, I think this is a pretty good stoppage point for us. So just like that, we've added whole authentication from one prompt. And since we are not vibe coding, we actually went through the git diff and we verified that this is what we want and that this actually works. So let's go ahead and add these changes and git push. One important thing I forgot to mention is that you should now have a .environment or .environment.local file in your project, which should now have clerk variables inside. So you should now have the next public clerk publishable key, the clerk secret key, as well as the URLs for various routes like sign in and sign up. What's important is that after you did git commit and git push is that that file isn't present here. So this file should always be in .environment, my apologies, in .ignore. And since you did the exact same setup as me, you will have this added. So it shouldn't be available in your Git repository right here. And if you go into Clerk's dashboard, you should also see a brand new application here with the name of your project. As you can see, Browser Automation is the exact name which it extracted from my package JSON. So that will be the name of your new project in Clerk 2, and this will basically be your dashboard. So it's also important that you verify that you have that as well. Your users, your organizations, your billing, your logs, and all other configuration is right here. Since we have connected Railway to our GitHub repository, every new push is going to cause a redeploy. And in my scenario here, the redeployment actually fails. I'm not sure if this is going to happen to you or not, but I do want to share the fix with you anyway. By the description of the error that was given, it looks like package lock is in some kind of conflict or it's out of sync. So the only thing I did was run rmrf node modules and package lock.json. After that, I went ahead and run npm install, and then I simply committed and then git push. And you can see that once I did that, the deployment was successful. So that was the problem if you are having the same error as me. One other thing you should add to Railway to ensure that our deployment is working are environment variables which were automatically generated using the Agentic prompt. So go inside of Variables tab, click on Raw Editor and simply paste the entire thing inside and click Update Variables and then click Deploy. And then you can test Clerk on your production instance. Now that we've added authentication using Clerk, let's also use their organizations feature to transform our project from single tenant to a proper multi-tenant B2B application. The first thing I want to do is clean up some of the things I don't like in our current authentication implementation. So because we needed to demonstrate that authentication works, what we did is we enabled the home screen to be a public route. So that's the first thing I'm going to remove. I don't want the home screen to be a public route, meaning that if I am signed out, the only route I want visible are the sign in and sign up routes. But as you can see, I have this weird header here, and that is visible on every single route because it was embedded in the layout file. So that's the first thing that I'm going to remove. And depending on what code you have, it might not be in a header, it could just be rendered in a normal div. So here's what we can do. I'm gonna go ahead and open Claude Code, and since I'm already speaking whenever I type, I might just use text-to-speech, which you can also do using this icon right here or any other app like Whisperflow, Super Whisper, or open source tools like Handy. Clean up my layout.tsx file and make sure that there isn't any auth logic inside besides the Clerk provider, meaning that I don't want any header components which use Clerk's show components or sign in and sign up buttons. All of that will be triggered from other pages, not the root layout. And here is my prompt. So exactly as I said, I don't want any auth logic inside of my layout.tsx. So I'm just going to make sure that auth is properly spelled here. The only thing I don't want changed is the Clerk provider. So I just don't want to have any header components, and I don't want to have any show components or sign in and sign up buttons. And let's go ahead and use auto mode with effort high on Opus 4.8 to do this. There we go. It says done. The app layout now contains no auth UI. The header, the show, sign in button, sign up button, user button, and unused button imports are all gone. Only the Clerk provider, which wraps the theme provider, children, and toaster, remains. So auth actions can be triggered from individual pages. Perfect. So let's take a look at our current changes. In my layout.tsx, I have removed all imports from Clerk Next.js besides the Clerk provider. I have removed the unused button component, and now what I render is just a Clerk provider, which renders the theme provider and the children with the toaster inside. To show you the actual final code, this is what it looks like. So very similar to what we had in the beginning. I just left the Clerk UI themes ShadCN CSS. I left the Clerk UI themes ShadCN and the Clerk provider because all of that is important for Clerk setup, but I don't want the actual Clerk UI to be rendered here in my root layout file because that will make it visible everywhere. This is what I wanted. So when I log in, I will then be redirected to this page right here. But obviously, we are now missing a logout button from here. So let's go ahead and add that as well. So just as we've cleaned this up, I'm now going to tell you the following. Now go ahead and clean up my page.tsx. The only thing I want rendered inside is the user button component from Clerk. Let's see if I did this correctly. So now go ahead and clean up my page.tsx. The only thing I want rendered inside is the user button component from Clerk. So I'm once again going to execute this in auto mode. This should be pretty simple. I don't want anything else rendered inside. And the reason we can safely render the user button inside app.page.tsx, let's take a look at this change here. So once again, you can see I deleted everything in here. And now it's much simpler actually. My app page.tsx, as you can see, now only renders the user button. The reason we can now safely do this is because we have modified our proxy.ts, so it no longer includes that home page inside of the public route. If we accidentally left this, then it will probably create some problems. But as you can see now, when the user is logged in, all they see is their user button. And if I sign out, I'm redirected to sign in or sign up pages. And if I try to manually go here, it redirects me back here. Perfect. So this is the setup that I actually like, that is easier for us to develop going forward rather than having to do it later. Before we add organizations, let's do one more thing. So I don't like how my sign in and sign up folders are just here standalone in the app folder. I'd like to put them under one folder so that they are grouped together. But the problem is, if we just create a brand new folder called Auth and then drag those two folders inside, that would become the part of the URL. So I would have to use Auth sign in. And that would require us to also change our .environment variables here. So let's go ahead and use something called route groups. So I'm going to go ahead and open Claude Code. I'm going to open a new conversation because this one is kind of unrelated, and I'm going to do the following. Go ahead and organize my sign in and sign up routes to all be under a singular Next.js route group, meaning you will have to use parentheses in the folder name and call that route group Auth. Looks like my pronunciation of Auth is not really good, but this is what I meant, Auth. Go ahead and organize my sign in and sign up routes to all be under a singular Next.js route group, meaning you will have to use the parentheses in the folder name and call that route group Auth. Let's go ahead and execute this and see the result. Let's go ahead and look at its thought process because I think it's really interesting. So it said, I'll take a look at the current structure of the app directory and see the sign in and sign up routes. And then what it did is the following. Let me check the docs since Claude MD warns that this Next.js version differs from what I know. And this is exactly why we added that symbolic link from agentsmd to Claude.md to instruct the whatever agent you're using that this is not the Next.js you know, meaning not the Next.js from their training data, because that can be drastically outdated. So what it did is it read from node modules next dist docs, and in here it found routegroups.md documentation, and then it implemented exactly what I wanted, an Auth folder in parentheses that doesn't affect the URLs but lets us group files like this. So if you take a look at my file structure now, I now have an Auth folder and inside sign in and sign up routes. So they were technically just moved here. But what's important is that they are in parentheses. So nothing has really changed. Everything works exactly the way it worked before. If I go ahead and try to access localhost 3000, I'm once again redirected to sign in and it works perfectly. And login also works, of course. Brilliant. So now we are ready to go ahead and focus on setting up organizations. One thing I would always recommend whenever you do agentic coding is to create checkpoints so you don't lose your files, because we just did a successful refactor of our homepage, of our proxy, of our layout, and of our file structure for the auth folder. So you can see that I have a combination of 5 staged and unstaged changes here. It's a pretty good idea for me to commit this so that my upcoming prompts don't accidentally modify what I know works perfectly fine, and so that I can always easily revert to this checkpoint if something goes wrong. So I'm gonna go ahead and do git add small auth refactor and git push. And now all of our changes are committed, so we don't have to worry about them being overridden with some other prompt that we're going to do. Whenever you use agentic coding to develop with a third-party tool, it's a good idea to make it aware of its documentation and how to use it properly, because if it doesn't have that information, it's just going to rely on its training data, or it's going to use some kind of web search, which can waste a lot of tokens if it doesn't know what to look for. Thankfully, the Clerk team has prepared skills for us to add to our AI agent. And if you're wondering what is NPX skills, it is de facto standard for distributing skills for AI agents. So you can find the exact same prompt by searching for Clerk on skills.sh website. So whether you find the prompt from here or from here, it's the exact same thing. What's important is that you are inside of your project and then go ahead and run this command. Now let's go ahead and choose which skills we're going to install. So I would recommend installing the entire core group because we're going to need all of these. Then let's go ahead and add all features as well. And under frameworks, you can just select Clerk Next.js patterns. You don't need to install the React patterns because the Next.js patterns technically includes that as well. The React patterns is more of a name if you're developing a single page application and are going to use specific Clerk React packages with Vite, for example. So you don't have to pick that, even though we are using React. And you don't have to select anything else because we're not using anything on mobile and we're not using Clerk with Expo. So just make sure you've selected all the features. For me, those are billing, organizations, and technically we don't need testing and webhooks, so you can actually remove those too. So just make sure you have billing and organization selected. Now Clerk Setup, Custom UI, CLI, Clerk Backend API, and Clerk. I think all of these are useful to have even if we end up not using them, but let's just leave them here. And then go ahead and press enter. In here, it's going to ask you for which agents you want to install this for, so just find your agent. I'm going to select Claude Code here, and down here you can find all other options. So if you're using something different, go ahead and select that. So you can find Open Code here, you can find Codex here, basically whatever is the agent which you're using, go ahead and select it. You should see a green circle next to it. Then it's asking you where to install this. I would highly recommend picking project, meaning install in the current directory so the skills are committed with your project so that whoever picks up on this project can continue developing with it with the exact same agent instructions and skills. And for the installation method, feel free to choose symbolic link, which is a single source of truth with symbolic links to all other agents for which you want to install this for. And let's go ahead and proceed with the installation. You will now have a bunch of unsaved, or should I say uncommitted changes in your project. So don't worry, all that is updates in the .claude folder and .agents folder with the exact skills which we have selected. So to make sure that these aren't interfering with the changes we are actually going to do, what I would recommend is simply committing all of them. So let's go ahead and do git commit, feat add clerk skills. As simple as that. And then git push. This way, you don't have any uncommitted changes, so they are not interfering with the changes that we are actually going to do. Now let's go inside of Claude Code, Open Code, Codex, whatever you're using, and verify that you actually have clerk skills available. So search for clerk like this, and you should now see a bunch of commands which are basically clerk skills. If you're not seeing these commands, you can go ahead and use reload skills in Claude Code, which will add new skills. And if that's still not working, you might have to close and reopen Claude Code entirely, or maybe your entire IDE if you're using an integration like I am. Let's go ahead and implement organizations now. go ahead and enable organizations in this clerk project. Go ahead and create a new page, choose-organization, which is going to render the UI for choosing an organization using clerk components. Use clerk organization skill for this task. Let's take a look. So go ahead and enable organizations in this clerk project. Go ahead and create a new page, choose-organization, let's call it organizations. Actually, no, it's organization, correct. Which is going to render the UI for choosing an organization using the clerk components. Use the clerk organization skill for this task. Let's go ahead and proceed with this prompt. Let's take a look at what it did. First, it decided it's going to use the clerk organization skill for this task, exactly as we expected. Then it explored the project structure to be aware of where it's working. Then it verified whether it can use the clerk CLI and whether we are authenticated with the clerk CLI. This is a very similar step as we did in our previous conversation where we set up clerk in the first place. So at this point, we already have the clerk CLI and we are authenticated with it. So then all it had to do is run clerk enable organizations. And that is essentially the same as us going onto the clerk dashboard and enabling organizations ourselves. Then it went ahead and created the choose organization page, exactly as I've instructed it to do so. And it also registered that new page, choose organization, in the clerk provider. And we can actually take a look at the summary down below. So first, it enabled organizations in clerk via clerk enable organizations. The membership mode defaults to membership required, exactly as we expect. So signed-in users without an organization are routed through the choose organization session task. It created the page and it put it inside of the Auth route group. So it isn't terribly important if your agent didn't do that. It's just for organization. If you want to, you can instruct it to move the choose organization page to the Auth route group to be along sign in and sign up. Rendering clerk's task choose organization component, which is the purpose-built UI for the choose organization session task, which redirects to the root on completion. Perfect. And then it wired that into clerk provider. Brilliant. This is exactly what we wanted, and there aren't that many changes actually. As you can see, we have a brand new choose-organization page, which now renders the task choose organization within a div like this. And the other thing it did is it modified the layout.tsx so that the clerk provider now has task URLs. And when it comes to choose organization, so this is an enum. So if it misspells this, you will have an error, right? So it needs to be choose organization, and it redirects to where? Well, to exactly the name which I specified for the route. Since I knew that this is an enum in clerk, that's why I chose this name. So it matches, so it makes sense, right? Brilliant. So let's go ahead and check it out now. Since I already have one account, I'm actually not sure how it's going to behave. Let's log in and see. Will it ask me to create an organization? There we go. So I'm redirected to tasks, choose organization. So I'm going to create Antonio's organization right here, and then I'm redirected to this page. Brilliant. So now let's go ahead and add one more thing. So I'm going to tell it to do the following. Now go ahead and add organization switcher just beneath the user button in page.tsx. So this way we can actually see which organization is currently active in our project. And there we go. So with just a very simple prompt, it added an organization switcher, which allows me to create another organization like this. And I can now click create organization. I can also send invites. And I can decide whether that's going to be a member or an admin. And from the organization switcher, I can always change between organizations. Just like that, we've implemented an entire B2B suite in our project. And if you go ahead and visit the organizations in your clerk dashboard, you will now see that you have those two organizations right here. You can also verify by going inside of configure, organization, settings, make sure that you have membership required set to the active option, even though that is a standard. In here, you can also find some other settings for the organizations, but for now, I would recommend leaving it as is. And before we commit, I just want to demonstrate how the sign up flow and organization creation or organization selection flow looks now in a completely new account. So I'm going to go ahead and click continue with Google, and I'm going to enter with a brand new account here, and let's see what happens. So the first thing here is the ability to join an organization that I'm actually invited to, or I can create a new organization. So this is only visible to me because I invited myself to this organization. But if I go ahead and just create my organization, you will see that instead I have an invitation here. So I have one, as in one notification, meaning that this is something I'm invited into. And now I'm part of the same organization as I am in this browser right here. And that is how we are going to implement multi-tenancy and live collaboration in the canvas. So let's go together through our changes before we commit. So first things first, the Clerk provider now has task URLs, which redirect the choose organization task to a specific route, choose organization. No new imports have been added, just a simple prop to the Clerk provider. Next, we have the actual organization switcher added to under our user button. The organization switcher is a component imported from the same place as the user button. So this is in our global page.tsx. And the last thing that's been added is inside of our Auth route group, we now have choose-organization, which has a page which renders the task choose organization from Clerk Next.js. Brilliant. So let's go ahead and commit all of this, git add, and let's do git push. After I pushed these changes to my GitHub repository, Railway did an automatic deployment and something caused it to fail. And it wasn't until closer inspection that I found a very interesting error. If you take a look at this error message, which you may or may not have, perhaps they've changed this in the future, but my error message specifically mentions .claude folder, skills, and then Clerk Next.js patterns. Now, at first, I didn't understand how could this file or folder possibly cause the deployment to fail. So I went into my code base and I found that exact folder. So inside of .claude or inside of .agents, if that's what you use, you should have Clerk Next.js patterns. And then I found this templates folder, and then it clicked for me. Inside, they have a very small replica of a Next.js application with its own package JSON. So that is probably what confused Railway or Railpacks and causes the deployment to fail. Luckily for us, the fix is very simple. All that we need to do is create a new file .dockerignore, and inside put Claude and agents. So these two folders, because agents also has the exact same templates inside. Then go ahead and commit those files. And once you push this, it's going to trigger the redeployment once again. And that will result in a successful deployment. So adding dockerignore and adding those files or folders inside skips the attempt of Railpacks to initialize that or build that as a standalone Next.js application and successfully deploys our application instead. In this chapter, we're going to develop the dashboard layout. And for that, we're going to need to do some architectural changes, but also add some design screenshots so that we can tag them into Claude Code, OpenCode, or Codex, so that we can instruct our agents exactly how we want our layout to look like. So let's go ahead and create a new folder called Design. And inside of that folder, go ahead and add all of these screenshots of the UI, which I've prepared for you. Using the link on the screen, you can access this project's open source repository. And once you are here, just make sure that you are either on the main branch or in chapter 05, which is the chapter that I'm recording right now. So obviously I don't have it yet. And then once you're here, you will be able to find the designs folder, which we are going to commit now. And while you are in the repository, go ahead and do one more thing. This is also very important because it's going to dictate the look and feel of our application. Again, make sure that you are on the main branch or in chapter 05. And once you're there, go inside of app, go inside of globals.css and copy the entire file. And then go inside of app, your globals.css, and replace it entirely. So some of the differences you're going to notice immediately are things like these little snippets that enable the pointer cursor for the buttons when they are not disabled. Other things that are different are specific colors in the dark mode, and also some general variables like radius have been changed. So just make sure that you update your globals.css according to my GitHub repository's globals.css file. Again, just make sure you're on the main branch or in chapter 05, and then go inside of app, globals.css, copy the entire thing and replace your globals CSS. And now you should have around 17 changes. Don't take my word for it, because maybe I will add more design images if I find that some are missing throughout this tutorial. What's important is that right now the only uncommitted changes you have are globals.css and then just a bunch of images, right? I'm not sure what is the exact number that I'm going to leave here. I might even remove some if we end up not using them, but just make sure it looks something like this. And using the diff viewer, you can actually see which differences you are supposed to have in your globals.css here. So it looks like I also added Clerk UI themes Shadcn.css. I've replaced the radius, and I've just replaced some of the colors in the dark mode and added this right here. So not too much, but just enough to make our app look and feel a little bit better. So I'm not really sure if we actually need this Clerk UI themes Shadcn.css, because I think we already have it here, but I think it won't hurt being here as well. I don't know. I'm going to leave it as is, and if it causes any problems, I'm going to remove it. So let's go ahead and actually do git add, git commit, and git push, so we can continue developing this chapter without having a bunch of uncommitted changes confusing us, so we don't know what is the code change and what is just some style change. So go ahead and run your app and then visit it on localhost 3000. What you should look out for is that clerk styling looks fine, so you should have the user button working, you should have the organization switcher working, and pressing the letter D on your keyboard should still switch to light mode, and clerk design should follow. So I'm pretty certain at this point that we actually no longer need this here because it's imported in globals.css. So if we actually remove this, I think everything will work just fine. But it's not causing any problems either, so I will just leave it here, and if I do notice any problems, I'm gonna remove it later, or I will just clean up with AI later. Great, so now let's go ahead and let's actually take a look at what we've added in the design here. So what I've added here are mostly some atomic design screenshots about individual elements, about sidebars, full design looks, some empty states, logs with different variants, some other empty states, specific node data looks, editor states, things like that, which will help us instruct our agent into how we want our app to look like. This isn't necessarily required. It's just so we have some kind of reference. So you don't have to look through the web to find something that you like, but you have it all here. Usually, you can do this through Figma as well, and the problem is, if you want to use Figma MCP server and connect it to Claude Code, for example, you unfortunately need a Figma paid plan, and I didn't want to do that as the default in this tutorial because I understand not many of you want to update to Figma Premium just to follow a tutorial, so because of that, screenshots are the better choice here. So let's go ahead and actually try using this design right here. No workflow selected. So what I'm going to do is I'm going to open Claude Code and I'm going to tell it the following: modify page.tsx, and make sure you pick the one in the app folder, so the root page.tsx, so that it uses empty components from components UI and it recreates the contents of no workflow selected PNG. And once again, I'm in auto mode with high effort. So let's see if it will be able to replicate that. It appears to have completed its task. Let's see if it actually looks as I've expected. There we go. No workflow selected. Select a workflow from the sidebar or create a new one to get started. That is pretty close, probably identical. Brilliant. Now let's go ahead and actually create a sidebar, once again using Chatzian components, and let's prepare the following. Not the right sidebar. This is something else. So make sure you choose the app sidebar. This is the one which we are going to recreate now. So as you can see, we are going to have an organization switcher at the top. Then we're going to have workflows section with items inside, and we're going to have a user button at the bottom. So some questions we have to answer here are, how do we display, how do we keep the data for these workflows? Because we don't yet have any database. So I'm going to instruct it to just keep a dummy array of things like this. And this button right here should collapse the sidebar to icon variant. So it will be interesting to see how we are going to develop this. The plus button can't do anything at the moment. Let's do one architectural change before we proceed, and that is by creating a new route group called dashboard. And then simply drag and drop the root page inside of that route group. This way, the URL of our root hasn't changed, but now we can maintain page within this folder right here. And also we can create a layout file inside of that folder as well. This was a problem previously because we would override this layout. But this layout is the root layout for the entire application. So we shouldn't actually add the sidebar here. Why not? Because in this root layout, there are other pages which are rendered, like choose organization, sign in, and sign up. None of those should have a sidebar. So that's why we have to create a new route group. And when you drag and drop the page inside of dashboard, it can happen that you have this weird unsaved file coming from the .next folder. This is regenerated every time you run the app, so you don't have to worry about this file at all. You can just close it and save it and forget about it. So this is a .next folder. Make sure you close it so it doesn't interfere with your work. So nothing changes now. Everything is exactly as it was before. We didn't change absolutely anything, but now we can create a layout file inside of here and then instruct the agent to develop that with the sidebar. This is how our prompt is going to look like. Create a new layout file in the dashboard route group, which encapsulates the root page.tsx. We are first giving it instructions on where this is going to be developed. Inside, cascade a new sidebar from our components UI and everything it needs to render and function properly. So this will include things like sidebar provider and the entire semantic order it needs to actually work. Develop the actual sidebar content inside a new component called app sidebar and put it in the components folder. So there is a difference between this sidebar and the app sidebar. The app sidebar will be a new component which will have the UI which we expect, right? But what's going to be inside of the layout file in the dashboard is just going to be the sidebar Shadcn composition that will allow us to render this. And we're going to maintain this in the components folder. I'm then telling it to utilize sidebar header to render clerk's organization switcher and utilize sidebar footer to render clerk's user button inside. In between, render a dummy list of workflows using sidebar items and buttons. And of course, I tell it use the app sidebar PNG as design reference. Once again, Opus 4.8 auto mode, effort high. Let's see what it comes up with. Let's take a look at the summary and then let's take a look at the actual result. So it says done, 2 files created, no type errors. First, layout.tsx, which now wraps the route group in page.tsx. It adds a sidebar provider, it renders the app sidebar, which is a new custom component, and it uses sidebar inset. Perfect. All of that is handled. So what it's saying here is basically describing how the sidebar component works, so we don't have to do anything here. And then inside of the app sidebar, it did exactly what I wanted. So it used clerk organization switcher and it added it inside of sidebar header alongside the sidebar trigger collapse button. So this is something that I didn't tell it to do. I actually forgot that, but it saw the design, and in the design, there actually is a collapse button. The sidebar content are the workflows using sidebar group label and a sidebar group action, and then a dummy workflow list. So judging by this summary, this looks great. Let's take a look at the code now. So what we have here is that we deleted the original page.tsx, right? And we moved it here into the dashboard. And then inside of the layout here, we added sidebar inset and sidebar provider from components UI sidebar. So very simple dashboard layout file. So that's the new file which was created. And then it renders the app sidebar. And this is the actual content. So use client, great. So import from React, organization switcher, user button, plus icon, a bunch of imports from components UI sidebar, a dummy list of our workflows, and then an export app sidebar. So in here we have active workflow and set active workflow. This isn't needed, and we're going to change this later. So the reason it added this is because in the design here, in the app sidebar, you can see that I have one workflow selected. So it obviously wanted to replicate that as well. Obviously, we're gonna maintain this using the URL, but I guess for now, it wants us to, if your app didn't do this, perfectly fine, not needed. There will be no use state in our app sidebar, so don't worry. Okay, let's take a look at the actual composition. So we have a sidebar, great. Then we have sidebar header. In here we have a div which renders the organization switcher. It added the hide personal prop, which is great because we don't support personal accounts. It added the appearance prop where it modified the elements like rootbox, flex1, and organization switcher trigger with full and justify between. We are going to see if this works for us or not. Next to it, we have the sidebar trigger. So that's it for the sidebar header component. Then we have the sidebar content. In here, we have sidebar group label, workflows, and then a sidebar group action plus icon. Perfect. So if you're not following, that is this right here. So this is a sidebar group label and this is a sidebar group action, a plus button. Let me keep this image open because I keep losing it. And let's see, what else do we have? So we now have sidebar group content, sidebar menu, and then using sidebar menu item and menu button, we basically have the workflow text rendered and a little is active here, which is maintained using that state, which I told you isn't really needed. If your AI didn't implement that, no worries, you don't need it here. And that's it for the sidebar content. So all of these are just closing tags. And then we have sidebar footer, which renders the user button, once again, with some appearance. I'm not sure about the show name prop. I think we're not gonna need that. So let's go ahead and take a look. Wow, this is incredible. This is so close to our picture here. Take a look. So the only thing, as I said, I'm not sure of is the fact that we are displaying the name here. I kind of don't think it looks good. And also we have this Next.js indicator here. So what we can do for that is we can quickly go, I mean, you can just ask AI to do it for you, but since it's pretty quick, just go inside of nextconfig.ts, dev indicators, and set it to be false. There we go. And then it disappears. Perfect. Wow. So this is pretty impressive. The only problem is, there we go, we have a bug. The sidebar collapse hides the entire sidebar. That's not what we want. We want it to collapse to icon mode, but we're gonna have to do something about that. Great. So I'm pretty satisfied with this. Yep, this looks fine. Perhaps we can add maybe a little bit of a gap between these elements, and I'm also going to remove this. So let's go ahead and do some of those tiny little changes by hand. So we can remove show name. I think that's the first thing I can remove, and let me take a look at how that looks like. There we go. So I'm not really sure if I really need these elements in that case, especially user button trigger. I don't think I need that. Maybe the width full, so it takes the whole space, but yeah. The other one is definitely not needed. Brilliant. Let's take a look at what else we have here. So sidebar menu. Well, perhaps we can add a class name and do something like gap y 0.5. And then there's going to be like the tiniest space between these two elements. I think that looks very, very good. Brilliant. So now I'm going to continue here and I'm going to tell it the following. The sidebar collapse button should collapse to sidebar's icon variant, meaning that it should still be visible and it shouldn't disappear completely when collapsed. There we go. So this is my prompt, and I'm just going to continue in the same conversation because it is relevant to what I want to change. Let's take a look at its changes. So it imported the workflow icon because it assumes we're going to need to render icons now when the sidebar is collapsed. Next, it added the collapsible icon prop to our app sidebar. Then it added a tooltip and a workflow icon to every single workflow rendered in the workflow in the sidebar content, because when collapsed and when you hover over it, it will show that tooltip. I'm going to show you that in a second. So it also told us one thing to be aware of. In the header, the clerk organization switcher sits next to the trigger and won't shrink gracefully into the rail. Its trigger will get clipped when collapsed. The sidebar trigger itself stays visible and functional, so collapse expand works. If you want header to look clean while collapsed, the usual move is to swap the organization switcher for just the organization logo icon visibility classes. So let's take a look at what we currently have, and then we're going to decide what to do with this. So let me refresh to see if this is something broken. Oh, there we go. Let's take a look at what happened here now. So app sidebar, we have collapsible icon, and then we have props. So I'm not really sure what is causing this error right here. Let me maybe check this here. I see. This is one thing we forgot to do when we added a tooltip. So chances are, if you told your AI to do this as well, and if inside of app sidebar, you have imported, actually, you didn't have to import anything. The collapsible icon inside of sidebar uses tooltip. And the only way tooltip can work is if it's added to the layout file, to the root layout. So we are encountering an error now. And honestly, this exact error isn't that useful. This one is super weird, but the second error is very clear. Tooltip cannot be used outside of tooltip provider. So let's go ahead and actually add this right here. And I'm just going to go ahead and go back inside of Claude code, and let's do a quick fix. So variant, actually collapsible icon makes the sidebar component use, or should I say render, the tooltip component. We never added the tooltip provider. So let's go ahead and tell it to fix that. It should be a pretty easy fix. It should just add the tooltip provider to our root layout the same way we have theme provider. So we can already open this. Let's go ahead inside of our app folder layout.tsx. So the same way we have theme provider and toaster, let's go ahead and see if it's going to add it here, or maybe it will add it in this layout, which technically works, but I would prefer it actually does it somewhere else. So there we go. Sidebar provider now wraps its children in tooltip provider. Okay, so that is not what we wanted to do. So what happens once an AI does something incorrectly? Okay, what you can do here, whether you're using Claude Code or Open Code codecs, most of them have a rewind functionality, which you can either use by invoking a command like this if you are in the CLI, or you can click on the message like this. So let me try using the rewind here. And let me go ahead and click this one, which is basically the collapsible icon makes the sidebar component use the tooltip. So I'm just gonna say continue. So what happened now? Well, what happened now is that I reverted the code that was generated in my last message, okay? So I am technically back to where I was a moment ago. So let me go ahead and add something else. Make sure to fix this in the root layout, and let's select the layout in the app and nowhere else. This time we are going to do it with more context and we're going to get a better result. So now we can confidently open the root layout file. So in here, layout.tsx, and there we go. You can see that now it has added the tooltip provider within the theme provider. So these things happen, right? You technically didn't even have to rewind. You could just told it, hey, I wanted you to add this to the root layout and not modify the sidebar component. So just in case you are a bit overwhelmed now, still nothing scary has happened. So these are our current changes. We disabled the dev indicators. Now we added the tooltip provider to the root layout file right here. We moved the page inside of the dashboard, so this technically isn't a change, but we did fill it with a very nice empty component. We have a new layout within app dashboard, which renders the sidebar composition, sidebar inset to render the children, and our custom component app sidebar. And inside of app sidebar, we added collapsible icon, which broke the app because it used the tooltip component. So now that we've added that tooltip component, we should be able to do this. There we go. So obviously not perfect, but we are getting to that point of making it look exactly how we want. So what sticks out the most at the moment is this broken organization switcher right here. I think it's easier for us to simply hide the organization switcher, so the user will have to expand to full mode if they want to change organization. So let's go inside of app sidebar here, and let's change the root box to have the following class name. We are going to target if group data is collapsible icon, and then we're going to set it to be hidden with an exclamation point like this. And once you collapse now, you can see that it is hidden. But I'm not sure if you notice, but it's not perfectly aligned. There's like a little extra space here, which it shouldn't be. You can see that this isn't exactly centered as this is. So let's go ahead and add a little class name here to fix that. What I'm going to do is I'm going to get rid of this div and just have the sidebar header directly render both the organization switcher and the sidebar trigger. And then I'm going to give the sidebar header this class name right here. So I'm basically adding the exact same class name it had before in a div. And I'm also giving it, if group data is collapsible icon, then use justify center. And then once again, if group data is collapsible icon, set the gap to 0. And then you will notice that this is now perfectly centered below this. There we go. So now we have a very, very smooth collapse and expand functionality. Great. One thing I'm still seeing is missing is a variant here, and let's set it to inset. There we go. I'm not sure if you noticed the difference, but now this has kind of like a encapsulating look. Take a look at how it looks without this. You can see it's just like a a very strict line here. But if you use variant inset, then it looks much nicer. But it does add this overflow, so let's see how we can fix that. Let's go ahead and open our dashboard layout.tsx, and let's go inside of the sidebar provider, and let's add a class name height svh, like this. And then on the sidebar inset, let's go ahead and add the following class name. And this should completely eliminate the overflow. There we go. You can see how nice and encapsulated this sidebar inset looks now. There is no overflow. I cannot scroll up and down. As opposed to what we previously had, you can see it looks weird. And you can scroll and there's no visible border. So by adding these two class names, it looks much, much better. Now let's also make sure that the user button correctly centers when collapsed. Because right now, once again, I'm not sure if you can see, but I can notice that there's too much space here, and I'm just a sucker for these details and I have to fix them. So let's go inside of the app sidebar here. Let's find the sidebar footer and let's go ahead and give it the following class name. And then let's modify two more elements in the user button appearance prop. So add this to user button trigger and this to user button outer identifier. So make sure you have these classes, and then when collapsed, you can see it's perfectly centered. Everything is aligned. Lovely. So what I don't like right now is the fact that each of my workflow has an icon. Obviously, this was added so that they can be displayed when in collapsed mode. But there are better ways of doing this. But to save the progress that we have, let's go ahead and actually commit this. So git add, git commit, feat, add, dashboard, layout and app sidebar, and git push. So we have a checkpoint for what's currently working. We have a working sidebar, we have a nice inset content here, and we even have a nice empty state. So we created a checkpoint, and now we're going to create a new prompt, which is going to modify this so it looks a little bit nicer. Let's take a look at how we actually want the collapsed state to look like. So what we saw already is the expanded app sidebar. Obviously, we want to get rid of these icons. But when the sidebar is collapsed, we actually want this to happen. We want just one workflow icon, which when clicked on opens a popover, which renders a bunch of workflows inside, as well as a button to create a new workflow. And when closed, it's just a normal icon beneath the sidebar collapse, instead of being this, right? So it's actually going to look exactly like this without all the other options. And when we click on it, it will open a popover component like that. So let's go ahead and prepare a prompt that's going to do that. The first thing I'd like to review is how our app sidebar looks at the moment. So make sure that you are inside of this component. So right now, app sidebar is a component which is responsible for maintaining the active workflow, which we said we're going to remove anyway, but still, right now, at least my version is responsible for this. So let's think. So I will now instruct it to maintain two different states. One when sidebar is expanded like this, and then another when sidebar is collapsed like this. So it's going to need to have some kind of if clause to detect when the sidebar is in collapsed mode, or it should use CSS for that, right? It's gonna have to handle something. So here's what I'm thinking. In my prompt, I actually want to include the following as well. I'm thinking of entirely getting rid of what's inside of sidebar content. So the entire sidebar group like this, and instead just rendering something like workflow navigation, a new component, and then developing that here. So a brand new function. And then this component is going to be responsible for rendering the workflows and for maintaining which workflow is active, right? Because I could just have if state is expanded here. In that case, let's return popover, right? This is just pseudocode, right? But I think you're getting the idea of what I want to do. So let me just revert that state because none of this will be exactly like this. So we are back to where we were. Let me just do this. There we go. And now let's go ahead and create a brand new prompt for this. This is the prompt that we are going to execute. Refactor the workflow list in components app sidebar so it adapts to whether the sidebar is expanded or collapsed. Pull the whole thing into a new component called workflow nav, defined in the same file. It should own both states. Use the use sidebar hook from components UI sidebar to know which state you are in. When you are in expanded, render the full list of workflows, just like now, but remove the icon from the workflow items, because right now every item has one, and I don't want any of them. When in collapsed mode, don't render the list at all. Instead, render a single button with the workflow icon. This is the only icon in the whole thing. Clicking it opens a popover containing the list of workflows, plus a button to create a new one. Don't track the popover's open state yourself, let the popover trigger handle that. And don't build custom components or write custom CSS to match the design. Just use the default popover and sidebar components that already exist. And then we pass along the design reference, which we previously showed. So collapsed app sidebar and collapsed app sidebar workflow list. And I added this because I wanted to understand that I really don't like that every workflow has the icon, but perhaps it will misunderstand this, so I might remove this part actually. So I think this is a pretty solid plan for us to do. Let's go ahead and implement this in auto mode, effort high, Opus 4.8. Let's take a look at the summary of the result. So the workflow list is now a contained workflow nav component, which is defined within the app sidebar that reads the sidebar state via use sidebar and owns both layouts. The expanded, where the full list, the full workflow list is exactly as before, but with the per item workflow icon removed. Then we have a collapsed, no list, just one sidebar menu button with a workflow icon that acts as a popover trigger. The popover holds a new workflow button, a separator, and the workflow list, so it extracted that from the design which we gave it. Notes on the constraints you set. Popover open state is handled entirely by the trigger, no state tracked in the component. Only existing popover and sidebar primitives are used, and only a few class name tweaks to override spacing. I am good with that. The active workflow state and workflow items are shared between both branches, so selection is consistent when whichever layout renders. Type check passes with no errors for the file. Brilliant! Let's take a look at the actual change. So inside of the app sidebar, it seems like we've now imported the popover components. We added sidebar separator, sidebar trigger, and use sidebar here. And we have a brand new component called workflow nav. And in here, we are using a hook use sidebar and the React use state, which maintains the currently active workflow. And in here, we render differently depending if the state is collapsed, in which we simply render a popover with a popover trigger with a sidebar menu button, and then we render a list of sidebar menu items within the popover content. Brilliant. Otherwise, if it's expanded, we do exactly what we did before. Looks like we have workflow items set in a variable, so it's only defined once, and then we reuse it depending on state collapsed in the sidebar menu here within the popover content or inside of the sidebar menu right here. Brilliant, very clean solution. And now we have actually freed the app sidebar from having to maintain all of that, and inside of the sidebar content, we just render workflow nav. Beautiful, exactly what we imagined. So let's now go ahead and take a look at how the design looks like. Perfect, this is exactly what I wanted. So tooltip is here, that's fine. we can work without it, but it might actually be useful. And when I click, we have a new workflow, we have a separator, and we have a list of elements. One redundant thing is this tooltip right here. That's definitely not needed. Let's take a look at the expanded mode. Beautiful. Perfect. So such a clean implementation of this. Let's go ahead inside of the app sidebar now, and let's just clean things up a little bit. So I can actually use the same session here, and I can just tell it one thing. Remove the tooltip for the popover content. I think that should be clean enough. Remove the tooltip for the popover content. Basically, I don't want, let me go ahead and just expand a little bit more. I don't want this to be having tooltips. So let me go ahead and maybe take a screenshot because I can't explain myself well. So no, I didn't want you to remove the tooltip for the workflows button. I want you to remove the tooltip for workflows list, which is rendered within the popover content. And then I'm going to attach a screenshot. So let me go ahead and just expand this. There we go. So now it will see the redundancy because it is redundant. There we go. So I didn't want you to remove the tooltip for the workflows button because that's what it understood it wants. Whether your agent did that or not, it's not really important, right? But I'm just explaining that I didn't want that. I wanted you to remove the tooltip for the workflow list, which is rendered within the popover content because it is redundant. So you don't have to obsess over this as much as I am. I just want to get rid of these tooltips, and let's see if it will be able to do that. Maybe we can detect it in real time. Let's see. Yes, the problem is that it has to keep it in the expanded list, but it actually, I'm not sure it needs it anywhere. Let me take a look at the workflow nav here. It thinks it needs to have the tooltip here, so it's overcomplicating now. This is the biggest problem when working on high thinking with agentic coding, because it tends to overthink. So here's what I'm just going to tell it now. We don't need the tooltip in either state. So it completely overcomplicated what is a very simple change. And yes, these things happen with agentic coding, and they can actually be reduced by noticing patterns like this and then updating your Claude or agents.md file so it can detect situations like this and just not give you so much opposition or such overcomplicating. And obviously, different models behave differently. Perhaps yours didn't do anything like this. Let's take a look now. There we go. This is something that I like. Brilliant. This is exactly how I want this to look like. So now I'm going to go ahead and just do one more thing here. So instead of workflow items here, I think in this sidebar menu, I have this gap, but in this one, I don't. So I'm just going to add it here. So I've added the class name for the popover content. So this one has the exact same tiny little gap between elements. Brilliant. I'm very, very happy with this solution right here. So now that we have this working, I actually want to completely separate this workflow nav component, which we've developed here using agentic coding, into its own file. The reason I want to do this is because workflow nav is a client component, whereas app sidebar, at least the plans that I have for it, is going to be a server component, meaning that we cannot develop both in the same file. Okay, it was easier for us to use agentic coding to develop it here, but let's actually separate them now. So I'm going to tell it to move the workflow nav component to a new location. And that location is going to be the following. So a brand new features folder, and then workflows, components, and then workflow-nav.tsx. And then remove the use client from the app sidebar. Remember to add use client to the new separated workflow nav component. So that's what we are doing. We are now separating these two components. We are putting workflow nav in a brand new location in features, workflows, components, workflow nav, and then we are removing the use client tag from components app sidebar. So the workflow nav is the one which is going to have use client because that's going to be the reactive component. So let's go ahead and submit this as well. And there we go. Created workflows, my apologies, features, workflows, components, workflow nav with use client, exporting the workflow nav and the workflows data that it owns. So I didn't ask for that because this is just dummy data, so it doesn't really matter. The components app sidebar no longer has use client. It's now a server component that imports workflow nav and only keeps the sidebar shell. Perfect. Let's take a look at this new output. So first things first, let's take a look at the changes within the app sidebar. It's much simpler now. As you can see, we just import workflow nav from its new location, and all we do is render it in the sidebar content. We no longer develop that component in here. So we got rid of a bunch of unused imports from the popover and other things. And now we should also have a brand new folder called features, workflows, components, workflow nav. And in here, we now have use client, that's important. And we now have the workflow nav component. Beautiful. So visually, design-wise, nothing is going to change, but now the app sidebar is no longer a client component, meaning that we can use it as a server component and directly access the database and load the workflows when we actually have a database to load from. So just verify that everything still works in your project. The last problem we have before we can close this chapter is the fact that the sidebar is still being somewhat in mobile mode when fully collapsed, so it disappears entirely. Workflow apps are really not possible to be developed for mobile. Technically they are, but they are never good. So in our solution, what we're just going to do is we're going to make sure that the sidebar never completely disappears. So users will be able to do this, which is enough to enable work on tablets, but on mobile, it's just not going to be as usable, and it really makes no sense to completely hide the sidebar because that just makes the app completely unusable. In order to make the sidebar behave this way, let's go ahead directly inside of components UI and then go ahead and find the sidebar component. So thanks to Shatsian UI, we can actually take a look at the contents of our sidebar. In here, find the function sidebar provider. And when it comes to the variable isMobile, simply set it to be false. Then you can also remove this unused import right here. So just make sure that the sidebar provider has been set to false. So this just by itself is not really enough. You can see that it still collapses. That is because we need to change some CSS class names in the actual sidebar component. So go ahead and find sidebar. So scroll a bit down, and after this big block isMobile, you're going to see this div, which by default is hidden and only block on medium viewpoint. Now you can completely reverse that. So make it block by default. And then if you scroll a bit down here, you will find the same thing in the sidebar container. So it's hidden by default, and only on medium viewport does it become flex. So let's change that and let's replace hidden with flex. If it's easier for you, you can just go inside of my source code and copy the sidebar.tsx component. But this should basically do it. Let me verify. There we go. No matter how small the device now, it is not going to collapse. So let's go ahead and do git add, git commit, and let's do git push. Amazing job, and see you in the next chapter. Now let's go ahead and set up a database and Drizzle ORM in our project. We're going to set up a Postgres database using Neon. Using the link on the screen, you can get on their homepage. Once you're here, I would highly recommend creating an account first. And then once you have an account, go back here and go into the documentation. The reason I'm telling you to create an account first is because once we run this one command setup, it is going to ask you to authenticate. So you need to have a Neon account ready. So just go ahead and sign up and then go back to documentation. Let's go ahead and use Neon's one command setup to add a database, schema, and even drizzle ORM to our project. So inside of our terminal, let's execute npx neon latest init. Let's select database for the option, and then let's select install with defaults, meaning MCP server and agent skills. This will also install a VS Code extension if you are inside of VS Code. And now you have to authorize the Neon CLI. So that's why I told you to create an account first. And then go back here. In here, it will output which user you are currently logged in with. Once it finishes, it's going to look something like this. It's going to tell you what it did, such as confirming whether neonctl CLI is up to date, that it added a Neon MCP server for VS Code, and that it installed some agent skills. It will then give you the next steps. Copy the following into your agent chat. If you have Claude Code opened at this moment, I would recommend restarting it. Or if you're using a visual extension like me, go ahead and do reload window. So a brand new Claude Code session opens. And then let's go ahead and copy this and add it to our agent. So paste that prompt into Claude Code, Open Code, Codex, whatever you are using. And let's see what's going to happen. If you're using Claude Code, it can sometimes be a bit careful, and it's not going to automatically do what we told it to do, and it will slightly explain that here. So it says the following: I see a Neon onboarding prompt suggesting I run neonctl init agent. Before I run anything, I want to check with you. That command kicks off Neon's cloud onboarding, linking a Neon Postgres project to your account, which is an outward-facing action I shouldn't take on my own. So it's basically being careful and just making sure that we want to do this. So what I'm going to do is I'm going to select the first option, run neonctl init. If your agent did a similar thing but didn't give you these options, you can just manually tell it, run neonctl init, or just proceed with the instructions as told, right? You don't need explanation, you don't need to skip anything, so just make sure to run neonctl init. Let's take a look at what it did. So the first thing it attempted to do is run neonctl init, and that failed because neonctl isn't installed on our machine. So what it did then is it decided to simply run it using npx. Then it loaded my organizations. Since I have a brand new account, I only have one organization. There we go, only one organization, so it will automatically use that organization. If you happen to have many organizations on Neon, it will probably ask you which one you want to use. Then it did the same with projects in this organization. Since I have no existing projects, it will simply create a new one called browser automation, which matches this directory and my package JSON. If you would have a lot of projects, it would probably ask you if you want to use an existing one or if you wanted to create a new one. And then it created a brand new project for me, as you can see here, and it updated the Neon context file with the information about the organization and the new database here. It also wrote the environment variables to environment local, and it also installed the Neon serverless driver. Brilliant. Looks like it also did a very simple select one against the database to verify that it worked. And once it verified the connection, it finalized the onboarding. And here is that exact summary. So you should have something similar. And the next question it's asking me here is, do I want to set up a schema or an ORM next. Before we proceed with setting up a schema and ORM, I want to bring something to your attention. So right now, if I try to invoke any Neon skill, it actually says I have no matching commands. That is because if you take a look at the files which were added here, we do have some skills, but they were added inside of .agents folder. So these are skills which are available to all other coding agents except Claude. Don't ask me why we don't have one standardized pattern for this, but it is the way it is. So that's why we actually can't see any of these two skills. So to fix that very easily, go back to Neon, go into Develop, and find the AI section. You can click on AI for agents. And down here in the table of contents, find Agent Skills. Then click on this right here, and that will tell you, that will show you the NPX skills for Neon database. If you want to use this page here, you should also be able to find it through here. There we go, Neon database agent skills. Okay, so let's go ahead and simply run this npx skills. Let me close this, let me close that. npx skills add Neon database agent skills, and now it's going to ask us which one we want to install. So select Neon and select Neon Postgres. Why those two? Because those are the two which have been added in our agents. Okay, so now we want to do the same for Claude Code. So that's why we want those two. Even though technically we no longer need the Neon skill because we just installed it, but still, let's keep it inside just in case. But the Neon Postgres might be the more important one. And make sure that Claude Code is selected this time. And make sure you choose the project installation scope and symbolic link, and proceed with the installation. And now you should see Claude skills for Neon and Neon Postgres. And now if you go here and if you do reload skills, ignore this, I've been testing whether I have some skills or not. You will see that for me, it says no changes because in this exact session, I actually did add Neon Postgres, but I reverted it. But for you, it might tell you that you now have one more skill. If you try, it will still not be visible until you do reload window or restart your Visual Studio Code. Try then, and there we go. You will now have Neon and Neon Postgres. So if you're using the CLI, simply restart the CLI and you will have these two available. So now that we have Neon skills installed, let's go ahead and use one of the prompts that they actually recommend. So this is really cool. At the bottom of this page that we are on, we actually have example prompts, and one of them is setup drizzle ORM with Neon. Pretty cool. Let's go ahead and try it out. So set up a drizzle ORM with Neon, and it might be a good idea to tell it to use the Neon Postgres skill. Once again, I'm in auto mode, effort high with Opus 4.8. Let's see what it's going to come up with. Let's take a look at the output of this prompt. So it detected that we invoked the Neon Postgres skill. So the first thing it did was loaded that skill. Then it inspected the current project state. And this is where I was getting a little bit worried because I didn't know where is it going to get the knowledge about the drizzle ORM because we don't have any drizzle skills, right? So I was worried that it might use some outdated training data. But look at this. Thankfully, we invoked this skill. That is exactly why they were so confident with giving us this as the example prompt. So it basically analyzed our app. We have app router, Next.js 16, no source folder, and we use Neon database serverless package, which was installed in this chapter. We didn't do it manually. We did it using npx neon init. Okay. And it also detected no drizzle yet. And then it said, let me fetch the current official Neon plus drizzle guide so I match their latest convention. And would you look at that, thanks to the Neon Postgres skill, they actually direct the agent to use this guide, which teaches the agent how to set up a drizzle ORM with Neon. Wonderful, wonderful guide here. So it had the entire plan to implement this. So it first decided that the code is going to live in the lib folder. It decided the driver it's going to use. It decided which files it's going to create. So we have lib database schema and lib database index, which exports the database util, a separate drizzle config file, some environment variables like database URL, and it even added scripts like generate, migrate, database push, and Database Studios. So the first thing it did is it installed all of the packages like Drizzle ORM, and it installed a development dependency Drizzle kit and .environment. So 3 packages in total. Then it wrote the drizzle config.ts, wonderfully I assume, and the database index.ts, and then a very simple schema. And then it created all of the scripts here. So overall, a very, very, very smooth integration here, better than I expected. Let's take a look at the actual code here. So in here we have the drizzle config.ts, which is just a usual define config. It targets our schema file in lib database schema, our out in lib database migrations, our dialect set to Postgres, and our database credentials set to be the migration URL, which is essentially reading from the environment file database URL unpooled or database URL. So yes, that was also added for us. If you do find your .environment.local, you will find the database URL and database URL unpooled, so you don't have to worry about that either. So drizzle config, definitely good. Then let's go ahead and take a look at the other file, which is inside of the lib here. So we now have database folder, and in here we have a schema. So this is our schema. It doesn't matter if yours looks like this or not, because obviously we are going to change this, but it probably did create some schema. And it also added an index.ts, which is basically just the database util, so we can basically import it if we want to import it somewhere. Brilliant. And if you take a look inside of your Neon dashboard, inside of your project here, so browser automation, that's the project I'm in, go inside of tables, and in here you will see that it has successfully pushed the migration of that new schema. So we have ID, clerk ID, email, name, created at, basically exactly what's written here. ID, clerk ID, email, name, and created at, updated at. Brilliant. So I'm very happy with this. One thing I'm not too happy about is that it automatically added migrations. Migrations are obviously the production way of doing things, but in development they cause more problems than solutions, so we are mostly just going to use database push instead of doing the whole migration. So what should you verify that you have? Remember, you can always actually look at this chapter's branch to verify things, but in the lib folder you should have a database with index and with a schema. We should also have a drizzle.config.ts file, which basically exports define config and make sure that the schema and out match the lib folder, which we verified a second ago. At this point, we already have 14 uncommitted changes. So it would be a pretty good idea to create a checkpoint by adding a commit so that we can safely develop the schema to the way we like it. So let's simply go ahead and do git add, git commit, and let's go ahead and do git push. So we are not going to need the user's schema at all. Clerk can handle the user's database. What we are going to be maintaining is the workflows table. So let me go ahead and remove everything here, and let's replace it with this. So from Drizzle ORM Postgres core, make sure you choose JSONB, PG table, text, timestamp, and UUID. Go ahead and create a new workflows table with an ID, which is the primary key, an organization ID, meaning that each workflow will be scoped to its organization, so other organizations cannot see some other organization's workflows. The name is what each workflow is going to have. The graph is going to be stored inside of a JSON field because it can be very dynamic and very modular and can change very often, and it's just easier to keep that data in a JSON field. And then some classic created at and updated at fields. And then in here, let's go ahead and do an export type workflow, which is type of workflows infer select. So just by adding this schema, we didn't exactly update our database, because in our database, we still have that users migration. So this is what I plan on doing right now. First off, go inside of the database folder, and you can just remove the migrations folder entirely, or maybe a better idea is to just clean it, okay? The reason I didn't remove the folder itself is for a very simple reason that we actually reference it in the Drizzle config, and I'm not sure what happens if that folder is missing. So what we can do here is we can add a git keep file inside of migrations. So even if it's empty, it's going to be committed, okay? Because usually when you delete all files from a folder, Git also removes the folder. If you add a little .git keep file inside, then that folder is also going to be committed. So the reason we remove the migrations is so that we can safely override the database. Let's go ahead and attempt to do this. So in package.json, it says that we have database push. So let me go ahead and do two things first. So I'm first going to try npm run database generate. There we go. So, okay, so that creates the migration file. And let's now go ahead and do npm run database push. And let's see if it's going to work. So it looks like it's asking us if workflows table is created or renamed from another table. So it looks like it's still in this migration process. So let me just try something. Let me once again go inside of migrations. And let me once again clear it entirely, except git keep. So empty migrations. And let me try just doing npm run database push. Nothing more. And now let's go ahead and just say create table. And it's asking us what we are going to do here. So we are going to drop the users table and we're going to create the workflows table. And you can just pick, yes, I want to execute all statements. There we go. And now if you go inside of your Neon database, you will now have workflows here with ID, organization ID, name, graph, created at, and updated at. Great. And we don't have the migrations here. I just think it's easier because if you keep track of migrations, which obviously you should do in production, but in development, they can just cause conflicts and then you have to resolve those conflicts, which you can now do with AI. But honestly, I think it's just easier to just do database push every time we change our schema, even though we're not going to be changing it anymore. And later in production, when you do changes, you should do migrations. But for now, it's just easier to do it this way. Now let's go ahead inside of our features, workflows, and in here, let's create a new data.ts file. In here, we can now import and descending and equals from Drizzle ORM package. And we can import our database package from lib database. So make sure that your database is actually created in the lib folder and that you have an index which exports the actual database here. Let's also make sure that we actually import workflows from lib database schema. Now let's go ahead and add a very simple list workflows which accepts an organization ID. The reason we are doing this by hand is so that we have a base, a pattern to teach AI how to create other functions for us. So that's always a good idea. When you didn't exactly specify how you want something created, first create it by hand and then use this as an example of how to create other functions using agentic coding. Now let's go ahead and highlight this function and let's open our editor. And let's make sure that we are in a new conversation. If you're using Claude Code, in Visual Studio Code, you can see that we have 7 lines selected. If you don't have this functionality, you can always manually tag data.ts like this. So I'm going to tell you to do the following. Use the existing list workflows as an example on how to build data functions. And then I'm going to tell it to create a create workflow data function that takes an organization ID and a required name and inserts a new row into the workflows table and returns it. So very simple method here of highlighting an existing function which we wrote by hand and then teaching the agent how to produce other functions based on that pattern. Obviously, this is a super simplified way of doing it, but I think you get the gist. As we move on and as our code becomes more and more complicated, this will be a very valuable skill to have. And just like that, we now have create workflow as well. Let's remove the end, which is unused for now, and let's just add an empty space at the end here. Now, if you remember from the demo, or perhaps you remember in the pictures, each of our workflows will have these automatically generated unique slugs and names. So let's go ahead and create a little helper for that. So inside of workflows, I'm going to create a new folder called lib, like this, and then I'm once again going to open Claude Code. And this is what I'm going to tell it. We can open a new chat for this because it's not exactly connected. Create a generate slug util that uses unique names generator package to return a random hyphenated name made from an adjective and an animal, like brave otter. Develop this inside. Let's just use features, workflows, and then lib folder. And that will generate a handy little helper for us, which we can then use, and you will see how we're going to use it in a second. So we should have that created any moment now. And there we go. A function generate slug, which simply returns unique names generator from the package which I told it to use, uses adjectives and animals, uses the dash as a separator, and keeps the length to 2. So that is exactly what's going to generate these cool little names like dominant, wasp, right? Brilliant. So just like we've added a data file inside of our workflows feature, let's also add actions.ts file. And in here, let's go ahead and create a brand new action, which is going to use this create workflow data function. So I'm going to go ahead and tell it to create a create workflow action server action that takes a name, gets the active org ID from Auth, and throws if there is none. Calls create workflow to create the row, revalidates the layout, and redirects to workflow ID. Develop this in actions.ts. Use the functions from data.ts. Use auth hooks, auth utils from clerk packages. Let's proceed with this prompt. There we go, exactly as we described. So it added a use server directive because this is a server action. It imported auth from clerk next.js server, and it also imported revalidate path and redirect. It imported the create workflow from our data package here, and it developed a new server action, create workflow action, which only accepts the name as the parameter because organization ID is derived from the auth tool right here. If the organization ID is missing, we throw an error, no active organization, and then we create a new workflow by passing along the organization ID and the name, which in return gives us back a workflow, which we can then use to redirect to. Brilliant. We need to call revalidate path here, even though it currently does nothing. The reason it currently does nothing is because we never used the list workflows function. So that's what we're gonna do now. So let's remember where that is. So inside of dashboard layout, we use something called app sidebar. And remember that whole requirement which I made where I purposely wanted to separate the workflow nav from the app sidebar so app sidebar can be a server component. Well, it's because of this. It's because I want app sidebar to be able to call this function list workflows. So make sure that you don't have use a client anywhere in here. In dashboard layout, there shouldn't be use client. And inside of app sidebar, there shouldn't be use client either. Okay, so you shouldn't have any use state or anything like that in the app sidebar. That's why we removed all of that inside of workflow nav, which is a client component, which is expected, which is perfectly fine. And this is the prompt that we are going to execute next to make app sidebar actually load the data. So use workflows data.ts list workflows function and add it in app sidebar.tsx and pass, maybe we should say pass the result along as a prop to workflow navigation component, replacing the dummy workflows with real data. And I also gave it the following information. The list workflows function requires organization ID. So do a simple ternary using clerk's auth function and fall back to an empty array if organization ID is not available. So if you take a look at the workflow navigation, you will see that it doesn't accept any props, right? So that's what we are going to change. And we are going to replace this workflows array as well. And I'm also going to tell it to do the following: remove the dummy active workflow, set active workflow functionality from workflow nav as well. We will implement active item later. Okay, so I don't want it to go into some rabbit hole of changing the code so that it works with real data now. Great, so I'm very confident in this prompt. So the app sidebar will now call our data.ts list workflows, which is going to return basically a list of items. Let's go ahead in full screen and let's execute. Let's take a look at the summary of the changes. Components app sidebar, it made it asynchronous, brilliant. It fetched org ID using clerk's auth, and it loaded real workflows with list workflows org ID, falling back to an empty array when there is no org ID. And then it passed the results to workflow navigation workflows prop. It modified the workflow nav to accept those same workflows, and it used the type from database schema. Brilliant. And it renders each workflow ID and workflow name. And it dropped the dummy list, and it also dropped the active workflow, set active workflow state, and it removed the unused React import. So active item highlighting is left out for now as requested. So whether you had this part or not, I don't know. I just wanted to remove it because it's dummy, and we are later going to use the URL to highlight an active item. But I think it's easier for us to actually take a look at the code rather than read about it. So instead of components app sidebar here, let's see what happens. We now imported list workflows from features workflows data. We made the app sidebar asynchronous. That's why we can't have use client. We attempt to extract org ID from await auth, which we've imported from Clerk Next.js server, and then we attempt to load the workflows by checking if we have organization ID, then await list workflows and pass in the org ID because that's what it accepts. Otherwise, fall back to an empty array. And once we got those workflows, we simply passed it as a prop to the workflow nav component. Those are all the changes in app sidebar. You can also verify that using the diff. Now let's go ahead and take a look at the components workflow nav. So in here, we now have workflow nav props, which uses workflow and then an array. So an array of workflows. And it got this type from lib database schema, which is an inferred type workflow. Now, sometimes agents don't do this. I'm very happy that our agent recognized that I actually have a workflow type inside of lib database schema, but sometimes they can actually do this. They can create their own workflow type and then give it an ID, right? Which makes no sense, and it's code smell. It's bad. So here's what you can do, and what I'm gonna do anyway, even though this worked as expected. What I'm gonna do is I'm gonna go inside of my agents.md and I'm going to add the following. You don't have to pause and copy this. You can simply use the link on the screen, or if I forgot to add the link on the screen, just go to the GitHub repository, select this chapter or the main branch, and then simply go ahead and find agents.md and copy whatever content you have inside. So this will basically instruct your agent to never handwrite custom or partial shapes for table rows, so it can always add an export and infer from the database, which is exactly what happened here. So if yours didn't do that, you can go ahead and literally give it this in your conversation. So tell it, do not make custom types, and then tell it to do this instead. And then I guarantee you it will do the right thing. Brilliant. So inside of workflow nav props, we also removed that dummy list, and we also simplified. There is no longer that logic highlighting which item is selected. So the only thing that these two now do is load items from our database and pass them here. And if you now go onto localhost 3000 and make sure that your app is running, you will notice that we have no workflows. So it's time to finally enable this plus button. We can enable the creation using a prompt like this. Modify the workflow navigation component to enable creation of new workflows by using the create workflow action from its location workflowsactions.ts. Keep in mind that this is a server action and workflow nav is a client component. It will most likely have to be passed as a prop through components app sidebar, which is a server component, which means it's compatible with the server action. Also, make use of generate slug lib from generate slug to create a unique name before passing it to create workflow action. And let's go ahead and run this prompt. Let's take a look at the output. The wiring is complete. App sidebar imports create workflow action and passes it as on create workflow to the workflow nav. Workflow now accepts that new action as a prop, and handle create workflow, which is a new function inside of workflow now, generates a unique name with generate slug before calling it inside a use transition, so is pending disables both new workflow triggers during the request. The action itself revalidates and redirects to the new workflow. Both the collapsed popover button and expanded sidebar group action now trigger creation. Let's briefly take a look at that code. So inside of app sidebar component, we import create workflow action from features workflows actions, and then we pass it to the workflow nav under the name on create workflow. Inside of workflow nav, we now accept that brand new action, and we also added use transition from React. The reason we've added this is so that we can call that function within start transition, because that will enable us to maintain the is pending state so that we can disable the button to create new workflows while one is already creating. So let's take a look at localhost now. Let's refresh and let's go ahead and click the plus button. And what happens is we are redirected to a 404 page because we never actually implemented the workflow ID. But if you delete this and go back to workflows, and my apologies, if you go back to localhost 3000, you will now see a brand new workflow visible here. And inside of your Neon database, you will now see a record has been inserted into workflows. And what's important is that it's tied to its organization ID. So if you actually go back here and switch to another organization, you will see that it's no longer available. So that is only accessible through a specific organization in which it was created. That brings us to the end of this chapter. We have successfully set up Neon, we got a Postgres database, we have Drizzle ORM set up, and we even implemented data functions and server actions, which we wired up into our app sidebar as a server component and in our workflow nav component, which is a client component. Brilliant job. You can always check out this chapter's branch on GitHub, and don't worry if the code is slightly different than mine. The goal of this project isn't to copy and paste what I do, it's to learn how to use agentic coding to your advantage. It's to learn to be in control and use AI to your advantage and not just let AI do what it wants to do. It doesn't have to be exactly the same as it produced in my code base, right? Subtle differences are completely okay as long as the functionality works and you are satisfied and understand the code that was written. So let's go ahead and do git add, git commit, and git push. After you push your changes, your Railway deployment will most likely fail. And that is because we have to update our environment variables. As you can see in this exact error, npm run build failed to collect configuration, and then in here we have the error database URL is not set. So go into your .environment or .environment.local and go ahead and copy the Neon branch, database URL, and database URL unpulled. All of these were added automatically using Neon's quick start and agentic prompts. Then head into variables, raw editor and simply add those new variables here. Click on Update Variables and then redeploy. So right now, we have the ability to load workflows from our database, and we also have the ability to create new workflows. The problem is every time we create a workflow or try to access an existing workflow, we are greeted with a 404 page. That is because this URL right here, workflows and then ID, doesn't exist in our file explorer. So we ought to create inside of the app folder dashboard route group that exact URL path, a workflows folder, and then a dynamic URL folder which will accept any workflow ID. Let's create a prompt for that. Create an individual workflow route at dashboard route group workflows and then ID in square parentheses, indicating that this is a dynamic part of the URL with 4 files. The first file is page. Page will be responsible for displaying the dynamic ID part from the URL. We are not going to implement any fetching logic, and it's a good idea to write that explicitly so it doesn't try to do that ahead of time. We're going to develop a loading file, which will simply use the spinner component from ShadCNUI. And then we're going to use error and not found, and we are going to utilize the empty TSX composition from ShadCNUI. And we can even tell it reference existing page from the dashboard to see how we did empty composition so far. Because this page right here is something that we are already familiar with. If you go back to the root page here, there we go. This is that empty composition. So let's use that to create the error, loading, and not found elements as well. So I'm gonna go ahead and execute this prompt. There we go, 4 files created within workflows ID folder. A page file, which is an asynchronous server component that awaits the params and renders the ID, no fetching. Loading is just a centered spinner. Error is a client component because that's required for error boundaries. That's a Next.js rule, and it uses the empty composition with a reset button wired. We also have a not found, which also uses the empty composition with a link back to the workflows. Brilliant. Let's take a look at these changes. So I'm going to close this. First, we have a page file. It's located inside of app folder dashboard workflows ID. So all it does is it extracts the ID from the params. Params need to be awaited. That is very important. That's why we have this right here. So a lot of training data don't include the newest version of Next.js in which you actually have to await the params. So what they usually do is they define params like this, and then they just do this. This will technically work, but it's also going to throw an error in the terminal. So make sure that your agent has created params as a promise and it's actually awaiting it. So that's all I want from the page. Make sure it's an asynchronous function so that it can await, and that's it. I just want to see the ID that I have clicked on. In the not found, what I'm expecting is something like this, just a random empty composition, workflow not found. And here we have some errors because this can be escaped. Sure, yeah, we can do that. And for example, this is an interesting thing that appears to be happening often. So I'm going to go ahead and I will tell it to do the following. This is a good exercise for us. So in notfound.tsx, you've used apostrophes, however you pronounce that, which cause the following error. And I'm going to paste the error, and then I'm going to tell it fix this, and also add a new agents.md rule to avoid doing this in the future. So this is how you update the agents MD. When you see something that's kind of annoying and the agent appears to be doing it over and over again, you can add that to the agents.md and then it's going to stop doing that. There we go. So I have this updated in my agents MD file, JSX text escaping, escape apostrophes and quotes in JSX text content, and it's basically telling it how to avoid that error. And my not found now has proper apostrophes set here. Perfect. And we also have a very simple loading, which includes a spinner and a not found. Great. So let's go ahead and try creating a new workflow now. And what should happen is this. This time we shouldn't be getting an error, but instead we should be getting the exact ID that you see in the URL. To test the error page, you can go inside of this new page.tsx and literally just go ahead and throw an error, test error like this, and then go ahead and reset this page, and there we go. This is how the error page is going to look like. And if you want to see the not found, you can go ahead and import not found from next navigation and save the file, and then go ahead and refresh again. There we go, workflow not found. The workflow you're looking for doesn't exist or may have been deleted, and clicking on go back leads back to localhost 3000. Perfect. So now let's go ahead and enable clicking on the items in this list and keeping them active when you're actually in one of the workflows. And make sure to remove the not found which we added here. So the component which we have to modify to enable the sidebar from being interactive and showing us which is the currently active workflow is workflow nav component. This is where we have to add that logic. We can achieve that with this prompt. So in the workflow nav component, make each workflow in the list link to its own page and highlight the one that is currently open. Wrap each workflow's sidebar menu button in a Next.js link using asChild prop, so that link becomes the button component, and make sure that it points to workflows and then workflow ID. Use the use pathname hook from next navigation to detect the active workflow and pass is active to that button so it shows as selected. Apply this both in the collapsed popover list and the expanded sidebar list, since both render the same workflow items. Let's go ahead and execute this prompt. And that should produce results like this. The workflow nav component should now have a link import, use pathname import. It should use the use pathname hook to get the pathname value, and then inside of the workflow nav component here, each sidebar menu button should have an asChild prop, is active prop, which is calculated by comparing the pathname to a generated URL which we expect with workflow ID injected, and then a link wrapping the span which renders the workflow name with an href workflows workflow ID. And if we go ahead and test that out, there we go. We can now navigate between our existing workflows. This seems like a pretty good place for a checkpoint, so let's go ahead and commit our changes. And then git push. What we have to develop next is the workflow shell, which should look something like this. A very big center panel where all of our nodes and the canvas in general is going to be. Beneath it, we should have a logs panel where we are going to display each of the nodes' status happening in real time. And then we're going to have a right sidebar, which will serve both as the toolbar to add new nodes and as the inspector for individual selected node. And it's also going to have some functions like run or delete this workflow. The prompt to develop this is going to be a little bit bigger than usual. So what I've prepared for you is the exact file, which you can just download or copy or paste, because I don't expect you to pause the screen and copy the whole thing. So whenever we have these longer prompts, which are mostly related to UI changes, I'm going to add them in the specifications folder right here. So make sure you are in the main branch, or simply select the branch of this chapter. Go inside of specifications, find the workflow shell, and then simply add it to your specifications right here. And these are the instructions which we are going to give. Create a workflow shell component in features workflows components folder that takes a workflow ID and is the layout shell for the workflow editor. Then render it from the workflow page.tsx located inside of the dashboard route group inside of workflows ID page.tsx. So that is currently this right here, which right now just renders the ID. Then we're going to say build all of this in one file using resizable components from Chatcn UI, meaning components UI resizable, and use rem values for every size. That is because its training data will probably tell it to use percentages, but they don't look as good when you actually do it that way, especially with zooming in and zooming out. So using rem values is actually much better. And then what we do is we basically describe exactly how this canvas is supposed to look like. The layout is a horizontal resizable panel group that fills the space size full with 2 panels and a handle between them. So we have the left panel, which is essentially this right here. That is the primary column with this specific min size. Inside is a vertical resizable panel group split into 2 panels with a handle between them. The top panel has a minimum size of 18 rem for the canvas placeholder. The bottom panel has a default size of 8 rem and minimum size 6 rem for the logs placeholder. So that is this panel right here. And then we have the right panel, which is the inspector with default size 16 rem, minimum size 14 rem, and max size 36 rem. So Antonio, where do you get these values from? I just tweaked them until they looked good. That's why I'm giving you the prompt to implement this, because it isn't really educational. It's just tweaking the values until they look and feel good. And I also instructed to put a simple label in each panel as placeholder content, so we can identify which one is the canvas, which one is the logs, and which one is the inspector. No subcomponents and no data fetching yet. So purely presentational. We just want to get a skeleton of this layout. Let's go ahead and simply run implement specifications workflow shell md, and the result should look something like this. A main canvas panel, beneath it a logs panel, and on the right side the inspector panel. And these should be resizable to their minimum and maximum values, which we have defined. Beautiful, exactly as we imagined it from the picture. I purposely didn't append this picture because then it would notice all of the cursors and it would notice all of these icons, and some agents can go crazy and just try to implement all of that. All I wanted was a simple shell, which is exactly what this prompt implemented. Let's take a look at the changes together. So the page has been modified to no longer just render the ID, but instead to render the workflow shell and the workflow ID prop. We implemented the workflow shell inside of features, workflows, components, workflow shell as instructed. Right now we don't use the workflow ID prop for anything, but we will later on. And in here we simply make use of components UI resizable component, and this is the result. There we go. Pretty clean implementation. Brilliant. So that is exactly what we wanted to achieve, and that is the perfect end for this chapter. So once again, let's make sure we create a checkpoint, git commit, and git push. Before we develop the UI, which will allow us to add new nodes into the canvas, drag them around, and connect them, it's important to understand how we're going to develop the execution logic of these workflows. This is an example workflow which we are going to be able to build once we implement the UI. So take a look at this process right here. It starts with opening a URL. Then it goes to the agent node, which is instructed to configure a Porsche 911. After that, we connect it to extract node, whose job is to extract the relevant information. And that is connected to a send email node, whose job is to send an email. These types of workflows cannot function within your normal HTTP request. Every classic request has some kind of timeout, regardless of if you're deploying on Railway, Vercel, or your custom VPS, you will be hit with some kind of HTTP timeout error, which is not something we want when developing these long-running workflows. What we need is something built for AI workflows and long-running tasks with queues, retries, and elastic scaling. And Trigger.dev is the perfect solution for what we need. Even on their landing page, you can find a use case for browser automation using Browserbase, which is exactly the way we are going to implement our functionality. Besides that, Trigger comes built in with everything you see here on the screen. And if you're still not convinced or you are unsure about using a third-party library, rest assured because Trigger.dev is open source and self-hostable. You can use the link on the screen to get on their page and create an account. Once you create your account, go ahead and create a new project. Once you set up a new project, you will see the installation wizard. This is a manual installation wizard, which is perfectly fine to use, but since we are using Agentic coding, they actually have a prompt that we can use. So let's go onto their landing page, documentation, and find the quick start. In here, you will find setup with AI. Now, Trigger's quick start is intended to be used a little bit differently in comparison to Clerks or Neons, which we've had used before. So what I would recommend is having Claude Code or whatever is your coding agent opened on one side, and on the other side, or just in a new window, have your regular terminal open. Let's go ahead and copy their prompt and paste it into Claude Code. Depending on the agent you're using, you might get a little bit of a different response, but in general, it should be something like this. It should give you a very quick summary of your current code base, and then it should tell you that you need to check whether you have a Trigger.dev account. So you have to manually tell it, yes, I have a Trigger.dev account. And this is what's going to happen next. It's going to try to run Trigger.dev latest init, but for example, my Claude Code immediately noticed that init is an interactive command, meaning that it's going to prompt the user for an organization and project selection, or if you're not authenticated, it's going to log in via browser. So it knows that it won't be able to run this itself. That's why I told you to prepare a normal terminal on the side. What I would recommend answering now is the following. Yes, I have a Trigger.dev account. I will run the setup manually and tell you once it's done, so you can review the code changes and proceed with the Trigger.dev setup. So there's no point in telling it, can you go ahead and run this command? You can see that mine has already detected that that would fail, because it will. So let's go ahead and actually run this ourselves. The first thing that's going to happen is that we are going to have to authenticate our account. Next, it's going to list our projects, so just go ahead and select whichever project you have just created. Now it's going to install the dependencies in our code base. After Trigger dependencies have been installed, it's going to ask you where you want to create the Trigger directory, and the placeholder is source Trigger. Since we are not using the source folder, as you can see, we only have the root directly here. Let's go ahead and make sure that it doesn't create one unnecessarily and just put the name Trigger inside instead. Now it's asking you to choose an example to create in that directory. If you really want to play around and explore, you can choose the scheduled task, but I'm going to choose the simple option, which is just a hello world. Before we proceed forward, I want to focus on the files it has modified or created. So first, in the package.json, we now have Trigger.dev SDK. This is the version I am on. And we also have Trigger.dev build in the dev dependencies. We have a new file, trigger.config.ts, which is basically connected to the project we have selected, as well as some max duration and retry options here, and the directory from which it's going to read long-running tasks or durable functions, which we are going to define. And then we have some updates to the tsconfig, and we have an example file inside of the Trigger folder right here. Now, here's one interesting thing. So the CLI which I used has generated this code. And I can see this import here, Trigger.dev SDK version 3. But if you actually take a look at their quick start, and if you look at critical rules, you will see the rule always import from Trigger.dev SDK, never import from SDK version 3. So that is why it's useful to use this setup with AI, even though we had to manually do a few things. So what I would recommend doing now is the following. Manual setup complete, review the files and follow the critical rules from the initial instructions. and let's see what it's going to do. Let's take a look at what happened. So it reviewed the generated files. It detected that the init worked, but both files generated and violated the critical rule. They import from version 3. So it fixed that and it just uses the SDK instead. So both of my files, example.ts and trigger config, now have the proper import. As you can see, there are no errors, meaning that that truly does work. So if I take a look at trigger, there we go. No need for version 3 because it's redundant at this point. So let's go ahead and see what it recommends doing next. Now that we have this trigger config set up, let's go ahead and actually run the dev server. So this is the command that it gave me, and it also recommends running this in its own tab because it's a long-running task. So let's go ahead and do npx trigger.dev latest dev within our project right here, and that is going to build the local worker. And now if you actually go back here, you should no longer see the installation wizard. You should instead see the very file which we developed, the command line interface developed here, visible right here. Pretty cool. So I'm gonna go ahead and respond with the following. Development server is running and the dashboard is no longer displaying the installation wizard. Instead, it's showing the registered task. Now let's follow the step 4, which it has generated for me. Obviously, if yours tells you to do something different, you can follow that instructions, but you can just follow what I do because it's the same thing, right? So I'm going to copy this payload which it has prepared for me, which is a super simple object with key message and value of hello from the dashboard. But before I do that, I just want to manually review this code right here. So this is a hello world task, which uses the task API from Trigger. Its ID is hello world. Its max duration is 300. And its run function does the following. It's an asynchronous function, which accepts a payload. It currently has a type error here. We can just turn it off or just change this to unknown if it bothers you. And then immediately once the task is run, it's going to log hello world and it's going to display the payload. And then it's going to wait for 5 seconds, once again using Trigger API, and at last it's going to return the output. So what I would actually recommend is changing this to task finished so it doesn't confuse you with the log here, and save this file. And now let's go ahead and actually run the test here. So go ahead and find your workflow here and click on test. Now in the payload here, let's go ahead and do that. Message hello from the dashboard. And down at the bottom, you can find run test. So let's see what happens. First, we have the payload visible here, hello from the dashboard. Then immediately we have a log, hello world. And then no output yet. It's not until 5 seconds pass and only then do we get the output task finished. We have successfully developed our first long-running task, which will be the base behind the entire workflow execution logic. This is, of course, a super simple example, but I think you can already see how useful this will be when we have actual long-running tasks and AI workflows with topologically sorted nodes which pass data through one another. And besides the dashboard, you will also see the output of the finished task in your terminal. Since the agent tells me that there are step 5 and step 6 we have to do, I'm just going to respond run completed successfully to see what is the next step I have to do. So the next step is to establish a trigger secret key in our dot environment. So what the agent already did for me is it actually modified my dot environment dot example. You probably don't have this and you don't need it yet. I'm maintaining this for this repository when it becomes a tutorial repository, right? So whoever clones the repository has an environment example. But what you should be looking at is the .environment.local file. And inside, I'm just gonna go ahead and prepare the following. So don't be confused, okay? So far you should have the database, neon, clerk, and these, okay? You don't need to maintain environment.example. I am maintaining that, so it's easier for me to develop this tutorial. So now let's go ahead and follow its instruction on how to obtain the trigger secret key. So in the dashboard, make sure you are in the dev environment. So let's ensure we are dev environment. Then let's go inside of the API keys. So let's see, how can we find that? There we go, API keys. And in here we have a secret key. So I'm just gonna go ahead and copy this, and then I'm going to paste it here. There we go. Just like that, we added our trigger secret key. So let's see, what do we have to do next? It added the documented placeholder. So yours probably didn't do that if you don't have a .environment.example. And then we have step 6, triggering from your Next.js backend. You are on Next.js 16, so you'll trigger the task from a server action or a route handler. The key rule is a type-only import of the task, so its code never gets bundled into your app. So in here, it's recommending something like a server action, which imports the hello world task and then executes it with a payload hello from my app. Okay, so here's what I'm going to tell it to do now. Before we do this, maybe yours already did that, it's perfectly fine. But here's what I want to do first. Is there any trigger AI tooling you can recommend for me to install? So before we proceed with building execution from our Next.js app. So what it did is it fetched the documentation from Trigger.dev. So in case yours didn't do that, or it maybe used its training data, I want to show you that you can go inside of Trigger documentation, you can scroll down and you can find building with AI. So my agent tells me that I already have an MCP server, which is okay. MCP server basically allows the connection between Claude Code and Trigger in a way that I can tell Claude Code, create a new project in my workspace or create a new organization, right? Things like that. But skills will be more useful for us because that will allow us to properly programmatically use Trigger. So because of that, I would recommend that we first focus on installing Trigger skills. So let's go ahead and go inside of our terminal here. We can close the dev running task and let's run the following command. So the skills installer is asking me which targets I want to support. So I'm going to select Claude Code. If you're using something like OpenCode or Codex, you would select agents.md. Agents.md is also going to cover like 99% of others. So let me go ahead and select these two. Now let's choose the skills we want to install. So in here we have Trigger Authoring Chat Agent, then we have Trigger Authoring Tasks, then we have Chat Agent Advanced, Cost Saving, Getting Started, and Real-Time and Frontend. So I'm going to select all of them and I'm going to press Enter. And now it's going to install those. You're going to have to do the same selection for the other option, Agents MD. And yes, this is a bit weird. It seems broken. It actually happens in almost every CLI tool that I use. Maybe it's ghosty, maybe it's my shell, but whenever I'm too zoomed in, everything seems mushed. But yeah, I just basically select everything. If for whatever reason you had trouble running their executor, you can most certainly find on skills.sh trigger right here, trigger.dev. Let's see. So we have trigger setup, trigger real-time. I would recommend having the setup, the real-time, tasks, well, all of these, to be honest. Yeah, just make sure that they are coming from trigger.dev. Okay, as long as that is the author, you can go ahead and install all of those and you will have pretty much the same thing as me. So, okay, at this point I have a lot of skills here. Let me do a quick review here. So I'm going to look at my Claude. Let's see, skills. These are the ones that I have. Okay, Trigger, Authoring Chat Agent, Authoring Tasks, Chat Agent Advanced, Cost Savings, Getting Started, Real-Time, and Frontend. So if you are adding yours individually here, I would recommend trying to find the Real-Time and Frontend. Let me see, Trigger, Real-Time. Looks like they have Real-Time. is there maybe front end? Maybe they've bundled that into one. Anyway, just use npx Trigger.dev latest skills, and then you will be able to find these ones that I have selected. If this is happening to you, like your shell looks weird, try zooming out, making the text smaller. I think that can fix it sometimes. But yeah, basically just use your arrow keys and press space to select all of them. Or maybe their skills agent, skills CLI has the ability to like select all of them. Yeah, non-interactive install. You can just use this. And then that's just going to install every skill without prompting. Perfect. So yeah, here's the solution if you are having trouble. Beautiful. So now that we have all of those skills, let me just go a little bit back here to see if there's anything useful that I can have here. Skills and MCP server. Apparently we already have the MCP server, so we don't need that. LLMs.txt. This is when you don't use skills and just want to point your agent to a web search temporarily so it gets the context. Okay, I think I am satisfied with this at this point. Let me just do, looks like there was a change in agents.md. So in here, it added Trigger.dev agent skills, and it basically instructs, it injects, so agents.md is injected into every single prompt that we do, agents.md or Claude.md. And now it added this here, which basically makes sure that whenever an agent needs to use a skill, it's going to use a skill. Okay, basically instructions on how to load the most relevant skills. Now, it's not the end of the world if yours look different, right? But this will just make it easier for agents to understand how to build a task. And that's the whole point of agentic coding, right? Of providing a few examples yourself and then letting the AI do 50 other examples so you don't have to do it, right? Or in this case, the authors are providing us with examples. Since we already have 20 uncommitted changes, I think this is a pretty good checkpoint. So I'm going to do git commit and then git push. Now let's quickly create the UI for this run button so that we can test our new trigger skills and see if we can make an agent connect a task with being executed by clicking on the run button. So let's go ahead and modify our workflow shell component. So workflow shell currently has all the panels which we need, and I want to put the run button inside of the inspector panel right here. So I'm going to highlight this part right here, which will make the 3 lines selected. If you can't do that, then just go ahead and tag the workflow shell in your editor like this. Make sure you don't tag the specification, tag the component. So I'm going to tell you the following. Separate the selected lines. If you can't select lines, then tell it separate the inspector div, right? Separate the inspector div in its own component called right sidebar.tsx, and instead of a centered inspector paragraph, render a button component with a play icon and run text. Great. So now my right sidebar is its own component, and I can click here and I have a button with a play icon inside. So if I go ahead and run my app, and if I visit localhost 3000 here and select the workflow, I should see a big run button here. So before we develop a prompt which is going to connect or wire up the right sidebar button to executing a Trigger.dev task, it's a good idea to check whether the skills are actually loaded in your agent. So try and search for something like trigger. And if it's not here, go ahead and try doing reload skills. And if that doesn't work, go ahead and reload the entire window. So then if I go ahead and search for trigger, there we go, a bunch of skills available. And now we can execute a prompt like this. Use Trigger.dev skills to create a new server action in our workflows actions file. Call that server action run workflow action, which will trigger a example task which we got when we set up trigger. Then wire up that server action to the right sidebar button. Let's go ahead and execute this. Let's take a look at the result. So first things first, in our features workflow actions, we now have the following. We now have tasks imported from Trigger.dev SDK, and we have a type hello world task imported from Trigger example. And then down here we have a new function, run workflow action, which once again validates the organization ID. It doesn't have to do that yet because we are not really fetching anything with this org ID, but why not? And then what it does is it very simply executes or should I say triggers the task called hello world. The only thing it didn't do is it didn't add any payload. So perhaps we can add some payload. Let me close this here. So I'm gonna go ahead and do something like message, and I will do hello from right sidebar. So we know it's executed from there, right? And this run workflow action was, I suppose, connected to the right sidebar. There we go, use client. And in here we have run workflow action imported. We have is pending, start transition, on run, all added to the button. And let me look at the change in the workflow shell. So, okay, in here we just have the right sidebar rendered, nothing more, nothing less. So now let me go ahead inside of here and let me do the following. I want to prepare my tasks here, or my runs. I think that might be a better idea here. First of all, my local server is not connected to Trigger.dev, so it's pretty good reminder that I need to both have Trigger.dev latest dev running and npm run dev. So make sure that you have both as well. And that should make this connected. So let's just refresh. Perfect. And now let's go ahead and click run here. And let's go ahead and refresh this, and there we go. We can now successfully execute long-running tasks and AI workflows from our Next.js application. And now just for fun, I'm going to do the following. I'm going to say use, and then I can use the / command and find trigger real-time and front-end skill to display the feedback of the task. I'm not really sure what to expect here. I think every agent will develop something different. I just want to see if the skill actually works and if it can produce some useful results here. So it looks like this is a pretty useful thing to run because it's going to install a package, Trigger.dev React hooks. So if you haven't, go ahead and just run a simple prompt with this skill. It will most likely do the same. If it doesn't, you can always instruct it to use this dependency specifically, and then it's going to do that. And let's take a look at the changes it actually produced here. So first I'm taking a look at the actions just to see if anything has changed here. So nothing seems to be changed here. Now let's look at the package JSON, and this is where we see the first change. Trigger.dev React hooks 4.5.1 has been added to my dependencies. And let me take a look at the right sidebar here. So what do we have here? There we go. So we have a new function called run status, which uses the use real-time run, and it uses the access token, handle public access token. So I'm assuming it read the skill and it knows how to set this up. Chances are yours has developed something different, right? But as long as it's anything similar to this, if you can see hooks like use real-time run, and you can see the public access token being added here, it doesn't really matter how it implemented this, because obviously we're going to modify this later. We're going to delete the whole file. I just want to make sure that, you know, we can play around and you feel comfortable playing around with agentic coding, right? It doesn't need to be the same as mine. So now in theory, we should be able to click run, and we should be getting some more useful information. Starting run, dequeued. Let's see if anything's going to update. So what does this mean? What just happened? I'm not even sure. Oh, it completed. Let me try again. Run, dequeued, executing, and then we should get completed after. There we go. So we now have real-time information here. Yours can have slightly different UI, that's perfectly fine, but I think you now get the idea that this real-time feedback is going to be important for us, because if you take a look at our canvas design here, these nodes will need to be executed one by one, right? So we are eventually going to have something like a node in progress, and that's going to look like this. So how do we make sure that whichever node is currently executing is the one that's currently highlighted? Well, exactly with a skill like trigger, real-time, and frontend. So that's why I wanted you to run this prompt, not so you have the exact code as me, but so that you at least have the React hooks package installed, right? Regardless of how your agent got to this solution, it really doesn't matter, because we are later going to rework this and make it look like it's supposed to look like by first cleaning this entire component and then starting from scratch. So don't worry at all. As long as you can actually see some real-time feedback, it should all be perfectly fine. Before we commit and push these changes, remember that we added a new variable to environment.local. So go ahead and simply add a new variable here, or just use the raw editor like this, and then add it at the end. So trigger secret key and click update variables like that. And if you want to, you can click deploy. And now let's go ahead and commit. That brings us to the end of this chapter. Amazing job, and see you in the next one. If you get an error like this on your Railway redeployment, it appears to once again be some kind of conflict in the package lock file. The fix is very easy. You just have to remove node modules and package lock, run an npm install, and then go ahead and commit that new package lock, which will eventually cause the redeployment to work. But I'm gonna go ahead and research in the meantime why this is happening. Perhaps this is only happening to me, but I'm recording just in case any of you has this problem as well. So from now on, remember, if you see npm CI and if you see mentions of package lock or something like this, remember that you just have to reinitialize the package lock file. Now that we have the basic execution logic in place, it's time to start developing the canvas component. And for that, we're going to be using React Flow, which is de facto standard for developing workflows, and it's a fully open source library. Since React Flow doesn't have an official quick start using agentic coding, nor does it maintain any official skills in the skills SH registry, what we can use instead is their LLMs endpoint. So simply append llms.txt on React Flow domain, and that's going to give you this markdown file, which is basically an instruction file for agents on how to find relevant documentation for React Flow. So we can use this instead of skills or MCP servers. Let's go ahead and once again revisit our workflow shell component. And just like we've separated the right sidebar in its own component, let's do the same for the canvas. So either use the line selection functionality. If you have that, you can see that I have 3 lines selected here. But if that's not working for you, then go ahead and tell it something like this. Separate the canvas div inside workflow shell.tsx in its own component, just like right sidebar. Do not alter the actual content of the new component. I just want to add one guardrail so it doesn't go off the rails and I don't know what it wants to implement. Let's go ahead and simply do that. After that, you should have a separate canvas component in place where this was written inline moments ago. The actual look of your app shouldn't change because we explicitly told it that the new canvas component should preserve the content that was there before. But now we have a separate canvas component which we can target for upcoming prompts. So let's go ahead and do the following. Modify the canvas.tsx component and set up a basic example of React Flow using the documentation. And then in here, go ahead and paste this llms.txt documentation. There we go. So here's what the agent produced. It set up a basic React Flow example in our new canvas.tsx component. It also installed a new dependency, xyflow react, which is React Flow 12. It also verified that there was an old package called React Flow, so that is deprecated. And we can also verify that by very quickly visiting their documentation. And yes, we can see that this is the package it's supposed to use. It replaced the placeholder content within our canvas component with a working flow. So we now have 2 connected nodes and some logic like use nodes state, use edges state, on connect, and some components like background and controls. It also turned this into a client component because it's interactive and it uses hooks, so it's mandatory. Oh, sorry, no. And it added the mandatory style.css import. It also added the size full, so it fills the resizable panel from workflow shell. That sounds pretty basic, exactly what we wanted. So don't worry if yours looks somewhat different. This is, I'm pretty sure, exactly what's written here. I'm pretty sure that's it. Just maybe slightly modified so it matches our export function canvas, and in here it's default function app. So slight modification here. Great, so in here I can see one weird thing, and that is that we are skipping the second parameter. Oh yeah, because we don't need set nodes. So if you're added set nodes, it will just be unused, I guess. So that's why this is skipped, and that's why it caught my eye. I would prefer we do like set nodes, but yeah, that's gonna throw a warning. So I'm just gonna leave it like this. We also have a very simple onConnect here, and then div class name size full, so it takes the whole space, and a very simple React flow with background and controls. Well, that's simple enough. Let me take a look at all the changes here to verify. So yes, XYFlow React package was added. Inside of workflow shell, we just rendered the canvas component. And in here, we have the entire new canvas component, which isn't really complicated, simple enough. And if I go ahead and refresh, we should see a very cool component right here called the canvas. In dark mode, it's currently broken, but if you toggle, it should look fine. Don't worry, we're obviously going to fix this and adjust it so that it works in dark mode as well. But you should have this working right now. I think their llms.txt instructs the agent to do exactly this, which is exactly what we need at this point. So great. Now let's go ahead and modify the styles of this so it matches it a bit closely to what we expect in the canvas picture right here. So let's go step by step and turn the existing canvas from this into what we would expect to see. So the first thing that bothers me, besides the obvious dark mode failure, is this connection right here. I would rather it looks like a step than this current curve that we have. So let's go ahead and from XYFlow React, import the connection line type. Then go ahead and find the React Flow component and add the following props. Connection line type and choose smooth step. Set the proper color of the stroke, so it uses our border variable, and default edge options, type smooth step, style, and once again, use the same color for the stroke. And once you save that, it should get closer to what we expect, which is this kind of step connection rather than the weird curve that it was before. Let's go ahead and add some more style props, which will change the look. So after these connection lines and default edge options, go ahead and add a style prop, which is an object. Make sure to open double square brackets and then change these 3 variables and then add a typecast as react.css properties. So this should a tiny bit more modify the values. You can't really see right now, but the border has kind of changed. This line has become thicker and some other small changes. And the last prop you should have here is max zoom. Make sure it's set to 1. Now let's go ahead and add the dark mode support to our canvas. We can do this in the existing conversation, but even if you add a new conversation, it will work equally. So this is the prompt. Add light and dark mode support to the canvas component by syncing React Flow's color mode with the app theme. Use the use theme hook from next themes package to read the current theme, and pass it to React Flow color mode prop so the canvas, edges, and controls switch between light and dark along with the rest of the app. Let's take a look at the output. The canvas now syncs React Flow's color mode with the app theme. Imported use theme from next themes and color mode from XYFlow React. Read the current theme and passed it to the color mode prop, falling back to system during hydration before theme resolves. React Flow's color mode accepts light, dark, or system, the same values Next Themes produces, so the canvas, background, edges, and controls now switch with the rest of the app. Since your background edge connection colors use the CSS variables, which we've added on purpose, so we use background and border, those already follow the theme as well. So let's actually take a look at these changes here. So we have now theme from use theme hook, which was imported from Next Themes. We also now have type color mode imported from XYFlow React. And let's see, so we now have color mode prop, which adds the theme here as a prop from here. It casts it as color mode, so it matches the type that XYFlow expects. And it falls back to system if it cannot read the value, which can happen during hydration. And just like that, we now have pretty cool looking dark mode, and switching to light mode seems to work as well. I'm just curious what happens during a refresh. Okay, so this is what I was worried about. During refresh, the hydration appears to fail. So let me confirm this a few more times. Yes, so I'm guessing yes, okay. When I refresh, it's broken, but if I toggle from this state, then it works fine. So we implemented it, but looks like there is some sync which we have to implement here because we currently have an error. So the fix for this is to add a sync external store hook, which is going to resolve the theme first and fall back to some other mode during server-side rendering and hydration. Since the prompt for that is a little bit longer, and I don't think it makes sense for you to watch and copy this whole text, you can simply go inside of the specifications folder in the GitHub repository, either in the main branch or in this chapters branch. And then let's go ahead and in the same conversation where we implemented the canvas theme, let's go ahead and say implement canvas theme.md. So these are the changes that it did. It imported use sync external store from React in our canvas component, and then it created a function called use mounted. This function use mounted simply returns the use sync external store and uses a no-op function here. It also uses some dummy unmounts here. Then in the actual canvas component, we replaced the usage of theme with resolved theme value from use theme. We then grabbed the mounted value from our use mounted hook, and then we calculate the color mode by the value of mounted. So if we have successfully mounted, meaning we have hydrated, we fall back to resolved theme. Otherwise, we fall back to light theme. And if we don't have mounted at all, we go ahead and fall back to light as well. And down here, we simply swapped the theme value and the fallback to the system to that color mode value. So the component looks like this in the end. Let me show you once again. We import use sync external store. We create a no-op function, empty subscribe. We create a function use mounted, which returns use sync external store, uses that no-op function, returns true and false respectively. And then instead of extracting theme from use theme, we extract resolved theme. And then the color mode is now calculated by using that mounted value from use mounted hook. If we are mounted, we attempt to use the resolved theme, which we cast as color mode here, or we fall back to light. And if we are not mounted, we fall back to light mode as well. And then we simply replace the color mode here to use that calculated value instead of the previous one, which we had, which fall back to system. And if you take a look now and refresh, it works. You can toggle, you can refresh, and everything will persist. Now, as you can see, we have some white flash here. So if you want to get rid of that, and if you're certain that your app will be in dark mode by default, you can change this light to dark value. And then there we go, there is no flash anymore. But then if you want to use your app in light mode, there will be a quite more noticeable flash in the other direction. So choose whichever value you want to use here. So depending on your preference, you can either leave or remove the background. I personally think it looks cleaner if we get rid of the background component, but you can choose for yourself. This way it looks empty. I like it that way. I feel like it's cleaner, but if you prefer having those little dots, feel free to leave the background component there. And now let's go ahead and stage, commit, and push our changes so we have a checkpoint and so that we can close this chapter. Now that we have the basic React Flow example ready, let's do the necessary changes so that the nodes no longer look like this, but instead are more similar to this. Now, in order to achieve this, we are obviously going to have to develop some custom node components, but it will also be a good idea for us to develop something called a node registry. You can think of that as some kind of manifest which every single node will have to satisfy. So every node will need to have a title. Every node will need to have an icon. Every node will need to have its accent color, like green, blue, red, etc. Every node will also have a type. Is it a trigger node, like start, or is it an action node, like open URL, extract, etc.? And that's also how we're going to separate them here in this right sidebar. And the reason we are developing this in that kind of registry manifest is so that we only have to develop one or two nodes ourselves in the beginning, and then we can easily point our agent and tell it, using this node registry or the manifest, develop the agent node, or develop the extract node, develop send email node. That's how you use agentic coding to your advantage without losing control of the code you want to generate. So what I've prepared for you in the GitHub repository is the templates folder. In here you will find two files. The first one is the node registry, which I was just talking about. This node registry will define the step node kind, which can either be trigger or action, the node field, node definition, and the actual node registry with all the required types for each node, which satisfy the node definition. We're also going to export some additional node types. And in my opinion, it doesn't really make sense to try and prompt to generate this, because we really cannot leave it to chance for this to be non-deterministic. It will be much easier for you to follow along if you have this manifest exactly the way it's written here. And then later, we can use agentic prompting to enhance this manifest, to add new properties to the node registry, and to use it to create new nodes. That's why I feel it makes more sense to simply inject this into our code base, because it's not really a large file, but it is very specific with its types. And that's what makes it a manifest, a definition, something we have to satisfy. And the second file I've added here is a custom step node component. The reason I added this as opposed to try and generating this is because of the class names. Chances are you and I are not gonna get the exact same class names, and it will just be annoying to follow the tutorial where you have to fight with your agent in trying to generate the exact same style of the component. So make sure that you are in the main branch, or simply find chapter 10 once it's available and use the templates folder. The reason I'm telling you to use the templates folder and not the actual features workflows where we are going to put these files is because this templates is just the initial state of these files. We're going to work and add on top of them. So I want you to have the exact version you need to have right now. That's why maybe preferably use chapter 10 branch and then get them, but using them from the main branch should work just fine. So inside of features workflows, create a new folder called nodes, and inside put the node registry component. And just ensure that you have everything that I have here. So step node kind, node field, node definition, the actual node registry, which has two nodes inside, one start trigger node, and then one open URL action node with some fields which just have a youtube.com placeholder. This exact node registry needs to satisfy the record string node definition. We need to export node type, which is a key of type of node registry from here, so we know which nodes are available. So this will result into start and open URL. And as we add more nodes, this node type will expand. And you need to have step node data and step node type. Now, obviously, we are going to improve on this, but for now, this is a perfect start. And then go inside of features, workflows, components, and in here add the custom step node component. And when you copy it from here, just make sure that you modify this import right here. So just change this to be workflows nodes like this. The reason I put this import in the templates folder is because if the import is invalid, it breaks the build. So just make sure that you have a valid import in the step node, which you put inside of features, workflows, components. So you should now have node registry inside of your features, workflows, nodes folder, node registry, and you should have step node component inside of features, workflows, components, step node. And that step node should have the features, workflows, nodes, node registry import, where it gets the node registry and it gets the type step node. And you can see how these two components are connected using their types, sharing their types, and also extracting from the node registry based on the type that this step node component data has. To not leave you in the dark, I will just quickly go over this step node component. So majority of this styling here, as you can see, when selected, add ring, rounded radius, border 2, it's just to make it look as in this picture right here, okay? That's it. A bunch of these styles are just for that. Now about this has target thing and the handle component, well, that's basically to determine whether this is a start node, which should only have one handle, or if it's an action node, which should have like an input and an output handle. So you can see that we check has target, meaning a trigger starts the flow and takes no input, so it has no target handle. So we make sure that we only render this first handle if we do have a target, right? And every other component has the other handle on the other side. And everything else you see here is just making it look like it's supposed to look like. Nothing really educational in me showing you every single Tailwind class name here. That's why I feel like it's more useful for us to just copy this template, but understand what we are copying. So now that we have these two files, step node and node registry, it's time to wire them into the actual canvas component so that they appear here instead of these default nodes. So go ahead and prepare your canvas component. One thing I forgot to tell you, which could be very useful. Remember when we set up React Flow, we weren't able to find skills or MCP service for it, but we were able to find a React Flow LLMs TXT. The problem is we have to remember to add that context every time to Claude code. So what we could do instead is we could update our agents.md or claudecode.md, whichever one you use. Since we did a symbolic link, we can just update any of those. So go ahead and prompt your Claude code something like this. So update agents MD, so that every time we have to use React Flow API components or just usage in general, we don't rely on training data, but instead we search https reactflow.dev llms.text. And the output should be something like this. It will probably have some differences, but React Flow, don't trust training data. This project uses React Flow, XY Flow React for the canvas. Its APIs, components, hooks, and props change across versions and may differ from your training data. Before writing or changing any React Flow code, fetch and consult the official LLM docs index at LLM's text, and follow the linked pages relevant to what you're building. Do not rely on memory for component names, props, hook signatures, or usage patterns. Great, I love this change. So yours should be something similar to this. It doesn't have to be word for word. So remember, every time you don't have skills available or MCPs and the only thing you have to work with is llms.text, it's a pretty good idea to add that to agents.md. So every time you reference React Flow, it will know, hey, I have to look at the documentation first and not rely on my training data, because you can't really know what data this was trained on. Now, to render the new step node component inside of our canvas, we have to do the following. I honestly think it's worth doing this by hand rather than writing a prompt, because writing a prompt would actually take longer. So first things first, make sure that you import the step node component from components step node and the type step node type from nodes node registry. Then let's go ahead and define the custom node types object here. So node types and go ahead and import node types from XYFlow React. So make sure you have that import here and simply add step node. Now let's go ahead and modify our existing initial nodes. So right now we just have 2 dummy nodes here. So we can replace this array with step node type array and just a single object inside, ID of start, type step, position XY0, and then data. Now be careful here. So type needs to be start, kind needs to be trigger, title needs to be start, and values need to be an empty object. Then let's go ahead and let's clear the initial edges, and let's go ahead and register the node types in the React flow here. And once you do that, if you go ahead and refresh your canvas, you should see your brand new node here. Since this is a trigger node, you will notice that you only have a handle on one side. It doesn't have a handle here because it's supposed to start the data flow and not accept any data flow. In your canvas component, you're now going to have one unused import, so you can remove type node from XYFlow React. This is a pretty good place for a checkpoint, so let's go ahead and commit these changes. This way you have a checkpoint for this custom nodes and node registry and all the wiring that went into the canvas. And now you can play around and you can tell your agent to do the following. Modify the canvas component so that initial nodes also render a open URL node, which we define in the node registry. And just like that, you can see how easy it is for utilize agentic coding to do the work which we would usually have to do manually, but we can now do very reliably because we implemented that manifest, the registry, right? So we can trust the code that's been generated because we have such a good base of existing code. The actual code change will look something like this. So no need for any new imports. Instead of the initial nodes in your canvas components beneath the start node, you should now have ID open URL, type step, some slight change in the position, and then the data here. Feel free to play around a bit and maybe tell your agent to create a few more nodes and maybe connect them. But after you are done, I would recommend actually just reverting the changes and making sure that the only node you have on your canvas is the start node, simply because this will be the actual look of every new workflow which is created, right? So every new workflow that gets created is gonna get initialized with a start node. And then we're gonna develop a toolbar here, which will allow us to add new nodes inside. Now that we've developed custom nodes and our node registry, let's go ahead and add Liveblocks to our project, which will enable live collaboration in each workflow room, as well as enable actual data persistence. Because right now, regardless of how many changes we do in a workflow room, if we connect some nodes, drag them around, all of that is reset when you reload the page. So we can achieve both by adding Liveblocks. Creating our own sync engine and live collaboration would take months to implement to this level. But thanks to Liveblocks, we can achieve all of this in just a few lines of code. Using the link on the screen, you can visit their page. And once you're here, go ahead and create an account. Once you create an account, go ahead and create a brand new project. I would recommend leaving the environment in development mode so that we can test it out without worrying of incurring any costs. And click Create Project. Once you've created your account, I would recommend going into their documentation page, Get Started. In here, let's go ahead and select Multiplayer as the collaboration feature we want to set up. Then, let's choose Canvases as the type of content people are going to edit. That is going to provide us with several guides. Go ahead and choose React Flow with Next.js. In here, you can follow the guide on adding React Flow and Liveblocks integration into your app. Before we add this to our project, I would recommend doing one prompt to improve our data.ts file within features workflows. What's currently missing is the function which is going to fetch an individual workflow scope to the organization ID. So we can run a simple prompt like this. Add a get workflow, organization ID and ID as the parameters to our workflows data file that returns the single workflow row matching both ID and organization ID. That should generate a function like this. And it should also add an import for the AND query from Drizzle ORM. I would recommend staging and committing this change as well as pushing it to the repository so we reduce the amount of uncommitted change we are going to have to review once we add Liveblocks. So this is somewhat of a checkpoint for us. Before we add Liveblocks to our project, I would recommend scrolling down until you find Tools, Agent Skills. And in here, you can find the command with which you can install Liveblocks Skills, which will make our agent more reliable when it comes to using and developing with Liveblocks. So let's go ahead and run this command and choose Liveblocks Best Practices. And go ahead and install this for your agent and select Project as the installation scope, and use the symbolic link as the installation method. This will once again produce a bunch of uncommitted files, so go ahead and do git add, git commit, and then git push, so you start with a clean slate and don't have to review 50 files. Remember to run reload skills and reload window so that you actually have Liveblocks skill available. Now that we've prepared our environment for Liveblocks, let's go ahead and actually add it to our project. Now, usually if we were at the beginning of our coding journey, I would tell you to simply copy this prompt. But since we already have a pretty large code base at our hands, it will actually cause more harm than good initializing this prompt. Instead, let's go through the quick start manually and then utilize Liveblocks skills to help us enhance this setup which we are going to develop right now. Let's start by adding the necessary Liveblocks packages. Once you've installed the packages, go ahead and initialize a new Liveblocks config file using the command listed below. Once you have the config generated, let's go ahead and configure it so it only holds the information which we are actually going to need. So we are not going to need pretty much any of these besides the user meta. So we can simplify this entire config so it looks like this. Our user meta object will have an ID and then an info object which holds the user's name and an optional avatar. And go ahead and save that file. Next step is to create a Liveblocks room. Now, if you are in this documentation while you are logged in, it will actually load your project which you've created, and it's automatically going to append the public API key here. Now, if yours hasn't done that, don't worry, I'm going to show you where you can find your key. But for now, let's actually just create a room using this snippet. So inside of your features workflows components, create a new file called room.tsx and simply paste the content inside. So if you can't find this public key, you can go inside of your project here, API keys, and in here you have a public key. Now let's slightly modify this room component so that besides accepting children as the prop, it also accepts the room ID. And then we can remove the hard-coded ID and actually use the dynamic prop. The next step is to encapsulate our React Flow component with that room we've just created. But I would rather we encapsulate the entire workflow shell. So go inside of your app folder, dashboard, workflows ID, page.tsx, and go ahead and encapsulate this inside of this new room component which we've just developed. So make sure you add the proper import, features, workflows, components, room, and make sure that you pass the room ID matching the dynamic ID from the params. Step 5 is to set up a collaborative React Flow diagram. In their documentation, they create a new component called Flow. But in our example, we have a canvas. So what we actually need to do is we need to transform this canvas from using our use nodes state, use edges state, on connect, and actually make it use Liveblocks flow hook instead. Let's go ahead and create a prompt that says the following: transform the canvas component hooks to Liveblocks hooks. Do not modify edges or nodes. Only change the API which is used. Desired result. And then we can just copy this part of their example so it understands that this is the only thing we are interested in. And let's go ahead and simply append Liveblocks best practices. And let's execute. Let's take a look at the changes. We removed use callback import because we no longer need it. We also removed unused imports from XYFlow React. We added use Liveblocks flow from Liveblocks React Flow. And we also added Liveblocks React Flow styles.css. I assume this was added because we appended Liveblocks best practices. If your agent didn't add that, go ahead and add it. I mean, it's a step anyway. And about the changes here, so it completely removed use nodes state, use edges state, and on connect, and it replaced it with a very clean use Liveblocks flow. And then from here with the structure, the nodes, edges, on nodes change, on edges change, on connect, and on delete. And the actual configuration for nodes and edges in this hook stayed the same. So we reused our initial nodes and our initial edges. That's also important. Make sure this wasn't modified. And the only change in the React Flow component is the wiring of the on-delete prop, which was unused before. Brilliant. So the component should now look like this. Pretty similar to what it was before, but actually a bit simplified now because we get all of our API from a single hook. In step 6, we have to render the cursors component from Liveblocks React Flow, as well as add some additional styles. So let's go ahead and do that. First things first, make sure you import cursors from Liveblocks React Flow. Then make sure that you have all 3 styles. So XY Flow style, Liveblocks React UI style, and Liveblocks React Flow styles. So you can just verify that you have all 3 here. And then inside of the React Flow, beneath or above the controls, simply render the cursors component. You can now open another Chrome browser, log in with a different user, and invite yourself to the same organization. So you can see I have 2 different users, but both of them are in the same organization. And both of them have opened the exact same workflow, and now their cursors are visible. Not only are their cursors visible, but all changes they do are visible. Obviously goes on both sides. And yes, there is a way to improve this throttle here. So what you want to do is you want to go inside of the room component, find the Liveblocks provider, and go ahead and add throttle and set it to 16 and save. And then go ahead and refresh your pages, and then you will see a much smoother experience if you want to demo it to someone. This is a pretty good spot for a checkpoint, so let's go through our files and let's commit our changes. So first of all, you should have Liveblocks config file, which has a very simple user meta object inside. You should have a package.json modification with all the relevant Liveblocks packages. You should have a page modification, which renders the room component, passes the room ID prop, and encapsulates the workflow shell, thus providing the Liveblock API inside of our canvas component. Speaking of canvas component, you should have this modification inside where we technically replace the entire local state and replace it with Liveblocks. And we also add floating cursors around so we can see who is in the room with us. And in the actual room, you should have the exact snippet which we copied from the documentation. Now, since we're using the public API key, it isn't really terrible if this leaks, but let's not give anyone the opportunity anyway to use your usage or anything like that. So let's replace this with an environment key. So it's very important that you prefix your environment key with next_public, because this will be injected in a component. And inside of Next.js, the only environment keys which can be injected like that are those with a prefix of next public. So go ahead and name this next public Liveblocks public key and then the value. And then inside of here, let's do process.environment next public Liveblocks public key. And to get rid of the error, add an exclamation point. Don't worry, we're not going to continue using this public API key. We are later going to implement proper Liveblocks authentication and organization scoping. So only certain users from organizations can access rooms and not whoever has the URL. So go ahead and git add, git commit, and git push. Remember to add the new environment variable to your Railway service so that the deployment actually works if you want to test it out or share it with your friends. So click on the raw editor, and after a trigger secret, go ahead and add next public Liveblocks public key, update variables, and click deploy. So far, we've developed a Canvas component along with a Liveblocks integration which accepts multiple participants. But there is a problem. So right now, I'm demonstrating this with two different users, both of them in the same organization. But watch this. I'm going to copy the URL of this workflow, and I'm purposely going to switch my organization. So as you can see, this organization doesn't have a single workflow, but since I know the URL, I'm just going to paste it here. And would you look at that? Even though I'm in a completely different organization, I still have access to this organization's workflow. Not only do I have access, but I can actually delete the nodes as well. So what we need to focus on in this chapter is how to scope the workflow access both in our database fetcher, but also in the Liveblocks room provider, so that only participants from certain organizations can access and modify our workflows and rooms. First, let's go ahead and protect our page.tsx, which actually renders the Liveblocks room, and the workflow shell, which eventually renders the Canvas component. So inside of your dashboard, workflows ID page.tsx. Right now, the only thing we do is we extract the workflow ID from the params. That's the only thing we do. So let's go ahead and add auth from Clerk Next.js server and not found from Next navigation. Then let's import get workflow function from our workflows data. And then let's go ahead and extract the organization ID from auth and throw the not found redirect if not available. And then let's attempt to fetch the workflow using the currently scoped organization ID and the ID of the workflow we extracted from the params. If the workflow is not found, return not found. Go ahead and double check that you have the get workflow inside of your features workflows data.ts. So get workflow first accepts organization ID and then the ID. If yours is the other way around, that's perfectly fine. Just make sure that you pass the props in the correct order. So just by adding this change, we should see a significant improvement. Go into one of your existing workflows and copy the URL. Then go ahead and create a new organization or just switch to some other one that you have. And what you're supposed to see now is this: workflow not found. The workflow you're looking for doesn't exist or may have been deleted. So make sure that you try with refresh as well. There we go. So now, unless you are inside of the proper organization, you will not be able to load that workflow. So that's one big problem solved. But somehow someone could still access the Liveblocks room ID and manually render that room and render the canvas. So we have to protect the Liveblocks room as well. You can find the documentation on how to add authentication to Liveblocks on the same page where we set up React Flow using Liveblocks and Next.js. So here at the bottom, you can click Setup Authentication and add user information. Now this specific guide isn't really tailored to Next.js, so what I would actually recommend is scrolling a bit down and finding the authentication guide for your framework. Or you could have just clicked on authentication right here, but I just want to show you how I find my way around the docs page. And in here, you can find Next.js. So let's go ahead and first install this package, and then let's add the secret key. Once you install the package, ensure that you have added the Liveblocks secret key right beneath your Liveblocks public key. Since this is a secret key, it doesn't need and it shouldn't have the next public prefix. So make sure that it's exactly as written here. Once again, if you are connected to the docs, or should I say, if you're logged in while you're reading the docs, it will automatically populate your secret key with your project. But in case you're not, you can find inside of the API keys your secret key and just copy it here and then paste it. Now we could follow the rest of the documentation manually, but remember that we have Liveblocks best practices skill, in which we actually have all of this information available and ready for our agents to consume instead. Let's go step by step and first create the auth endpoint route. Set up an authentication endpoint in API Liveblocks Auth route.ts and make it ready for ID token permissions. Use Clerk SDK for authentication utils. Use Clerk's organization ID in group IDs for organization scoped access. Only create the auth endpoint in route.ts. Do not perform any wiring or modification/creation of other files, and make sure to include Liveblocks best practices. What this should do is create a single file route.ts located in this exact folder structure. And this is the API route which was created. First, let's check the location. API Liveblocks Auth route.ts. Perfect. Now inside we have auth and current user from Clerk. We have Liveblocks from our new package. We set up a Liveblocks client. We export an asynchronous post function. We extract the user ID and organization ID, throw if either of those doesn't exist. We extract the user information, and then we use Liveblocks identify user, passing along the user ID which we extracted from Clerk, and grouping or scoping this access to an organization ID. And then we populate the user info. Now, your agent could have done this differently. For example, just full name would have been fine, but my agent decided to use a lot of fallbacks. So first it tries the full name, then it tries the username, then it tries the email address, and last it falls back to anonymous. Okay, let's leave it like that. And for the avatar, it simply uses image.url. And it returns a new response with the body and the status. So this is the only file which should have been created, and what's important is that it uses Liveblocks identify user and that it has these two parameters. One thing I don't like from this implementation is the fact that this Liveblocks client is initialized in the file. I would rather that it has its own file inside of the lib folder. So I would like to have liveblocks.ts in here. So I'm going to highlight these lines, and in the same conversation, I'm going to tell it extract the Liveblocks client initialization in its own lib liveblocks.ts so it is reusable. There we go. Now my API endpoint imports from the new lib Liveblocks, and now I can reuse this file whenever I need to access the Liveblocks client. What we have to do now is we have to wire the new API endpoint into our room component. So right now, we have Liveblocks provider, which uses the public API key, which means that the Liveblocks room isn't actually verifying whoever joins this room. We need to connect it to the endpoint which we've just created to make sure that the user has, first of all, a user ID, meaning it's logged in, and second, that it has an organization ID so that we can start scoping users to a specific organization. And the prompt for that would be the following. Wire the new API auth endpoint and then tag the room tsx. Since I'm doing this in the same conversation, I don't have to add the Liveblocks best practices skill, but if you're doing this in a new conversation, then make sure to include the Liveblocks best practices. If you want to, you can add it here as well. I think it will know that it's already loaded and then it won't do it twice, but adding the skill won't hurt. And what this should do is it should get rid of the prop public API key and replace it with the auth endpoint. And the auth endpoint should point to API Liveblocks Auth, which is the exact folder structure for our route.ts. Now, this isn't everything we have to do, and as you can see in the message that my agent sent me here, is that this right now won't work because ID token auth means that rooms are private by default. So they actually aren't joinable right now. What we need to do is we need to call get or create room, and we need to pass the group ID using organization ID, which has access to join that room. And we need to do this in a server component. And the perfect place for that is our workflows page.tsx, with which we started this whole chapter. So the prompt we can use here is wire up get or create room with org ID access and then tag that page.tsx. Just make sure it's the correct page. And this should completely finish the wiring of Liveblocks Auth to our components. So you should now have the following function: Liveblocks get or create room. Pass in the ID from the params, then open the options, set the default accesses to an empty array, group accesses scoped to this organization ID, and give it a permission of room right. The metadata is optional, but if your agent passed anything here, it won't hurt. And I like how it created this inline, because this isn't going to be reused anywhere. If yours created a separate util for that, it's fine, but you can tell it to inline directly inside of page.tsx. And it should have also added the Liveblocks import. That's why I wanted to extract that in the lib, because I knew I was going to reuse it in another server component here. And as you can see, my agent just told me the full ID token flow is now wired end to end. So we have a room component, which now uses the auth endpoint. Now that auth endpoint identifies the user and scopes it under its organization ID. And then whoever tries to visit the workflow's ID attempts to call get or create room using their organization ID, so we can check whether they are scoped to access this or not. So I'm going to show you the full 6 files which were modified so you can compare with yours. Starting with the package JSON, we have Liveblocks node package added. Then inside of our app API Liveblocks Auth, we have the route.ts, which is responsible for authenticating the user, extracting the user information, and running Liveblocks identify user scoped to the organization ID. We then have an extracted Liveblocks util in lib Liveblocks. We have a room.tsx modification where we remove the usage of public API key, and instead we use the auth endpoint, which points to our new endpoint. And last, we have page.tsx, which now protects the database access to a specific workflow scoped to the organization ID. And we use our Liveblocks util get or create room for that workflow ID scoped with the correct group access for that organization. Now let's test it out. What you should test first is 2 users who belong to the same organization and have access to the same workflows, and then try and meet each other in one workflow. Both should be able to load this Liveblocks room, and you should see each other's changes in real time. Now we already know what happens if I try to copy the URL and switch my organization. We get this error, workflow not found. But this isn't anything new. We know why this happens. It happens because of this block right here. But that isn't what we just spent a couple of minutes implementing. So let's actually hide this function, and let's hide the metadata if you have any, so you don't have errors. Because what's going to happen now is there is no longer a database protection, but only the Liveblocks protection. So let's see if this group access actually works. What happens now? So I purposely hid this block, and now I'm going to refresh in this correct organization where everything should still work fine. But what happens in this other user? If I refresh, as you can see, I no longer get that not found, but if I click on the error here, you will see that correctly Liveblocks has responded, you have no access to this room. That is because the auth endpoint has failed, because this user is currently scoped to a different organization, meaning that it shouldn't be able to load this Liveblocks room. So our ID token actually works. Brilliant. And now we can, of course, revert these changes. So we have both the database level protection and the Liveblocks cloud level protection using ID token auth. So go ahead and commit all of these changes so we have a clean slate for the next feature we have to develop. Even though our current implementation works as expected, there is one problem when it comes to preserving the data in Liveblocks about these rooms and everything inside of them. As you can see, as we developed our Liveblocks implementation, at first we had some public rooms, and then once we've implemented ID token access, we now have restricted rooms. But as you can see, still all of these rooms are restricted to the same organization ID default. Even though their definitions sound similar, organizations or groups serve 2 different purposes. groups are used to decide who has access to a room, whereas organizations are used to scope where Liveblocks data and resources should be stored. This isn't immediately obvious, but Liveblocks is also its own database. And when you click on a room, you will see that they have several data tables here, like comments, document, metadata, etc. If you go inside of document and select Liveblocks storage as the option, you will actually see React Flow object inside. So that is why it's important to compartmentalize in the proper organization ID so that sensitive data isn't held in one shared pool with all other rooms in your database. Luckily, we can achieve this very easily in just a few lines of code. First, go inside of your Liveblocks Auth endpoint, and when you identify the user, also append the organization ID. And then go inside of your page where you invoke get or create room and do the same here. I would recommend going inside of your Liveblocks dashboard and actually deleting the existing rooms at this point, just to ensure that no conflicts are created. Then once you have a clean slate, go ahead and visit your app at localhost 3000. Go ahead and click on any of the workflows or simply create a new one. Nothing much should change in the UI, but if you take a look at the Liveblocks dashboard, you will now see that the resource is properly scoped to this organization. And if it says default here, just go ahead and give it a refresh, and then it's going to load the actual organization to which this is scoped. In the organization's documentation page, we can find the recommendation on how to refresh Liveblocks initialization whenever an organization needs to change. What they recommend is simply invoking location.reload. Even though I wasn't really able to encounter any stale information, as I can see, everything works just fine. So the problem in theory should be if you refresh and load the initial page in this scenario, right? So no workflows, and then switch to a proper organization and click on the one which we've created previously. In theory, sometimes it can happen that a stale organization ID gets access here. So if you want to prevent any chance of that happening, you can revisit your app sidebar component, find the organization switcher, and go ahead and give it the following props. What this is going to do is it's going to refresh the page every time an organization changes, an organization is left, or an organization is created, meaning that it's going to invoke this location.reload, increasing the chances, or should I say reducing the chances of an organization ID being stale. So now that all of the authentication and organization scoping logic is wired, let's fix one more issue. When I switch between my workflows, I can see that there are two different loading states. The first one is a spinner, and then the second one is just a text loading. That is because we have two loading states. The first loading state is invoked from the page.tsx in our workflows ID page. The loading state is invoked every time we await something. So that spinner first loads auth, then it loads get workflow. And then once the room loads, we render the fallback, and that's where the loading text appears. So go ahead and change that fallback to render a spinner from components UI spinner. So make sure you add this import and render this div, which makes it full screen and centered. And that will essentially make it look the same as our loading component here. And then if you try, you will see that it kind of twitches, but it looks much better than the previous example we've had. Let's review these 4 modifications we've done. We've added organization ID to our Liveblocks Auth route when we identify the user. We've done the same in the workflows ID page when we do get or create room. We've added these 3 props to the organization switcher, and we modified the room component so that the fallback renders a spinner rather than the loading text. Remember that we also added a new environment variable key, so go ahead inside of your Railway, click on raw editor, and add Liveblocks secret key update variables. You don't have to redeploy because now we're going to commit. Actually, you do have to click deploy to apply the change. My apologies. So click deploy anyway. And then go ahead and stage, commit, and push your changes. The collaboration feature in our project is starting to shape pretty well, but we are still missing a few features. So far, we were able to see the other person's cursor, but we didn't see their name attached to the cursor. We also didn't add the avatar stack, which displays the images of all users who are in the room with us. So let's implement that in this chapter. First, let's modify our canvas component. Then import panel from XYFlow React. Next, import avatar stack from Liveblocks React UI. And the last thing we have to do is render that panel with a position of top right and avatar stack inside. And once you save and revisit any of your workflows, you will now see an avatar stack at the top right corner. The problem is there is no user information. All users will be presented as anonymous. In order to fix the issue in which all of our users in the room are scoped as anonymous, I would like us to go and search for the component which we are using. So avatar stack. In here, you will find information on how to use it, which we just did, but scrolling a bit down will also instruct you on how to add the user information. So the prop which we need to use is resolve users. Let's run the following prompt. Add a post endpoint at API Liveblocks users route.ts that takes user ID's payload and returns their display info, which is name and avatar in the same order. And put null for unknown ones. Resolve them from clerk. Require an authed user and organization. Only develop the route.ts file. Do not modify other files. And I've included Liveblocks best practices and clerk backend API skill. Let's review what the agent has created. So I have a new route inside of my Liveblocks folder, inside of the API folder called users. Now I'm going to read through the description of what the route does. First, we have an auth gate, which reads auth and returns 401 unless there is both user ID and organization ID. Next, we have input validation. So this is something that sometimes the agent will do, sometimes it won't. So if you don't have a snippet like this, but instead maybe you just have user IDs extracted from request.json, that's honestly okay. Next, it appears that we iterate over those user IDs, we check if they are empty, and then we return back an empty array so we don't unnecessarily compute or initialize any clients. Then we initialize clerk client, and we get the user list using the IDs which we got from our payload. We also scope the organization ID to ensure that this endpoint cannot be abused by someone just wanting to get a list of users using their IDs. We also assign the limit to the ID's length limit, and then we map each user by ID in this exact format, and then we resolve each user's information. So I can't really guarantee that your agent will produce the exact same code, but I assume it's going to be something similar to this. What's important is that you in the end have something resolved which produces an object like this. Basically an object with a name, with an avatar, inside of an array. And if it wasn't able to resolve it, it falls back to null. Basically, it matches the user info which we extracted from our global Liveblocks interface, user meta info. So that is generated in Liveblocks config.ts. Now, just in case your API route looks wildly different from this one, remember that you can always go ahead and find chapter 13 and go inside of app API and find the exact route. So now we have to wire in that new endpoint into the resolve users prop. We can achieve this with a simple prompt. In the room component, add a resolve users prop to the Liveblocks provider, inline in the prop. It should post the user IDs to our API Liveblocks users endpoint and return the parsed response. If the request fails, return undefined. And that should produce an output similar to this. You should now have a resolve users prop attached to your Liveblocks provider, which is an asynchronous function which extracts the user IDs who are in this room. It opens a try and catch block, and inside of the try block, it attempts to fetch the API Liveblocks users and passes the user IDs as the body payload. If the request fails, we return undefined. If something else fails, we also return undefined in the catch. Otherwise, we simply await response.json. And now go ahead inside of your localhost 3000 and refresh your workflow. And if we've done this correctly, we should now see the user avatar here and the name of the logged in user. And if you try joining with two different users, you will now see the actual name of each user next to their cursor. And in the top right corner, you will see the name of users inside of this room. So after all of these prompts, you should have one new route and two modifications to existing components, the canvas and the room. Let's go ahead and commit stage and push these changes. Now that we've added collaboration to our workflows, let's focus on the right sidebar component. The right sidebar component will have several purposes. The default one is the toolbar. The toolbar is going to display two categories of nodes, triggers and actions. Clicking on the node will simply add it to the canvas. The second purpose of the right sidebar is the editor. Whenever a user selects a node from the canvas, we're going to automatically switch to the editor and display that node's information. From here, user will be able to modify the node data. To speed up development of this component, I've prepared a template in our GitHub repository. The template only focuses on the UI and avoids adding any business logic. Instead, that's what we're gonna focus this lesson being on. So we learn how to add the actual functionality to the component rather than you watching me type 1,000 class names and copy after me. Once you're in the repository, you can either use the main branch or preferably go and find chapter 14 workflow toolbar, and then go ahead and find the templates folder. In here, you will find a new component on top of the two existing ones that we've had, called right sidebar. Now go inside of your existing features, workflows, components, right sidebar, and replace the entire content inside with the template. As I've said, the template exclusively focuses on the UI. As you can see, writing this together honestly wouldn't be too educational. You would just have to pause the video all the time and then copy a bunch of these class names. They are nothing more than compositions of Shatsy and UI components. I've also written descriptive comments so we understand exactly what each of these components is doing, and we're gonna go over the entire thing together. But first, let's see what actually renders now. As you can see, our right sidebar component now has the toolbar, which reads from our node registry and displays the correct nodes. It also separates them in their correct categories. We also have the editor tab, which we're going to wire in so that when we click on a node, it's loaded here and we can change its data. We also have a run button at the top, as well as a drop-down with an option to delete the workflow. None of these actions buttons do anything, but that's what we're going to focus on in this chapter, enabling the right sidebar component. Let's go over the source code of this component to understand what we are working with. The first function we have is the node icon. Node icon is used to display the icon inside of an accent color. So exactly what you see here in the start and open URL. The actual icon, as well as the accent, is extracted from the node registry, which matches the type which was passed for that node icon. So node registry is a very important component in this project because it's the manifest. It is the source of truth for all nodes. So later, when we point our agent and tell it to create 50 new nodes, all it's going to have to do is modify the node registry, and the right sidebar component, for example, will automatically load all of those nodes and their respective icons and their respective accent colors. Next, we have the section component. The section component is this right here. So either toolbar or editor. But it also has the option to display an icon if needed for this scenario. When we select a node in the canvas. So then we will be able to display its name as well as its icon. So depending on the state, we can either use the section component to display the text toolbar and editor, or to display an icon of the node the user has selected from the canvas. Next, we have field input. Field input is this exact component right here, which is used to render the node's data. Next, we have the inspector function, which is, as the comment says, the editor tab. So this tab right here, which currently renders no node selected, as you can see in this paragraph right here. So if there is no node, it will render no node selected. Otherwise, if we do have a node selected, we are once again going to extract its definition from the node registry. And then we will be able to render all of the fields that it has. You can see how we iterate over the fields, and depending on the field, we render the appropriate component. For example, in our node registry, the start node has no fields, so we would simply display no properties. But if we click on the open URL node, we will read, hey, we have one field with a placeholder youtube.com, which is exactly what ends up being rendered here. Next, we have the toolbar tab. So that is the default view right here. And in here, we define the sections. You can think of sections as categories for our nodes. So we separate that into triggers and actions. Once again, we make sure that this is compatible with our node registry, because each node needs a kind. And so far, we've only established two kinds, trigger and action, which is also the type step node kind here, which we make sure that we strictly type here. So it's not something like this cannot happen. It has to be strictly typed. That's why node registry is the source of truth. Then we go ahead and we use the entire node registry export, which is this. So this exact object, which holds all of our nodes, and we create definitions for every single component. Then we use the palette, and the palette basically renders the accordions by iterating over our sections. We define the sections here, which are basically categories. And inside of each accordion, which can be collapsed, as you can see, it simply goes over all of the items inside, or definitions, which we extracted from that node registry. And we render a button for each of the node. And we also render that node icon, which we first saw at the top of the component. We then have the header component, which is basically this at the top, which has a drop-down menu, which simply renders a delete workflow button. And we also have a run button component right here. So I've purposely separated those two so it's easier for us to work with. And then we have the sidebar component itself, which is the whole thing, and all of these other things are plugged into it. So actions menu, run button, and then we have the editor, the toolbar, the palette, the inspector. So now that we've established the source code and we know how it works, let's go ahead and make this right sidebar component functional. Before we implement the right sidebar functionality, I would actually recommend committing this file. The reason is that git diff right now is absolutely huge. And now imagine trying to look at your agentic coding changes in this file on top of that. So to make this easier for us, go ahead and commit. You don't have to push because we're still developing. And now every change we do will be clearly visible in the git diff. The first feature I want to add is the ability to add new nodes to the canvas when we click inside of the toolbar section. To understand how to implement this, we need to go into the right sidebar source code and find which function is responsible for rendering these two buttons. Inside of the right sidebar, you can find the palette function, which is the toolbar tab, which renders a button per node type that it adds to the canvas. So once we render the sections, meaning the accordions, which are basically categories of nodes, inside of each category, we render the definitions. Each definition is presented as a button with the node icon, which is exactly what we are seeing here. And right now, we already have an onClick, which calls the add function right here. The problem is this function currently doesn't do anything. Let's construct the following prompt. This will be a prompt in 3 paragraphs, so don't immediately execute it. We're gonna additionally add more context about how we want this function to look like. First, the main functionality. When I click on a node in the palette in our right sidebar.tsx, add it to the canvas in the middle of the current view. Generate the node's ID with crypto random UUID. That's the first paragraph. Now let's add some more information about how this function should actually work. If I add several nodes of the same type, so if I have multiple agent nodes or multiple OpenURL nodes, we need to differentiate them. So number them, Act 1, Act 2, OpenURL 1, OpenURL 2, so they stay easy to tell apart. But only allow a single trigger node. So we are not going to allow workflows which are able to be executed in multiple trigger nodes. So only one trigger node per workflow. So if one already exists, show an error with a Sonar toast instead of adding another. And then let's add the last piece of information before we execute this. The palette lives in the sidebar component, which is outside of our canvas component. So let's actually tag that component as well. So the two need to share one React Flow store. So make sure to wrap the workflow's ID page.tsx, which we could also tag directly. So dashboard workflows ID page.tsx in a React Flow provider. So it sits above both the canvas and the sidebar. Now remember how we modified our agents.md to instruct it how to use React Flow. In theory, it should recognize that this is a scenario where it should load that documentation, but just in case, we can slightly remind it. Follow the agents or Claude MD rule for using React Flow. So this is our full prompt. Let's see what kind of function it's going to develop. Looks like the generation was successful. Looking at the summary, it's describing exactly what we requested in our prompt, but let's look at the source code to see exactly what was generated. So the first thing I would expect is that we have a modification in our dashboard workflows ID page.tsx. So it imported React Flow provider from XYFlow React. And then inside of the room component, it actually encapsulated my workflow shell within the React Flow provider. That is because the workflow shell is both responsible for rendering the canvas and for the right sidebar. So canvas and right sidebar are siblings, right? So we needed to put them under the same context because right now the canvas has access to React Flow using use Liveblocks Flow, but right sidebar had no access to that component. They are siblings, right? So that's why we needed to add a React Flow provider wrapping the workflow shell. So now both our canvas and our right sidebar have the same access. Now let's take a look at the right sidebar, the actual component. So we have use React Flow and use store imported from XYFlow React, and we have toast imported from Sonar. Those are the import changes. Now we have no other changes besides the palette function, which is perfect, exactly what we wanted. So using the use React Flow, we first give it a type, step node type. So it matches our node registry. From here, we extract get nodes, get viewport, and add nodes. So my agent decided to first calculate the width and the height of the canvas. So in the add function, it can calculate where to position it because I wanted to position it in the center. But let's see what it does first. So inside of the add function, it first reads the definition of the node I want to add by using the type from my add function here, and then it extracts the definition using node registry type. Then it loads all of the nodes that I currently have in my canvas, and it goes through the definition. If the definition of the node I'm trying to add is a trigger, and my nodes already have a trigger component, it throws an error and an early return. A workflow can only have one trigger. So that's the guardrail which we set in the prompt. In here, it defines the count of the nodes of that same type which I'm trying to add. So it counts how many nodes do you have in the canvas right now. And then it constructs the title of this node, which is going to add based on that count plus 1. So we then have open URL 1, open URL 2. Then, as I said, it uses the get viewport to get the coordinates and the relative zoom, so it can calculate the position based on our canvas's width and height and whatever it needs to do to get to the center. I trust AI when it comes to math. And then it uses add nodes, which it extracted from the use React flow, and it creates the ID using crypto-random UUID, gives it the type of step, that is basically the name of our custom step node component, gives it a position, and then passes along the data, the type, the kind, which is mapped to definition kind, which can be action or trigger, the generated title, and empty values. Looks very good. Now let's go ahead and actually see if it works. So I like how it didn't modify any files it didn't need to modify. So if I go ahead and first try to add another trigger node, there we go. A workflow can only have one trigger. Let's click on the open URL, and would you look at that? We can now add different nodes, and look at how it increments the number of nodes. Beautiful. And since we already connected Liveblocks, we actually have data persistence built in. So if you do whatever you want to do with these nodes and then change your workflow and then go back to the one you were in, you will see the data is persisted. That's right. So Liveblocks is currently the source of truth for our React flow data, but obviously we are later going to synchronize this with our schema graph field, but not right now. Brilliant. So this is how the function should look like. I hope yours is something similar. If it isn't, you can of course visit this exact branch. So go ahead and find a chapter 14 workflow toolbar, and then go ahead and find not inside of templates, right sidebar, but go inside of my features, workflows, components, and in here you will find right sidebar, and you will find this exact palette functionality. So if you have this working, of course it doesn't need to be the exact same code. It can be slightly different as long as the functionality is the same and you can actually add nodes and they increment in numbers. So if you did this, I would recommend actually committing this so you once again have a clean slate, so it's easier to track next changes. So you can commit with something like add toolbar, add function. Now that we've encapsulated our canvas component and our right sidebar component under the same umbrella of React Flow provider, we can add another feature which makes it so that whenever a node is selected in the canvas component, its information is displayed in the editor tab. And we can achieve this in one line. What's important is that you have use store imported from XYFlow React. Then scroll down to right sidebar function and replace the template version of the selected constant into the use store selector version, which has access to the nodes and has the ability to find the selected node. And if you try it out, selecting any node in the canvas will properly render that node information in the editor. With the selected constant populated, all we do is pass it to the inspector component. The inspector component then matches its definition from our node registry. That's how it renders the necessary fields like URL and the input. And for start node, it doesn't render anything, because that's exactly what we have defined in our node registry. The start node has no fields, but OpenURL has one field called URL, so that's exactly what's rendered. If you were to play around and add another field in the fields array of the OpenURL, it would immediately be displayed in the editor tab. If you've added any additional fields, make sure that you now remove them and then go ahead and stage and commit this change. Now let's make it so that the editor fields actually store the data which we type inside of these fields. Right now, we can't even type inside because there is no value control in these fields. So inside of the right sidebar, find the inspector function and go ahead and add use React Flow and give it step node type inside. And extract update node data. Now let's scroll down until we find field input on change. And in here, let's remove the template to do, and let's actually use that extracted function update node data, target the correct node ID, and then update the values matching that field key which we are currently modifying, which is currently rendered using definition fields, and preserving all other values this node might have and assigning the value to that specific key. If you try typing into the field now, it's going to work. And if you refresh, you will see that what we've entered is persisted, but it's currently only visible in the editor tab. It would be nice if it was also visible in the node component. To achieve that, we have to go inside of our features, workflows, components, step node. Then let's extract the values from the data so we can extract the fields from the definition of this node. And once we have the fields, all we have to do is iterate over their values and render them. We're going to render them right in between the closing tag for this div and this handle. So go ahead and add this snippet and save the file. Once you go back to your canvas, your nodes are now going to display each field and its respective value. If you want to see how this snippet works in action with more fields, go inside of your node registry, find the OpenURL node, and add an additional field. Then go into the editor and add some value to that field. You will see that the value is immediately rendered in the step node component. After you've done testing, remove the additional field from the OpenURL node and stage and commit your changes. Let's improve the user experience of our app so that whenever we click on a node in the canvas, we make the editor tab automatically open. Inside of the right sidebar function, let's add a new state, previous selected ID, and let's give it a default value of selected.id. Make sure that you use the optional operator in case the selected is undefined. Then let's open an if clause, which checks if we have any selected node and if the currently selected node is different from what we have previously stored. Then let's modify this new field which we've registered, and let's change the tab to editor. And if you try it out, every time you click on a node in the canvas, it's going to automatically open the editor. Now, depending on the node, sometimes we are going to need to render a simple input, but sometimes we're going to need to render a text area. So let's create a prompt which is going to enable the right sidebar to dynamically decide which component to render depending on the field property. We can achieve that with the following prompt. Let a field opt into rendering as a larger multi-line text area instead of a single line input. First, in the node registry, add a flag to the field definition so any field can mark itself as multi-line. Then, in the right sidebar component, add a new field component that reads that flag and dynamically renders either the single line input, which we currently render, or a multi-line text area. Use it for the fields in the editor. Let's look at the output. Node registry now has an optional multi-line property, which is a boolean and a flag to the node field type. So any field can opt into a text area. The right sidebar has replaced our existing field input component with a new field component, which dynamically renders either a text area if field multi-line is set, otherwise it renders the input. So now let's look at the actual code changes. So in your node registry, in the node field type, all you should have is a brand new property, multi-line, which is a boolean, and option. In your right sidebar component, you should now have a new import for the text area. As per the field input component, it should be replaced with a new field component, which has the exact same props as before, but it dynamically renders either the text area or the input, depending if field is multi-line or not. And replaced the actual field input to the new field component. If you're wondering which changes I have down here, it's just the auto switch to the editor tab we've developed previously. So go ahead and add another field to the OpenURL node, and this time give it a property multi-line set to true. And if you go ahead and open it in the editor, you should now have rendered a text area instead of an input. Let's go back to the node registry and let's add one more property to the node field type. right under our new property multi-line, let's register another optional property called required. And once we've added it here, let's also add it in our URL property. We can now also get rid of the temporary multi-line field we've added. Then in the right sidebar, find your inspector component and scroll down until you find the label. And beneath the label, go ahead and check if a field is required, and if it is, render an asterisk with a class name text destructive. And now every required field will have an appropriate sign, so we know we need to populate this if we want to execute this workflow and use this node. This is a pretty good place for a checkpoint, so go ahead and stage your files and commit. Now let's enable the only item we have in our menu, which is to delete the workflow. So let's construct the flow to enable this. First, make the delete workflow item in the right sidebar delete the whole workflow, and then send me back to the home page. So that's the overall goal that we want to achieve. Now let's get a bit more technical. It needs a server action to actually remove it from the database. It needs to scope it to the current organization. The same action should also clean up the workflow's respective Liveblocks room, so we don't have any orphaned rooms, which uses the workflow ID as its room ID. Execute it from the menu item and disable that menu item while the delete is in flight or in progress. The sidebar doesn't know which workflow it's in yet, so we need to pass the workflow ID down to it as a prop from the workflow shell, so the action knows what to remove. So what does that mean? Well, take a look at the workflow shell component. We currently have a workflow ID destructured, but we don't use it. So we need to pass it to the right sidebar, so the right sidebar is aware of which workflow it's in. And then let's go ahead and simply give it some pointers about where to create server actions and where to create database access. And let's end it with a skill, Liveblocks best practices for a room removal API, so it doesn't invent any new methods, but uses the official instructions. Looks like a very well-constructed prompt, so let's execute it. Let's look through the generated files one by one. First, I'm going to start with the data.ts inside of my features workflows. In here, the agent has added a new function, delete workflow, which follows the same convention as my create workflow, my get workflow, and my list workflows. Then let's take a look at the second file, actions.ts, once again inside of features workflows. So in here, it imports the Liveblocks client and the newly generated delete workflow from the data. It generates a new server action called delete workflow action, which accepts the ID which it needs to delete. It scopes the organization ID and throws an error if not available, and then it calls the data delete workflow function, which we just reviewed. In case the workflow is not found, it throws the error to let the user know that whichever workflow they are trying to delete doesn't exist or isn't available to the organization that they are currently in. And in here, it also performs Liveblocks delete room and passes the ID because the ID of the workflow is the same as the one of the room. Then it calls revalidate path and redirect, which are both from next cache and next navigation. So we revalidate the workflows endpoint and the layout. Perfect. So this is great. Let's take a look at the workflow shell. So as expected, we have simply passed along this unused workflow ID to the right sidebar component. In the right sidebar component, we have imported delete workflow action. Then let's scroll all the way down to find the right sidebar, which now accepts a workflow ID and passes the workflow ID to the actions menu. And the actions menu now accepts the workflow ID and has a new state, is deleting set is deleting. It disables the drop-down menu item if is deleting prop is set to true. It prevents the default on select, sets is deleting to true, and then calls delete workflow action. Now, sometimes my agent performs the pending state using the use transition hook. This time it chose not to do that. So if yours did it, it's perfectly fine. As long as the onSelect actually executes the delete workflow action, the code is perfectly fine. So now let's go ahead and actually test this out. So I currently have 9 workflows and 7 rooms in Liveblocks. So I'm going to go ahead and refresh just in case. And then I'm going to go ahead and go inside of my dropdown and I'm going to click delete workflow. And let's see what the error is about. Failed to delete workflow. So it appears that it actually deleted the workflow from here, but I'm assuming something went wrong with deleting the Liveblocks. Or maybe not, but we can verify by looking inside of here. So what actually happened? So I deleted a couple of workflows and all of them have been successfully deleted both from the database and from the Liveblocks dashboard. And I even tried going inside of my actions and commenting out Liveblocks delete room to see if maybe that's the culprit. But regardless of what I did, the server action always seems to throw this toast error. So I'm beginning to think that perhaps this catch is incorrectly used here. So I'm going to highlight the usage of this server action and I'm going to write the following. This .catch is always throwing, but both the database deletion and the Liveblocks deletion work. Can you verify your implementation using Next.js node modules documentation for why this could be? So Next.js, if you don't remember, injects the documentation in its node modules so agents can read it. So let's see what it has to say about this. After some back and forth with the AI, I've come to the conclusion that what actually threw the error was the redirect. So this specific redirect works by throwing an error. I actually remember this by reading some documentation or some problem someone wrote about. So I questioned it about that. And the first thing it did, which I purposely skipped in the recording, is it recommended I use some weird unstable feature. So then I told it the following. So if you're in the same situation as me, simply tell it, we already have create workflow action. So that's what I told it. We're using the same redirect which you deemed problematic in the create workflow action. Look at how you handle its execution and apply the same. And that was the solution. So in the end, the code should look like this. In the drop-down menu item, on select, simply go ahead and import use transition and get is pending and start transition from here. And then wrap your await delete workflow action inside of start transition. If you want to see the exact git diff, let me show you. So import use transition from React, import delete workflow action from features, workflows, actions, and then inside of the actions menu, execute the hook use transition, extract is pending and start transition, set the disable to be controlled by is pending, and then invoke the server action inside of the start transition function. This way you won't be greeted with any errors. That brings us to the end of this chapter. So let's go ahead and stage, commit, and push our changes. Now that we have a functional toolbar, let's go ahead and enable the run button, which is going to trigger the actual workflow execution. First, let's go back into our schema. In here, we can find the workflows table. What I want to do now is assign the graph property a proper type. When we first developed the schema, we didn't yet have the node registry file. But now that we do, we also have the step node type, which we can now reuse inside of this schema and make it more type safe. So first, let's import the type edge from XYFlow React. Then let's import the type step node type from our node registry. Then let's export a new type called workflow graph, which is an object with nodes and edges. And make sure that for the nodes type, you use the step node type in an array. And for the edges, we can just use the default ones from XYFlow React. And now, besides exporting this type, we can also assign it to the graph field. Now let's add a new dependency to our project called TopoSort. TopoSort is going to help us validate the graphs in our workflow, as well as correctly order the connections, nodes, and edges. Also make sure to add a dev dependency called types TopoSort. After the installation, go inside of your package.json to verify that you now have TopoSort inside of your dependency and types TopoSort inside of your dev dependencies. Now let's create a new util inside of features workflows lib folder, and let's call it validategraph.ts. First, let's add our new dependency TopoSort. Then let's import our new type workflow graph from lib database schema. Then let's create a new function validateGraph, which destructures the nodes and the edges from the prop workflow graph, and it returns an array of strings, which are essentially all the problems that this function found. So let's first define that constant, problems, which is an array of strings, and by default it's an empty array. Make sure that you return it so you no longer have the type error in the function. Then let's load all the trigger nodes we have from our workflow graph. If there are more than one trigger nodes, let's push a problem. A workflow needs exactly one start trigger. And then let's write how many of them we found and why this graph isn't validated. Then let's check how many edges we have. If we have no edges, let's make sure to throw another problem, connect your nodes before running. And in the else block, let's open a try and catch, where we call TopoSort and we map over its edges. And if this TopoSort fails, meaning if it goes into the catch block, let's push a new problem, workflow has a cycle, remove the loop before running. So by initializing TopoSort and adding this specific iteration of edges with the source and the target inside, TopoSort can detect if there is a cyclic workflow, meaning that one node ends up being connected to the previous node, which breaks our workflow. So this is our validateGraph function, which we can use to check whether our workflow has any structural problems or not. Now let's go inside of our data.ts file, where we have functions like list workflows, get workflows, create workflow, etc. And let's develop a new function which we're going to use to save the workflow's graph information. So first of all, let's import workflow graph type from lib database schema. Then let's import validateGraph function from our lib, which we've just created. Then let's open a new function, save workflow graph, which accepts organization ID, ID, and graph. Since we have three parameters here, I like to have a practice of putting them inside of an object instead of just in a specific order. Then let's use our validateGraph util and pass along the graph prop, which is equivalent to the workflow graph type. And let's extract problems from that lib. If problems.length is larger than 0, let's simply throw a new error joining all of those problems together. Since they are strings, we can display them in that manner. Other than that, let's do await database, update the workflows table, set the graph property, and update it add property to whatever is the current new date result. And then let's write a simple where query, both the workflow's ID and the workflow's organization ID match. And that is our function save workflow graph. Now let's use this new data function inside of our actions. So first things first, import save workflow graph from the data. Then import the workflow graph type from lib database schema. And then let's go down until we find our run workflow action. And first, let's extend its props. So let's make it accept an object, ID and graph. ID is a type of string and graph is a type of workflow graph. Make sure that you validate the organization ID if you haven't so far, and then after that validation, simply await save workflow graph and pass along the organization ID, the ID of the workflow, and the graph field. So now we have an action which starts a long-running task and validates our workflow. But we're also going to need a function which will be used to stop a long-running task in case the user changed their mind. So let's import runs from Trigger.dev SDK, and then at the bottom, after run workflow action, let's export cancel workflow action. The only thing it needs to accept is the run ID. Validate the organization ID and then go ahead and cancel the run. This is a pretty good spot for a checkpoint, so go ahead and stage your files and then do a commit. Now let's enable the run button inside of our right sidebar component so that it runs the server action which we just modified, the run workflow action. So inside of the right sidebar, first let's import run workflow action from features workflows actions. Then let's import our validate graph function. Then scroll down until you find the run button function. And first make it accept a new prop, workflow ID. Then using the useReactFlow hook, extract the nodes and the edges using getNodes and getEdges, and make sure you type it with step node type. Then add the useTransition hook from React and extract isPending and start transition. Then attach the isPending to the disabled prop of the button. Then construct the graph using nodes, which invokes the getNodes, and edges, which invokes getEdges. Then let's find if there are any problems using our validate graph function. If there are problems, let's go ahead and do toast.error, and let's always render the first in the array. Then let's call start transition and let's execute an asynchronous function which then awaits run workflow action and passes along the ID, which is the workflow ID from the prop which we've added, and the graph so we can validate it on the back end as well. And then at the bottom in the right sidebar function where we actually render the run button, make sure you pass along the workflow ID. So ensure that you actually have useReactFlow imported and useTransition. You should have both of those because we actually use useTransitions in the actions menu for our delete workflow action, but just in case your agent didn't do that, go ahead and manually add this. And you should absolutely have useReactFlow because that's what we use to update the node data and to add new nodes, and now to construct the graph using the getNodes and getEdges. Now make sure that your local Trigger server is running and go ahead and press the run button. As you can see, we have an error. Connect your nodes before running. So I have this error because I didn't connect my nodes, meaning that our validate graph function is working. So it noticed that I have 0 edges, which meant that I didn't connect any of my nodes. And now that my node is connected, I can click on run, and as you can see, I have no errors. And inside of my development server here, I can see that hello world was triggered and then hello world was successfully initialized. So if you play a bit more and, for example, remove all nodes and then click run again, you will find another error. Our workflow needs exactly one start trigger, found 0. So you need to have at least one node added, one start node, and your nodes need to be connected, otherwise you will get hit with an error. Perfect. So we have now completely wired up our data fetcher, our server action, and our component. But what's actually interesting is, does the actual graph now update in the database? Because so far we never really updated this graph field. We only defined it as this JSON field. All the data persistence was done using Liveblocks room because Liveblocks is a database in itself. So let's quickly check Neon to see what's up in our database. Go inside of your Neon project and find the tables. And in here you will find the workflows. As you can see, so far I didn't have any graph field populated, except this one, which is the first graph in which I hit the run button. So now let me go ahead and pick any random workflow like this one, joint baboon, which currently has nothing in the graph, and I'm going to go ahead and maybe add a couple of nodes here, and I'm going to connect them, and I might even add some data here, and then I'm going to click run. Since there are no errors, I know that this had to have been saved successfully. And there we go. Once I refresh, you can see that now a joint baboon has this data in here. Beautiful. And you can even see the exact nodes which are inside. And if I'm correct, we should also see the values stored. So this data persistence inside of our graph field is used for a different purpose in comparison to Liveblocks. So Liveblocks data persistence came as a great help to us because it's what renders the UI. So every single time we move our nodes around, Liveblocks updates its database. We don't have to synchronize that, they do it for us. But whenever we want to execute the workflow, this is where it's important for us to validate whether this graph is correctly connected, whether it has any missing edges, and whether we can actually execute it. But right now, the task which we are executing when we click on the run button is this hello world example. So let's now start working on a real workflow execution task. I want to develop this task inside of features workflows. And in here, I've created a new folder called tasks. And in here, let's create run workflow.ts file. Let's start with the imports. Let's add toposort and let's add logger and task from Trigger.dev SDK. Then let's import our get workflow from workflows data. Then let's define the run workflow task. Let's give it an ID of run-workflow. And inside of the run, let's simply define an empty asynchronous function. Let's go ahead and make this asynchronous function accept a workflow ID and an organization ID inside of an object. Then, using that organization ID and workflow ID, we can properly call our getWorkflow data fetcher, which gives us access to the workflow the user is trying to run. Next, let's check if the workflow isn't available or if the workflow doesn't have a graph. And if they don't, let's throw an early error. The workflow has no graph. Then let's go ahead and destructure the nodes and the edges from the other workflows which actually have a graph, which have passed this validation. Then let's add a little helper called byId. So we create a new map and we put the nodes inside in this exact format. Then let's go ahead and create a new set and we use edges.flatMap. What we do here is we ensure that the nodes we are going to run are only those which are connected. So if we have any orphaned nodes which aren't connected to anything, we're just going to drop them and we're not going to run them through the toposort and we're not going to execute them. Then let's go ahead and order our nodes using toposort.array. Inside of the array, in the first argument, perform a map over nodes, and in the second argument, perform a map over edges. Make sure you produce an array which will end up being a matrix of sources and targets. And then filter by ID of each of those and make sure they appear in the connected set. So that's how we ensure that we only execute those nodes for which we found a connection to another node. So there is a complete cycle. And let's add a little log here. Running workflow name, and let's prepare how many steps this is going to have. By steps, we mean how many nodes this is going to have. Then let's do a for loop. So for every order that we find, let's go ahead and find the node using our byId helper. And let's simply log running step, and then let's print out exactly which step that is. And let's add a to-do, actually execute the node instead of just logging it and report its progress so the UI can watch the run live. So that is the next step. So just make sure that you are iterating over the order, right? Because that's what we are doing. The order is essentially going to return an array of strings, and that's what we have to follow. It's basically an array of IDs which have to be executed in that specific order. And in the end, simply return the steps using order.length. Now that we have our new run workflow task, let's go back inside of our server actions and let's replace the usage of hello world task and replace it with our run workflow task. So first, let's add import type run workflow task from features workflows task run workflow. So yes, the run workflow task as defined and exported here is automatically a type. So there was nothing else we had to export. This can serve both as the API and as the type. So now that we imported that, let's go down until we find run workflow action. And in here, we trigger the hello world task. So let's now replace this with the following. Tasks.trigger type of run workflow task, which makes it required for us to name the workflow like this. If you try to enter something else, it's going to throw an error because run workflow task is clearly defined to have this specific ID. So make sure that your ID isn't misspelled. And then pass along the workflow ID and the organization ID. And then as a third argument, which is something we didn't have for the hello world example, go ahead and add tags. And tags is an array which has a constructed string workflow colon ID. If you try and click on the run button and then go inside of your Trigger development server, you will notice that runs are not firing. So even though we correctly replaced which run we are invoking, it's not properly executing. The reason is because we didn't register the features folder to store any Trigger.dev tasks. So we have to go back inside of the trigger.config.ts and replace trigger with features. And then I would recommend restarting your server and let's try it one more time. So make sure you have your Trigger server running and then go ahead and click run. And just like that, you will now see your runs. Besides verifying the runs inside of your CLI, I would recommend also visiting the Trigger.dev dashboard so you can actually go inside of your latest runs and verify what's logging inside. Create the following scenario in your canvas. A start node connected to OpenURL1, which is connected to OpenURL2. And if you take a look at our run workflow task, what we do is we topologically order the nodes based on their edges, based on the source and the target of the edge. So we are aware which node is connected to which one, which means this for loop for this specific canvas should output start node followed by OpenURL node, and then the last node that should be outputted is the OpenURL2 node. So when I click run, I'm gonna go ahead and refresh my Trigger.dev, and this one which just completed, let's take a look at the logs here. The first step is start node, the second step is OpenURL1, and the third step is OpenURL2. Now I'm going to try and purposely remove the edges and connect it the other way around, just to verify that this isn't a fluke. And just as we suspected, the order is now start, OpenURL2, and then OpenURL1, meaning that our algorithm for topological sort is correct. And because we added a tag into our tasks.trigger inside of run workflow action, if you take a look at your latest runs and scroll to the right side, you will see that our newest runs have a workflow with their respective ID. Now, right now, this isn't really useful for us, but later when we add the real-time feature of displaying logs of a specific run, this will come in very handy. We can now also remove the trigger folder and the example file from there because it's no longer used. Before we commit and end this chapter, let's ensure that we have the proper git changes. So we removed the example.ts from the trigger folder, as well as the entire trigger folder. We modified the trigger config so that the directory of the tasks is now features and not trigger. We added a new run workflow task, which topologically orders the connected nodes which it extracted from the workflow graph, which we loaded using the organization ID and the workflow ID. And inside of this topological order, we iterate over those nodes and log which step is currently running to verify if that order is correct and matches what we see on the canvas. We then modified our actions.ts by adding that new run workflow task and appending it to the run workflow action. And that actually reminds me, we should also remove the unused type hello world task from here. There we go. And in the right sidebar, we did this actually first, I believe. We wired in the run workflow action, which is a server action, and the validate graph, and wired it into the run button. So we can disable it while it's running, and we can throw any errors if validate graph doesn't pass. Great. So now let's go ahead and git add, and then git commit and git push. Amazing job, and see you in the next chapter. Now it's time to give our workflows, our nodes, and in the end, our agents access to the whole web. And we're going to achieve this using Browserbase. Not only is this going to give our agents access to browse the web, but also to interact with any website just like a human would. Using the link on the screen, you can get to the Browserbase website, and the link simply lets them know that you came from this video. Once you're here, go ahead and create an account. Once you've created your account, you're gonna get greeted with the following onboarding screen. Now, given that this screen can update in the future, what I would actually recommend is clicking skip to the dashboard. This way, we can manually learn our way around the dashboard and around the documentation. So first things first, how to find the API key. You can find the API key using their quick access button right here. If that doesn't work, you can click on the settings and you can find it here as well. This is the place where you can also regenerate it if you want to. Once you've obtained your API key, go ahead and add it to the environment file under the property name Browserbase API key. Then let's go inside of the resources and find the documentation. In here, you can find the quick start, and then in the sidebar, select skills. And then what we can do is we can copy this prompt, which simply fetches the skill.md file which they've prepared for us. We could have technically just copied the prompt that we saw on the onboarding screen, but I feel like this is more reliable, so we actually learn how to navigate the Browserbase dashboard and the Browserbase documentation. So now let's go ahead and run this prompt. So the agent fetched the setup guide from skill.md. Then it verified whether we have the Browserbase API key. Then once it confirmed that it already exists, it installed the CLI called browse. Then I assumed it authenticated that browse by copying the Browserbase API key globally somewhere on our machine. Then it ran browse skills install using that CLI, which globally added the browse skills. And here is the verification for Browserbase API credentials. So there we go. Let me verify that the API connection works with the existing key, and that is setup complete. So here's the summary once again. Browse CLI was installed. Since I have a macOS or a Unix system, this is my location. Agent skills are installed, and now the browse skill is available. So unfortunately for us, it didn't do it locally, it did it globally, which is fine. It still works, it's just not committed with the project. The API credentials were already present, so we didn't have to do anything here. And it also ran browse cloud projects list, which returned our production project, which is what we have right here, the production project. So it correctly managed to authenticate the browse CLI using our Browserbase API key. So everything checks out. The API key was already configured, so no new credentials were needed. So now it's offering me to do some quick tests here. It even provided me with like an exact automation task to do, but what I would first like you to verify is whether you actually have the browse skill installed, just in case we end up using it. So make sure to do reload the skills or simply restart your coding agent, and also do a reload window if you are using a graphical user interface. And then at that point, you should have the browse skill available. If for whatever reasons you don't have that skill available, go inside of integrations and scroll down until you find skills introduction. And then in here, you will find a manual way to add the skills that you need. Now it's a good idea to try out whether the browse CLI actually works for you, but if you got a successful message from the agent, chances are that everything is set up correctly. So I'm gonna run browse open codewithantonio.com with a local flag. If you get the output like I did, which is that session is already running, you can stop it with this command. And then let's try opening Code with Antonio once again. And the result is the metadata of my domain. So my title is Build Something Great Code with Antonio. Perfect. So we have verified that our browse CLI actually works. The browse CLI is used to interact with your organization and your project in Browserbase, and also to allow agents to open headless Chrome browsers and test out any domain you give it. But the Browserbase which we're actually going to be using inside of this project is the programmatic use of Browserbase. So we are not going to tell Claude Code to open a browser and then do something for us. We could do that, but what we are building is a software as a service which allows various users to build their own workflows and then use Browserbase's SDK to programmatically do that for them. So our job is to actually install the Browserbase HQ SDK package. You can find the documentation for that by going inside of APIs and SDKs and then select the Node.js SDK. Now it's time to add Stagehand. Stagehand is Browserbase's open source product which allows you to prompt using natural language and instruct agents to behave or do something on a website, which is that wow effect which we are looking to provide to our users. So besides the documentation on the left, which you can find where you are instructed once again to get your API key and then to install Browserbase HQ Stagehand, which we absolutely are going to do. So you can make sure that is installing in the background. Meanwhile, go and find the actual Stagehand website. And in here, click on the AI rules. And scrolling a bit down, you will find the editor rule files. So instead of providing a skill, they actually provide us, well, with a skill, but we have to manually add it to our Claude MD. So let's go ahead and close all of these, make sure the new packages are installed, and then go either in your agents or Claude, it doesn't matter because it's a symbolic link, and then paste all of that content below. So now we are going to have all the knowledge required to use Stagehand in this specific version for which this documentation was added. So this agents.md or claude.md snippet, which we've added, which will also be available in the source code if you can't find it. So you can just visit my repository and then find my agents.md and you can copy it, is more important than that browse skills, which we installed a few moments ago. So this is the actual SDK, which we're going to be focusing on, the Stagehand. So go ahead and stage and commit these changes so we have a clean slate for further development. So right now, if you go inside of tasks, run workflow, the only thing we do when a node is executed is we log that the node is actually running. So what's actually going to happen here in the future is we would somehow get the executor by having some kind of registry similar to node registry, but we're going to have something like node executors, and we're going to map it to our current node and then .type, right? And then we would simply do execute. And these node executors will in the future be something like this. So open URL, and then in here we will do open URL. Wow, this is a big function. Something like this. This is the general idea of how we're going to develop this. So let's start by actually developing that logic which we are going to create the node executors registry with. So no need to do any changes in the run workflow, but let's go inside of our nodes folder where we have the node registry, and let's create open URL.ts. First, let's add type stagehand from Browserbase HQ stagehand. Then let's export an asynchronous function open URL. Inside of its params, let's accept stagehand and URL. I'm going to explain why we are accepting stagehand instead of initializing it here later when we add the node executor. Inside of the actual function, first let's get the page using stagehand context pages, and then let's use page go to and then the dynamic URL variable which the user will enter on the canvas. And let's go ahead and decorate it with some properties like wait until and timeout in milliseconds. And then let's simply return the URL and the page title. So how did I know this API? Well, because it's written in agents.md. I could have technically just told the agent to do this, but it's such a small function that I feel like it's easier to do it by hand than to write a perfect prompt that will deterministically give us this exact output. So yes, this page needs to be accessed like this, and then you can instruct page go to a URL. Perfect. So this is our first node executor. Before we can write the node executors registry, let's first go inside of the actual node registry, because in here we have all of the necessary types that node executor needs to satisfy. So let's export action node type. And now that we export the action node type, we can create the node executors registry. So first, let's import type stagehand from Browserbase HQ stagehand. Make sure you're importing the type. Then let's import action node type and node type from our node registry. Then let's import the new executor we just developed, open URL. Let's export a type node context, which is an object with two properties: values, which is an object, and get stagehand. Then let's export type node executor, which is simply a generic type which we're gonna use whenever we need to satisfy the node executor output. Then let's actually export the node executors. Let's give it the correct type, and let's open an empty object for now. Then inside, let's add the open URL. The open URL is an asynchronous method which accepts values, gets stagehand, and returns the open URL util which we developed above. The open URL also passes the stagehand using await get stagehand and URL using values.url. And let's wrap it up by adding satisfies record action node type and node executor. There we go. This is our node executors. This is where we're going to build every single node's executor going forward. Or should I say, this is the factory which our coding agent is going to use to populate and add new nodes later, so we don't have to do it by hand anymore. Now let's wire this up inside of our run workflow.ts. So first things first, let's import stagehand, this time the actual stagehand. So don't import type, import stagehand from Browserbase HQ stagehand and add the new node executors import. Now let's implement get stagehand lazy run function. And this will clear up why we are passing stagehand as a prop rather than initializing it in every executor. So let's go inside of our run workflow task. Let's find our order const. And after this logger, where we log which workflow we are running, and before the for loop, let's go ahead and define a variable stagehand. And by default, let's give it a type of stagehand. So yes, we can use this both as a type and as the actual client, or undefined. Then let's open a function get stagehand, which is an asynchronous arrow function. If there is an existing stagehand stored in our variable, simply return that exact instance which we've already initialized. Otherwise, let's go ahead and create a new stagehand instance. And inside of its properties, first give it an environment of Browserbase, then give it an API key. Now for the model, I'm going to select the cheapest one. And no, you don't need to add your own key for this model. Browserbase will automatically infer this for you. But if you want to, you can provide your own API keys. If you run out of Browserbase API tokens, you can just switch to bring your own keys method. And we're going to add this property called disable Pino. So disable Pino is a logging backend that basically spawns a thread stream worker, which essentially breaks when run inside of a trigger long running tasks. So because of that, we explicitly disable that. Then let's do await stagehand init and let's return stagehand. It might be useful to add a comment like this to understand why we are developing the getStagehand function and to not forget that Browserbase has its own model gateway using the Browserbase API key. So this entire run, this Trigger.dev run, owns one Browserbase session. And we lazily open it on the first browser step, and then we reuse it by every later subsequent step. Otherwise, if we were to do what most of us felt was natural, and that is to initialize stagehand in here, we couldn't keep that in the same session. So the recording which we want, right? That's the cool part. When the user finishes a workflow, we want to give them a recording of what the agent did. The only way we can do that is if we somehow preserve a single stagehand instance. So that's why we are lazily opening it, and we're going to pass it as a prop. So it's reused across every executor until it reaches the end where we eventually close that stagehand session. So if you want to, you can add a comment like this, which will explain that. Now let's go inside of our for loop. And instead of just logging which step is running, let's do what's actually written here. Actually execute the node instead of just logging it. So first, let's extract the executor. We can do that exactly as we demonstrated in the beginning of this chapter using the node executors registry and then accessing it using node data type. And then once we have the executor, if we have the executor, let's await that executor and simply pass along values using node data and then its values. And don't forget to actually close the stagehand instance once all of the nodes have been executed. So now make sure that you have your app running, make sure you have the Trigger.dev server running, and then go ahead and populate one open URL node with a valid URL. And go ahead and click run. Inside of your Browserbase dashboard, you should now see a new session. And this session, if you clicked on it early, will actually be a live preview of this Chrome browser in the cloud, which actually opens the URL. But if you missed it, don't worry, because you get a replay of what happened. Congratulations on developing your first executor. This is now a primitive which we can leverage in agentic coding and build multiple similar nodes on top of this by pointing it to a proper result which we now have working. So let's go ahead and stage, commit, and push our changes. Don't forget that we've added a new variable to our environment file. So inside of your Railway service, go inside of the raw editor and paste that environment variable. Update the variables and redeploy. So now we have successfully developed our first executor open URL. But before we go on to creating the rest of the nodes and their respective executors, I think it's first time to completely finalize everything that a single node can do. And right now, our open URL node can almost do everything we wanted to do. But one thing we didn't implement is data pass-through. So when I connect OpenURL to OpenURL2 to OpenURL3, and when I click on OpenURL3, what I would expect is to see all of the previous connections it has. So I can interpolate the output data from the previous node and inject it into its values. This is a crucial part of any workflow application. Data pass-through. You might have noticed that in the previous few chapters, we focused more on manual coding than on agentic coding. The reason behind that is because I wanted us to establish a very deterministic state of our code base, where both you and I have the exact same code. And now that we have a fully functional executor and we have fully functional write toolbar, we can now build on top of all of those stable and deterministic components we've developed more reliably using agentic coding. Since some of the prompts in this chapter are going to be a bit longer, I don't want you to waste time pausing the video and retyping what I type. So I've prepared chapter 17 data pass-through inside of the specifications folder, which you can look at and then copy and paste inside of your coding agent so we have the exact same prompt. Let's start with developing an interpolation helper whose purpose is going to be to transform a value like this into an actual value extracted from the output of the node to which this node is connected to, and to any previous node that data was passing through in this workflow. So let's review the first prompt, which will be used to generate the interpolation helper. I want to let a workflow field pull in another node's output by writing a placeholder like this template or this template. To make that work, I need a small, pure helper that takes one field's text plus a collection of every node's output from this run, and make sure that all of those outputs are keyed by node ID, and returns the text with each placeholder swapped for the value that it actually points at from all of those previous node outputs. If a placeholder resolves to nothing, let's simply replace it with an empty string. If it resolves to an object, let's drop in the JSON. It has to resolve nested paths, so lean on whatever small getByPath utility is cleanest. Put it in the workflow features helpers and call it interpolate. So hopefully it's going to develop it inside of features lib right here. Let's go ahead and run this prompt. You should now have a new file called interpolate located inside of features workflows lib. And its purpose is to transform placeholders like this template into actual field for values pulled from this run's node outputs, which are keyed by node ID. Perfect. So now we have this interpolate function, which accepts text and all of the previous outputs in this run, and then it can replace the placeholder, which we define using a regex, so that's how it finds the double brackets, and it injects whichever value is referenced from the outputs object. Perfect. So I'm assuming your function looks somewhat similar. Now let's go ahead on to the next prompt. The second prompt is pass outputs through the run. Inside of the run workflow task, let each node use the output of the nodes before it. Right now, we run nodes in order and throw their results away. So instead, keep each node's result as we go, keyed by its ID. Then, right before running a node, replace the placeholder in its values with the matching upstream data using the interpolate helper we just made. Nodes already run in dependency order, so anything a node references has produced its output by the time we get there. Perfect. So a natural continuation of this interpolate helper which we just developed. So this interpolate helper by itself is just a pure function that could be used in any other project. So what we have to modify now is the actual run workflow task. What we do now is we pass the raw values from here. So we should somehow transform these values by capturing all of the output that happened in the previous nodes and then run it through our new interpolate function. So let's go ahead and paste that prompt here and let's execute it. I would highly recommend doing this in the same conversation so your agent has context of what we are developing. There we go. So our run workflow task now has an accumulator as a constant called outputs, which is an empty object, and that collects each executor's return keyed by node ID. We now interpolate before running. So each field in node.data.values, which was previously passed in raw, is now passed through interpolate. So if the node data values has any placeholder like this one, it will resolve to the upstream results just before the node executes. And at the end, we store the result to the accumulator keyed by the ID. So await executor values get stagehand returns its value stored inside of the outputs ID object. And we didn't do anything else because toposort already takes care of everything. So let's just go through the code quickly. So we import our new interpolate util. We define the accumulator, which is just a constant called outputs. And then in the for loop of our nodes, we go ahead and first check if we don't have an executor, we manually continue. But if we do have an executor, we make sure that we don't just pass in the raw values like we previously did, like node data values, but instead we construct new values using our interpolate here. And then we don't just randomly throw away the results of the executor. We actually store them inside of our accumulator right here. So every subsequent step can properly interpolate using exact output. Now let's do a few changes in the node registry, which are simple enough for us to do by hand. In between node field and node definition, let's go ahead and add a new type, node output. Then let's go inside of the node definition, and after fields, let's go ahead and make it so that each node definition also needs to have an output. So now, inside of our node registry, we're going to have to strictly define exactly what each node can return from its values. For example, the start node doesn't return absolutely anything. So what does the OpenURL node return? Well, to figure that out, all we have to do is go inside of the OpenURL inside of our nodes. And in here, we can see exactly what this node returns. So let's add URL and title inside of the OpenURL node registry outputs. Now let's construct a prompt that's going to develop the upstream outputs hook. So I want people to reference an upstream node's output without typing raw node IDs. Give me a hook that takes the node I currently have selected and returns every output that any node upstream of it produces, each as a ready-to-insert template. A friendly label like OpenURL1, which is the name of the node which I'm inserting, and then its value. And the source node's type so I can show its icon. Follow the connections all the way back up the graph, not just the node's direct parents, and recompute it as I connect and disconnect edges. Each node already declares which output it exposes. Put it in the workflow features hooks and call it use upstream connections. And follow the Claude MD rule or agents.md if you're not using Claude for using React Flow. So what exactly is this for? Well, right now with what we currently have, we are actually able to preview the value of the previous node. The problem is we would have to manually type the template and we would have to know the ID of each previous node that came before us, which is not a good user experience. So what we need is a hook that's going to serve as the business logic behind these chips here that the user can click on, which will automatically insert the value of the previous node in form of a token, in form of a placeholder. So let's go ahead and run this prompt in our existing conversation. Let's take a look at our new hook. So what does use upstream connection return? It returns an array of upstream connections, which is one entry per output of every node upstream of the selected node. Inside of the upstream connection, we have a token, which is a ready-to-insert placeholder like we expected. And it matches the syntax our interpolate helper resolves at runtime. We have a label, which is displayed like this. So the name of the node and then the value which we are inserting. The upstream node's data title, and then the outputs registry label. We then have node type, the source node's type. So the caller can render node registry node type icon, which is what we want for our chips components. So how does it work? Reads the selected node, all nodes, and all edges reactively from the React Flow store via use store. The pattern is already used inside of the right sidebar. Since edges are part of the selection, it recomputes on every connect and disconnect, and on selection change. It walks the whole upstream chain, not just direct parents. Perfect. So let's actually take a look at the code here. So we can see if anything is off, even though just by this description, I can see it's exactly what we wanted here. So this is the upstream connection type, which it just talked about. And then in here, we have the actual hook. So what's interesting is that my agent generated a hook which doesn't accept any params. So if you're created a hook which accepts params, it's perfectly fine. It doesn't need to be line for line, right? Because we are writing prompts which simply explain the idea what we want. They aren't necessarily, very strict and made so that the next prompt that we do won't work unless your code is identical to mine. No, that's not gonna happen, don't worry. So whether you have props here or you just directly use React Flow hooks inside, it's the same thing. So yes, technically, because we have access to use store, we don't need to pass any props. We can just access the selected node from here. And then in here, it basically does exactly what we told it to do. It goes through the outputs of all the previous nodes, and it returns a flat map of all the possible chips which we can insert for this selected node. Exactly what we wanted. So when I select a node, I need some hook to compute how many of these connections do I have. So now that we have this, we can build the UI component, which is actually going to render all of these connections. Now let's review prompt number 5, connection chips in the inspector. So in the right sidebar, under the selected nodes fields, add a connections section that shows up whenever use upstream connections hook we just developed returns any outputs for that node. Render each available output as a small chip with the source node's icon and its label. When I click on a chip, insert its token into whichever field I was last editing, or the first field I haven't touched one yet. I want this for every connected node, not only the ones with a large text field. And since we're once again using React Flow, it's just a little helper here. So what does this mean? Well, now is the time for us to build this UI. So we now have the backend, we now have the registry, and we now have the client hook, which provides us with a flat map. We can simply iterate over and display to the user, these are all the connections you have. And when you click on one of those, it's simply going to insert it into whichever field you were last focused on. So let's go ahead and run this prompt in our existing conversation. So let's read through the output. Here's what I added to right sidebar. Connections section. It renders under the selected nodes field. Whenever our new hook use upstream connection returns any outputs. Because the hook reads selection from React Flow store and walks all the ancestors, this appears for every connected node, exactly what we wanted, regardless of whether it has big text or just single line inputs. We also render the chips. So each available upstream output is now a small button showing the source node's registry icon using node icon and its label like OpenURL1 and title, wrapping it in a flex row and truncating long labels. So we will see how this looks like. We can always tweak the design easily. And we have click to insert. Clicking a chip appends its node ID path token to a target field. Field component now reports focus via an onFocus prop. The inspector tracks active field key. Okay, so this is the logic to determine which was the last field the user was typing in. So when we click on the actual chip, it knows in which field to insert. Beautiful. Reset on selection change. Yes, so every time you change the nodes using the key, it simply resets the entire component. Brilliant. So just by this definition, I already know this is exactly what we want. But still, let's take a look at the code here. So right sidebar component now imports use upstream connections. Our field function now has onFocus and it maintains onFocus. If yours didn't do that, it's not a big mistake. This is just so the chip's insertion is aware in which field you're currently working, because some nodes can have like 3 input fields. So when you click on,
Like this is simple because we only have one field, but what if we had 3 fields? How would it know into which field to insert the connection? So that's what it does here. It added the onFocus prop here, and then I assume that in the inspector or wherever the fields are rendered, it changes the set active field key to that active field, and then the insert token knows where to insert into which field key. In here we have update node data, which simply adds that token, which is destructured from use upstream connections. Beautiful. So very surgical change. And this is where we render the actual connections we have available. So we'll see how this looks like. We'll compare to our design and see if we like this or not. And the inspector now has the selected ID key added here simply so it destroys the whole component and rebuilds it. This is like an easy way of resetting whatever was loaded inside. Very, very clean change. I love this. Remember, if any of your changes look different or if the end result, which we're going to test now, doesn't work, feel free to simply open, this is chapter 17 in my GitHub repository, find the branch and take a look at all of these files, find them, and perhaps discuss with your agent. Discuss why something didn't work or what do we need to do to make it work like these files. So you have a more interactive experience in a tutorial. Now let's review these changes in our app. So right now I have one start node and one open URL node, and nothing looks different. So if I go ahead and attach an open URL 2 to my open URL 1, there we go. I can now inject the value of this previous node into this node right here. One thing we could improve, maybe give yourself a homework, and maybe this can be a challenge. Try to make your fields actually display the value somehow. Because right now we don't really care, right? Because what's actually going to interpolate the result of this template is inside of our run workflow. That's why we have this interpolate here. So that is now going to receive this template, and it's then going to transform that into the actual value of this output right here. So I think that in theory now, I should be able to access both of these nodes, and both of these nodes should now open codewithantonio.com. That is because the output of our open URL, as you can see, is the URL that we are currently on. So I think this should just translate to another version of https codewithantonio.com. So make sure that you have Trigger.dev running and execute this function. So if you now go into your latest session here, you will find that 2 pages were accessed. So first one was codewithantonio.com, and then the second one, once again, codewithantonio.com, meaning that our data interpolation officially works. And here's the best part. So if I go ahead and now chain open URL 3, I can now access open URL 2 and open URL 1. So that's the whole point of building this data pass-through. And I think it was really fun developing this entire thing using agentic coding. So this is why I kind of postponed using prompts until now, because I wanted us to establish a very stable code base, because now is when it starts to be fun to build with agents, because as you can see, the outputs are very deterministic. It's almost exactly what we imagined. If I look at my picture, of course, there might be some slight differences in these chips, but honestly, I'm fine with them. I like them this way. If yours look drastically different, you can either, modify them yourself or use this image and maybe take a screenshot of these images, and then inside of the existing prompt here, go ahead and tell it, make the chips look like this, if your agent has visibility and can access the images. Beautiful. I'm so happy about how this went, because we now have proper data interpolation and data pass-through. Obviously, this will be a bit more exciting once we have different nodes, something other than open URL, but I'm pretty satisfied with this. And now let's go ahead and stage, commit, and git push our changes. In this chapter, we're going to develop the live run status. So far, we can successfully execute our nodes, we can even interpolate their values, but we don't have an indicator as to which node is currently running, nor do we have an indicator if a node fails. So just like in the previous chapter, I've prepared a specification with all of the prompts which we are going to run in this chapter. So go into our GitHub repository, either on the main branch, or go ahead and find chapter 18 live run status, and in the specifications folder you will find the new prompts. So the live run status needs to start from somewhere, and in our case the answer is from the run workflow task. This is essentially the Trigger.dev environment, and inside of this environment we have the option to store the current status of a node, whether it's executing or whether it failed, using Trigger metadata. And then we somehow have to send that to the UI so Trigger real-time hooks can accept that and display it accordingly. So let's go through the first prompt together, in which we are going to stream the step status from the Trigger.dev run. So inside of our run workflow task, stream each node's live status so the canvas can show progress. Before running anything, build a list of the steps we are about to run, each just a node ID and status starting at pending, and then publish it to the run's metadata under steps value. Export the step type and call it run step. So we are here establishing the types and the default state we need to maintain each node's progress. As we go, set a node's status to running before its executor. So before a node reaches the executor, let's go ahead and label it as running. And then after the executor is finished, mark it as done or failed if it throws. And at that point also stop the run, so no going forward. And then republish the metadata on every change. Right after marking a node running, force the metadata to flush. Otherwise, that state gets overwritten by done before it's ever pushed, and we'd never see the spinner. So this is something that I've come to find out after a few unsuccessful implementations of this. So when working with Trigger.dev's metadata, you have to flush it after certain events, otherwise it simply won't reach the canvas and it would appear as broken. So that's why I have explicitly added it to this prompt. Also flush right after marking a node as failed before the run stops. A thrown run reaches no output, so the flushed metadata is the only way that failed state ever reaches the canvas. Also return the final steps from the task so a successful run's finished state is guaranteed. Keep the existing interpolation and execution as is, and finally use the Trigger.dev tasks skill. So let's go ahead and implement this prompt. Let's take a look at the change. So we now have metadata imported from Trigger.dev SDK. We have a new exported type called runStep with node ID and the status, which can either be pending, running, done, or failed. Then in here, after we topologically sort our nodes, so we have a new constant called order, we go ahead and we construct all of the steps from that order. And we make sure that each one starts with pending. And then we add those to the metadata under the steps property. So now we replaced the for const loop to a regular for let I loop, I'm assuming, so we can keep track of the index here. So now we manually have to maintain the ID, and then we have to construct the step using these steps and then accessing it via the index. So before we actually await the executor, we go ahead and set this status to running. And we modify the metadata once again. And then we do metadata flush so it actually appears on the canvas. We now execute the executor instead of a try and catch, because that is the only way we can capture if it failed. And if it did, we modify the step status to failed. We once again change the metadata steps, and then we do metadata flush. We do an early stage hand close, and we also throw an error. Otherwise, if it doesn't get into the catch block, we do step.status done and metadata set steps. And we have simplified the return output. Brilliant. So very clean and surgical change. So now that our Trigger.dev task is actually outputting the status, we need to subscribe to that workflow's runs. So our next prompt is going to be the following. I want one shared subscription to this workflow's runs that any component on the canvas can read. Give me a client provider that subscribes to workflows runs in real time by their tag, which is the workflow ID. So remember when we added that inside of our actions.ts. If you scroll down, you can find run workflow action. That is why we added a tag. I told you that it's going to come in handy later. So make sure that you actually have this tag right here. Using a public access token passed in as a prop. Call it workflow runs provider. So we are creating a new provider. So we're going to wrap our entire Liveblocks room, our canvas inside of it, and then any component in there will be able to access which node is currently running and all other metadata we decide to pass through. Expose a use latest run steps hook that returns the most recent run steps plus whether it's still live, preferring the run's initial output steps and falling back to the live metadata steps. Live means the run is queued or executing. So we're going to develop a hook called use latest run steps, which will either return the metadata values or the current live values. So there is a difference. That is because Trigger.dev outputs values using their real-time hooks of the currently running task, but also preserves all the values of the previous tasks which have completed. So we're going to need to create a hook which checks if the live one is active, so it displays the most up-to-date data, or falls back to the data which is now in the metadata which we stored ourselves. You're going to see in the code. It's easier that way. And put it in the workflow features components. Use Trigger.dev real-time and front-end skill. So let's go ahead and run this prompt inside of the same conversation, which has context of what we're building. You should now have a new component inside of features workflows components called workflow runs provider. So in here, it's marked as use client, and it uses Trigger.dev React hooks, specifically use real-time runs with a tag. And in here, it does exactly what we described it, and it uses the access token. So that's the next thing which we're going to have to create a proper consolidation and cascading of that access token, which we are going to hand down as a prop. Beautiful. So use real-time runs with tag, and this is how we connect to whatever our run workflow is outputting, right? So we are currently outputting some things using metadata set and metadata flush, right? But the only way we can subscribe to that is by using the correct tag, which is workflow ID, because that is what we have set inside of our actions.ts. In here, we just have a normal use memo for the value. So we have the runs, we have the error. Perfect. This is simple enough. This isn't really a complicated function at all. And in here, we have a hook, use workflow runs. This is simply so we can access the value of this provider inside of any component we might need. And then we have this, which we requested, use latest run steps. So in here, it created a hook, which will always produce the latest run, right? So it maintains whether we are live, which are the metadata steps, and the steps. And you can see how it falls back in between the output or the metadata steps. So that's what I was talking about. Your code, your agent should have generated something similar, because Trigger.dev outputs multiple variations of their real-time status. And for the nodes which have already been finished, we need to fall back to some other value. Brilliant. So if yours is anything like this, it doesn't need to be line for line, but it should be a workflow runs provider, and it should use real-time runs with tag. Now let's actually wire this up. In the workflow page, wire up the real-time subscription. Mint a read-only public token scoped in this workflow's run tag. good for about an hour, and wrap the canvas shell in the workflow runs provider we just made. So that component we just generated. Passing in the workflow ID and that token. Use Trigger.dev real-time and front-end skill. Perfect. So in that same conversation, let's go ahead and run this prompt. So let's take a look at the modification it did to page.tsx. So far you should have 3 changes. One in the run workflow, which outputs the live status. Another in workflow runs provider, which consumes what our task is outputting, and then one change in the page inside of the workflow ID, which is responsible for creating the access token to pass to the workflow run provider so we can correctly communicate with the running task. And the reason this needs to be authenticated using the access token is so that some third party cannot maliciously look at our running tasks, of course. So we import Auth as Trigger Auth from Trigger.dev SDK. We use an alias because we already have Auth from Clerk Next.js server, and we use our new workflow runs provider. Then we generate a runs token using Trigger Auth create public token. We go ahead and give it a read access, and we tag it to the workflow ID, and we give it an expiration time of 1 hour. And then we simply wrap the workflow shell inside of the workflow runs provider, passing along the workflow ID and the access token. Perfect. Very simple, very precise. There's only one more thing we have to do, and that is to paint the nodes. So we have to modify our step node component and make each node reflect the latest run. So we have to look up this node's status using our hook, use the latest run steps, by matching the node ID. When it's running, show a spinner in place of the node's icon and give it a blue border. When it failed, give it a destructive border. Only treat a node as running while the run is actually live. If the run has ended, a node left marked running should stop spinning. So let's go ahead in the same conversation and completely finalize this feature. Let's take a look at the changes in step node component. So inside of the component, we now import use latest run steps from our workflows run provider. We import the spinner component from components UI spinner. We pass along the ID to the prop in the step node component. We destruct the steps and whether is live using use latest run steps. We extract the current status of our node by filtering or finding our exact ID of the node. We define is running if status is running, and if we extract is live from use latest run steps. And we define is failed if status is failed. And then very simply, we have modified the most outer div to change the border blue 500 if is running, and if is failed, border destructive. And if it's running, we don't render the icon, but instead we render the spinner. And then we fall back on the icon otherwise. Beautiful. So once again, very clean, simple, surgical change. Now let's test it out. If you try to enter any of your existing workflows, you will probably see an error like this. Steps.find is not a function. That is because those are existing workflows which have different metadata in them. And as you can see, we actually changed the steps from being a number to being an array with object inside. So that is why all of the previous workflows are going to fail. Let's go inside of our Neon database. Let's choose our project, tables, and in here, let's clean up everything we have in the workflows. So delete all records. I would also recommend doing the same inside of your Liveblocks dashboard, simply so you don't have any orphaned rooms. Then go ahead and construct a new workflow. Start node connected to open URL, and make sure that this one has a working URL. And then connect it to the second node, and in here, make sure you add an invalid URL. We want to test if this node actually fails. And now let's go ahead and click run. And let's see, there we go. So this node is currently in progress, and let's see what happens once we reach the open URL 2 node, to which we purposely put an incorrect URL, and as expected, this node then fails. Keep in mind that Trigger.dev has built-in retries. So what it's going to do is it's going to retry, I think, about 3 times. Let's see, yes. it's going to attempt a maximum of 3 attempts. So you will probably see this repeating, and that's another benefit of using Trigger, because otherwise this would have been a very complicated feature to implement ourselves. Amazing. And now after 3 attempts, it is stuck here. Beautiful. So we are pretty much finished with our main functionality. Now go ahead and stage, commit, and push your changes. So far, we've only developed 2 nodes, with only one of them being an action node which has some kind of execution behind it. So let's quickly take a peek at our code base. How would we go about adding a brand new node? Well, good news is all the files we have to modify are inside of features, workflows. We would start with defining a brand new executor, which is something like this open URL file which we have. Once we define a new executor, we have to register it inside of our node executors, so it satisfies the record. And then we have to register the new node inside of the node registry. So not too bad actually. We only have to modify 2 files and create 1 new file, and everything will automatically sit in its place because we built this using factory type of development, right? We don't have to modify the right sidebar. We don't have to modify the run workflow task. We essentially built small factories which do all of that for us modularly. And while that makes it easy for us to add new nodes, it also makes it very easy and deterministic for agents to add new nodes for us. So instead of instructing the agent how to do that every time, one trick that we can do is modify our agents.md or Claude.md and add the following snippet, adding a workflow node. 3 edits required, all under features, workflows, nodes. First, we create the actual implementation file, for example, the open URL, which is the node's executor logic. We then register it inside of the node executors and make sure that the satisfy contract makes a missing executor a compile error for action nodes. And then we have to add its manifest entry inside of the node registry. We define the kind, label, icon, accent, all of the input fields it's going to have, and the outputs downstream nodes can then reference. The run task and the canvas step are registry driven. Never touch them to add a node. So exactly what we just went through in our code base is what we've described here. You can of course find my agents.md file in the GitHub repository and simply copy this snippet if you don't want to pause the video and write it yourself. And now we can create prompts which are going to reliably create new nodes in our code base. I have once again prepared chapter 19 remaining nodes specification file for you, in which you can find the exact change we've added to agents.md, as well as all the prompts which we're going to add to generate new nodes. So let's execute the prompt which is going to add the act node to our code. Let's take a look at the code which was generated. So first of all, we now have a new executor called act, and it's located right next to the open URL in the nodes folder. So very similarly as to open URL, the act node accepts a stagehand instance, the instruction value, and then uses stagehand API to perform an act, whatever that is per user's instruction in the natural language. In the return, we bring back to the user whether it was successful or not, whether there's any messages, and the URL that we are now on after an act was performed. So now inside of the node executors, which is my other change, that new act executor was registered, the same as the open URL. So we pass the stagehand and we pass the instruction using values.instruction. And then inside of the node registry, I don't know which icon it's gonna choose for you. For me, it chose the pointer icon and it added an act node. It gave it a label of act, icon of pointer. It used the purple color, it seems. And fields is just a single multi-line required field called instruction. So whether yours is multi-line or not, it doesn't really matter. It's a preference for the agent. And the outputs are exactly what we output inside of the act node, success message and the URL. Now let's see if it actually works. So I'm going to open my website codewithantonio.com and I'm going to tell it to click on the browse courses button. So it should perform this right here. Let's see if it's actually going to work. So make sure that you have your Trigger development server running and your app running. And let's take a look at our latest session. So what I presume has happened is we first went on to codewithantonio.com, and then we should click on the Browse Courses button. And there we go. We clicked on the Browse Courses button and it did a redirect. Now go ahead and try chaining another action to it and make sure that you can see the output of the previous act node, which should allow you to interpolate the whatever output values the previous node has produced. Now let's go ahead and add the extract node. Once again, a stagehand powered action node with a single multi-line instruction field. It pulls data off the page described in the instruction using stagehand's exact extract method. Surface the extracted result as an output. Follow our convention for adding a node. And once again, we have the exact same output, a new executor called extract registered inside of the node executors, and then node registry has a new manifest entry called extract. The executor for the extract is quite simple. All it does is it performs stagehand extract with natural language instruction from the user and returns the output of the extraction. I would recommend performing the test for the extract node on a very simple website, for example, quotes2scrape.com, which is essentially a sandbox for web scraping. And it's also HTML, static, and very simple, so there shouldn't be any problems and you should get very deterministic outputs. So let's go ahead and run this one. So now inside of your newest Browserbase session, if you scroll down here, you will find the exact timeline, first of opening the URL, and then the result of the instruction extract 5 quotes. And you can click on output, and down here you will see 5 quotes extracted. I'd also recommend testing that if you connect any other node to the extract node, that you can actually interpolate the output of that previous extract node inside. Now let's add the observe node, which is another stagehand powered action, which doesn't do any acts or any extraction, but instead it simply finds the clickable elements and the other DOM elements on the website, which you can then use to more precisely use the act node. Make sure that the executor generated for the observe node looks something like this. So we use stagehand API to invoke the observe action, passing the natural language, which is the user's instruction, and then we simply iterate over the matches and return those matches. And you should also make sure that this is properly registered in the executors and in the node registry. To test it out, let's once again load our quotes scraping page, and let's tell our observe node to find all clickable elements. And then inside of the act node, let's go ahead and tell it click on the first item inside of our observe one matches. So I assume that this will basically give us a list of all clickable elements. So let's click on the first item that it finds. And if you visit your Browserbase session, it's going to be a bit anticlimactic because the first clickable element is the quotes to scrape button. So perhaps we should have told it to click on the second clickable element. And you can see all of that in here. So first we navigate to quotes to scrape, then we find all clickable elements, and inside of the output you can see exactly everything it found. And you can see that the first one in this array is the link quotes to scrape. So the second one would have been a login link or maybe the about link. So yes, the act node in the end just clicked on the quotes to scrape. It might have been more fun for if it clicked on maybe login or Albert Einstein, something like that. So yes, the video is going to be a bit anticlimactic, but you can actually see that it clicks on quote to scrape. But I think we've demonstrated the power of this node, right? If you want to play around, go ahead and tell it maybe to click on the second item and see what happens. Now let's develop the star of the show, the agent node, which is another stagehand powered action node with a single multi-line instruction field. It runs an autonomous multi-step browser task from one instruction, using stagehands' agent. Surface whether it succeeded, a summary message, and whether it completed as outputs. And then followed our convention for adding a node. So this is basically our super-powered node, which is able to act as if a human were navigating a website. So once again, you should have the agent executor registered in the node executors and the node registry. And my agent has generated the following executor. So once again, stagehand API, which runs the agent and runs execute on the user's instruction and returns success, message, and whether it was completed or not. So let's test our super-powered node once again in a very simple scraping sandbox, and let's tell it to log in with the username of admin and password admin. Click on the about link in the first author that appears, and then connect the extract node and extract the information about that author, and just make sure that you can see the connections from the previous node to ensure that that is working correctly. So we are purposely doing a very simple example, even though this is a very powerful node, and I'm sure you can only imagine the things you can do with this, but I recommend testing it out in a sandbox for scraping because you can get very deterministic results with this. And let's run it. And if you actually visit the session on time, you will see the live session of what your agent is currently doing. So you just saw how it entered admin as the password and the username. And you will now see the whole timeline of everything the agent did. So you can see how agent has its own access to the act node, its own access to observe, right? So that's what the agent can do. So agent is essentially all nodes in one. But if you do want more granular access, then you would combine both the agent to maybe do some long task and then do some very deterministic simple task with a specific act, observe, or in our case, extract, which now extracted the about Albert Einstein description. So you can see how useful it is to create a code base which serves as a factory for your coding agents, because this couldn't be further away from vibe coding. And yet we didn't write a single line of code for any of these tools, which work extremely reliably, and the code is exactly as we expected, because we created an environment in which coding agents perform very well. And then go ahead and stage, commit, and push your changes. Now let's use resend to add the email node to our project. Using the link on the screen, you can get onto their website, and the link simply lets them know that you came from this video. Once you create an account, go inside of API keys and create a new API key. Make sure to give it full access and all domains. Then copy your key and add it to the environment file under the name resend API key. Then go inside of the documentation and scroll down until you find the Build with AI section. In here, you can find the agent skills. Make sure that you select resend skill, as that is the one we have to install. Then go ahead and execute it in your terminal within your project. You will now be asked which skills to install. So we are not going to need the agent email inbox. We are not going to need email best practices nor the React email. We just need the resend itself, which is basically the SDK, which we're going to use to programmatically send emails using resend node. Make sure to select your coding agent and make sure to select the project installation scope and use the symbolic link and proceed with the installation. Then go ahead and perform a git add and git commit so you don't have 23 changes in here and you can more closely and precisely follow the actual changes we're going to do to our code base. Now make sure to perform a reload skills and reload window if you're using a graphical interface, and check if you have the resend skill available. Now let's prompt the following. Set up resend SDK client inside of my lib folder in the project root. Use the resend skill. You should have the following changes: a new package added to the package.json and a resend lib.
located inside of the lib folder, right next to where Liveblocks lives. You should import recent and very simply export a new instance of recent using the recent API key, which we've added in our .environment.local, so just make sure that it isn't misspelled. Now let's construct a prompt to create this into a node. As always, this prompt is available in the specification file in the specs folder called after chapter 20 email node. First, add a send email action node that sends an email through resend. No browser session, so it doesn't use stagehand. So we purposely say this because all other nodes so far have been using stagehand, so just in case the agent looks through those nodes and thinks, oh, so I need to use stagehand, let's make sure that it doesn't use stagehand explicitly. It has 3 fields, a recipient or to, like to whom we are sending, a subject, and a multi-line body. When it runs, send the email with our existing resend client. From the hard-coded address, onboarding at resend.dev. So unless you purchase a domain and add it to resend, and I think you need to be on their pro plan, you need to send emails through this domain. They don't allow sending it from any custom domains, which is perfectly fine for development. Surface the sent emails ID as an output so downstream nodes can reference it. Resend's send returns data and error and doesn't throw on API error. If there is an error, throw so the run marks this step as failed. Otherwise, the node would look successful even when the email is never sent. Follow our convention for adding a node and use the resend skill. You should now have a new implementation executor inside of the nodes folder, which uses our resend client library, calls the function send email, accepts to, subject, and body, which are all strings, extracts data and error using await resend emails.send, hardcodes from to be onboarding at resend.dev, because we need this in development, then passes along the dynamic to, subject, and HTML as the body. In case there's an error or there's no data, go ahead and manually throw an error so we properly register this as a failed node. And if successful, go ahead and simply return data ID. Make sure that you also have a new node registered in the node registry, same as in the node executor. Now go ahead and construct a workflow which ends in some kind of extract node, and then attach your new send email node to this extract node. Make the subject be something of relevance to whatever is in the extract node, same in the body, and then find the connection for that extract node and interpolate its extraction. And for the to property, you need to enter the email in which you're logged in into your resend account. So in development, you cannot send emails anywhere besides your own account which you're logged in with. So make sure you use that account. You should also see all of that information in the node itself, and then go ahead and run the workflow. Now go inside of the resend dashboard under emails, and in the sending tab, you will see exactly which email you have sent. As you can see, tutorial mailing is the address as I've entered, subject is author information, and inside I can see the about section of Albert Einstein. And we can find the same email in our Gmail inbox. And now let's go ahead and stage, commit, and push our changes. Now that we've added all the nodes, let's go ahead and develop the logs panel. The logs panel's purpose is to display to the user exactly how each workflow went. We can see that more closely in this image canvas2.png. So each run will be inside of a batch with individual steps inside. And we're going to see exactly how long each step took before it was completed, and we're gonna see if any step is in progress or if it was skipped or simply not there yet. And each run will be separated with some kind of divider. The place where we have to start developing this feature is where we actually run the task.
That is because in order to develop this component, we need to add some crucial metadata to our tasks. For example, we need to have duration, but right now, inside of our run workflow task, we don't calculate how long each step lasts. So this will be the first prompt we have to construct. We're gonna need to add some more properties so this run workflow actually tracks duration. You can find all of the prompts which I'm gonna use in this chapter inside of this specifications folder inside of chapter 21 console panel. First, let's go ahead and install a new dependency called pretty milliseconds. So let's explain to the agent what we are trying to achieve and what we need to modify first. I want a console under the canvas that shows what each run did, a list of every run and its steps, and clicking on a step shows what that step produced or its error if it failed, plus how long it took. So that's the general idea of this logs panel, a display of every single step within a run, as well as how long each step took. And clicking on any of the steps should split the logs panel in half, and then in the other half display either the JSON formatted output or the error if it failed. If a step hasn't been reached yet, it should appear inactive like this, and if it's in progress, it should be spinning. So in the first sentence, we simply give it a general idea of what we're building, and then we start with the first request, which is what we established that we need. We need to modify our run workflow task. Right now, a run step only records its node ID and status inside of run workflow. So there's nothing to show yet. Basically, if you go inside of the run workflow right now, you can see that we are kind of storing something in the metadata here, but we are just storing the node ID and we are storing the status, right, running, which is useful, but we explicitly developed this for the canvas. Right, so in the canvas, when a node is running, it appears as loading, which is useful for the logs as well, but we are missing additional metadata like the duration and the output or the error. Those are the things we now want to add to the run workflow. So that's what we described. Right now, only a few things are being recorded inside of the run workflow, so there's nothing to show yet. So make each step track everything the console will show. Which node it is, so we can display its icon and title, its status as it moves from pending to running to done or failed, how long it took, whatever it output, and its error if it threw. Basically exactly what we just described we need so we can properly develop that console panel. But right now we're just focusing on adding more things to our run workflow. Once we have all of those new things, it's important that we expose all of that run data through our workflow runs provider, because I don't know if you remember, but we don't ever explicitly directly use the Trigger.dev hooks. Instead, we developed the workflow runs provider, which uses the use real-time runs with tag. And this provider is where we keep track of everything in this value here, right? So we have available runs here, and then I believe we also developed use latest run steps, in which we kind of summarize if a step is live, and we extract the metadata of those steps. So we also need to make sure that whichever new fields we add inside of the run workflow, we also add to the workflow runs provider. So I think this is a pretty good description of what we need. And we also give it a little hint, don't build the UI yet, just get the data in place. Brilliant, and let's go ahead and now execute this prompt. Now let's review the output. Keep in mind that your outcome doesn't need to be exact as mine. It doesn't need to be a line for line identical change, but I will show you some of the things you should look out for. So the most obvious change should start from the run step, because the run step is essentially the type which describes what we are storing inside of a metadata of a run step. So previously we only had the status here and node ID, which was now extended with what we requested. We have a type, we have a title, we have duration in milliseconds, we have an output, and we have the error. So if your agent didn't do this, it might be a good idea to tell it also make sure that our runs output the error. Make sure that our runs output the output or the duration in milliseconds if it forgot to do any of those. And you can validate that simply by looking at the run step, because this is kind of the source of truth. This is the main type of the run step. So if you have anything similar to this, the names doesn't have to be exact, it's probably correct. I also have some new imports, so node type from the node registry, so I can give it the proper type. So each run step can only be start, open URL, act, extract, observe, etc. Basically our nodes. Let's take a look at the rest of the code here. So now when it iterates over the steps here, besides just getting the node, which was usually enough, it also makes sure to explicitly extract the node data type and the node data title. So previously status was enough with the node ID, but to satisfy the new run step, now it also adds the type and the title. And here's one thing that perhaps your agent didn't do at all. So my agent decided to save some time and create a helper function called publish steps. So it replaces having to do metadata.set steps every time. It also casted steps as unknown as deserialized JSON from Trigger.dev core. So this is a very unique thing. I doubt your agent did the exact same thing, but don't be afraid if it didn't. It should work just as well. This isn't required. As I can see, this is just a helper, so it doesn't have to repeat the same thing all the time. So now in all the places where we did metadata set, my agent replaced this new function publish steps. All of this is left unchanged, and as you can see, every time it does metadata set steps, it just calls publish the steps, right? We change it to running, now publish it. Let's scroll down. This is how it calculates how long my step actually lasts. So it develops a new constant started at using date.now, and then inside of the, let's find it, here it is. If it catches, meaning if it's inside of an error, it starts the calculation of the duration. So because it failed, so we need to calculate date now minus started at, and it populates duration milliseconds. It populates the error, right? That's what we wanted, because previously the only thing we populated was the status, but now we populate the duration, the error, and we publish the steps. In the successful run, here's what we do. Previously, we just did await executor and we stored it inside of an ID in the outputs object. But now we extract the output in its own variable, and then we do the same thing as we did before. We store the output in the ID of the outputs object, but we also add it to the step.output so it can be published using the publish steps. So exactly what we described is happening. We are now sending to the front end using the metadata inside of this step, the output, the duration, the error, the type, the title. All of that is what we need. And here we have one more calculation of the duration millisecond. So this one happens if a step fails, and this one happens if it successfully completes. And that is the entire change. So it looks like a lot of things have changed, but when you dissect it, it's actually not that much. Now let's go inside of our run workflows run provider. So in here, what I expect is some kind of additional helpers, maybe like this. I doubt it's going to be exactly the same, and I promise you don't have to worry about your code being different, because we are going to add more prompts to this conversation that we are having, so your agent will be aware of the changes it just created. For example, mine created a new hook called use console runs, and in here it uses the use workflow runs, extracts the runs, and then it goes over the runs, sorts them by created at, so the latest one appears at the top, and then creates an object with an ID, status, created at, is live, and steps for a run. Your agent probably achieved something similar, but it doesn't need to be exactly like this, right? But you should definitely see some changes in the workflow runs provider here. Great, so now let's go to the second step. So now that we've added the necessary outputs to the run workflow task and we have attached them to our workflow runs provider, let's build the UI. So build a console panel below the canvas that lists workflow runs, every run, and below it, its steps. Each step shows its node's icon, its title, and how long it took. Format the duration with pretty milliseconds, which is a package we added. A step spins while it's running, turns red if it failed, and looks inactive if it never run. Clicking a step selects it, clicking again deselects. The accent-colored node icon already exists as node icon inside of the right sidebar. Reuse it instead of building another. So if you take a look at the right sidebar component, you will see that in here we actually have a function called node icon. And I think it's perfect to reuse for what we need right here. I think I still have the picture open. There we go. You can see that this icon is identical to the one we have in both in the step node, but also in the right sidebar. Perhaps the one in the right sidebar is even more perfect because it's smaller for this. So that's why I'm telling you can go inside of the right sidebar component and reuse that instead of creating a new one. And then I tell it, build the run list as a logs panel and wrap it in a console panel that owns the selection. Both new components in the workflow features components folder. Then mount the console panel inside of the workflow shell component where it currently shows a logs placeholder. So let's go ahead and simply visit that workflow shell component. So that's the resizable panel that we have, right? And the only thing we have right now is a text which says logs. So this is the place it needs to populate and develop that console panel and use our new hooks to display the run data inside. So I think this is a pretty good description of what we want. And this is how agentic coding is usually done. You focus on the outcome rather than knowing every single little thing that we are going to develop. Obviously in here I'm kind of nudging it into the name of the components that I want, so both you and I have the same named components, because in the next prompts that we're going to do, we're probably going to reference those new components. So that's why I'm being very explicit with my naming. But usually when you are doing agentic coding, you wouldn't know the name of the component, you would let the agent name it whatever you want. But because I want to make this easier for you to follow and more deterministic, I'm being very explicit about the name of the components that I want. So once again, you can find all of these prompts inside of the specifications folder in our GitHub repository. Just look for chapter, this would be 21 console panel. And let's execute this prompt. After the prompt finishes, the first thing you might see in your app is that all existing workflows are now breaking, and that is expected. In fact, this would have happened if you tried running your app after we run the first prompt, and that is because we fundamentally changed the definition of what step outputs. So if you see this, don't worry, just go ahead and create a brand new workflow. So first, let's test how this looks visually, and then we'll look at the code. So you can compare both your UI and functionality, and you can compare your code to what my agent did. So the empty panel looks like this. It simply says no runs yet. I'm okay with this. And what happens when I actually run something? Well, I've did that here. So it displays all of the steps which happened. It also shows that this open URL took 7 seconds, for example. And you can see that when I click on it, it stays selected, right? Unless I click again, then it's deselected. One bug I can see happening is, which I think was actually introduced in our first prompt, and that is because I told it to make sure that all nodes which weren't reached display as inactive. And the start node is technically never reached because there's no executor. So maybe you have this bug as well where your start node looks disabled. We can fix that later. And let me go ahead and do one more run so you can see how this happens. So right now it's executing, you can see the start, and you can see how it's currently spinning the open URL. So this state in the canvas and this state right here are both synchronized. And once it finishes, you can see that both of them get in their finished state. So that is the UI and the functionality, and hopefully yours looks somewhat similar to this. And now let's quickly take a peek at the code. So inside of the workflow shell component, you should now have replaced the previous logs to do temporary paragraph with a proper component called console panel. Now inside of that console panel, it could be different for you, but here's what my agent did. So first of all, it's a client component because inside of the console panel, it maintains which step is currently selected. It also developed a toggle function here. Whether yours did this or not doesn't really matter as long as the functionality works. And the only thing it returns is the logs panel. And in here, it sends the currently selected node, and it also sends the unselected step, which is the toggle. And then inside of the new logs panel, this is where we have all of the functionality needed to display each step in a row. So this is mostly just UI and cosmetics about this. So is selected, is inactive, is running, which changes to spinner. That's kind of one thing I don't like. I would prefer if is running displayed the spinner in place of the icon, but not by replacing the entire component. But it's okay. I want to focus on polishing those things later, because for now I just want to focus on the big picture stuff, okay? And you should see somewhere in here the pretty milliseconds or pretty ms import from the package which we installed. And in here we have the actual logs panel, which uses our hook use console runs. Now, whatever your agent modified in the workflow runs provider is probably what it's going to be using here to display these runs. But essentially, as long as you can see all of those things which we attached to the run using the step metadata in the run workflow, you should now start seeing here, right? So far we've only had the ID, but now we should also have step title, step duration, step type, right? Things like that. As long as you see that, it's probably okay. And in here we have some calculated fields like is running, is failed, is inactive. So that is kind of the general gist of how this component should look like. And I think at this point, both you and I hopefully are getting deterministic changes. Obviously the UI can vary a bit depending on which agent you're using, but because we have such a large code base right now, chances are that the agent did this correctly, because we first started with the run workflow, then we modified the workflow provider, and only now we are doing the UI. So the agent really understands what we are trying to achieve. So now let's go ahead and continue to step 3. So the last thing we need is that when we click on a step in the logs panel, some output shows in the other half of that console panel. So the workflow console below the canvas, which we just developed, the console panel.tsx, lists each run's steps and lets you select one. Add an output view showing the selected steps result, its output as formatted JSON, its error if it failed, or a short note when there's nothing. Build it as an inspector panel component in the workflow features components folder, rendered inside the console panel next to the logs and only while a step is selected. Let's run this. So to test if your agent developed this correctly, go ahead and select any of your steps. And what you should see now is an inspector panel component which renders a formatted JSON of that node's output. And with this inspector panel, I can also debug what's actually happening with my start node, because all of them appear as inactive and looks like my fear was correct. We have a bug. So because the start node doesn't have an executor, it is never considered done. So I assume this is the fault inside of the run workflow, because when we append metadata to these steps, the step without the executor never gets assigned as running, because we never even reach this whole code block. So that's why it probably always appears as skipped or not yet reached. So let's go through some other bugs that I have. Now, you probably don't have the exact same look or functionality, but as long as you have a panel where you can see your runs and your steps, and you can click on individual steps and you can see their outputs, it is good. And now what I'm going to teach you is how I approach fixing bugs when agentic coding doesn't produce something exactly as I imagined. So the first bug I have is this start node being skipped or considered skipped. The second bug I have is when I click run, my spinning node looks like this. But what I would rather prefer is that if it kept this green background and then if it spun inside rather than replacing the entire thing. I think it looks prettier. And another kind of a bug which I have is that these two components aren't put together using resizable panels like the rest of my layout, so I can't resize them. So now I'm going to show you how I would prompt to fix this small little bugs. So if you happen to have any similar bugs, you can follow along, or if you have some other bugs, in that case, you can adapt my prompts to your specific problems. But the overall functionality of what we wanted to achieve in this chapter is officially functional. I would also recommend testing this new console panel on a more complicated workflow like this one, just to see if all nodes are correctly rendered here. So you can see how my agent renders all of the steps which are going to happen and keeps them inactive until they are either in progress or they are finished. So this even more shows how this initial start node is a bug because it infinitely appears as inactive. But I think this looks super cool, especially with how synchronized everything is, and that is because we used our workflow runs provider both in the canvas and in here. And let's quickly take a look at the output. I think this is really cool, and there we go. I can even see when it didn't manage to do something. Perfect. So this is how useful this inspector panel is, because then you can see when something goes wrong. This technically isn't an error. The agent simply didn't succeed at what we told it to do. So perhaps we could capture this success, and if it's not true, we could manually throw an error if you think that should be a failed node. But keep in mind that then Trigger will retry that step, which can waste a lot of tokens. So sometimes maybe the user simply prompted something that makes no sense. For example, maybe I forgot completely what I can see on this page right here, and I couldn't extract this. And also make sure to test one invalid node simply to see how an error looks like. So I just put invalid URL in here, and let's see what happens now. There we go. Error, cannot navigate to invalid URL. And you can see how when it retries, it actually resets the output. So the culprit behind the bug in which my start nodes are marked as not run yet is inside of the run workflow. Specifically, when we try to extract the executor from the node executor, I then do, if there is no executor, simply continue, meaning that it never reaches the status of running. We can fix that with a simple prompt. In my run workflow, a node with no executor, for example, the start trigger, hits if no executor continue, while still pending. So it shows as skipped forever, and its inspector says it hasn't run. Instead of skipping it, mark that step as done and publish before continuing. The trigger does no work and has no output, so it should be read as completed. And the fix was very easy. So instead of immediately continuing, what we now do is we set the steps status to done and we publish the steps, and then we continue. So if I try running this inside a brand new workflow, hopefully the start step will now appear as immediately executed. And we even have the correct comment here. This step produced no output. Now I want to fix the running step. So I want to fix how this looks. So what I'm going to tell it to do is to extract node icon from the right sidebar component into its own file in the workflows components folder, and then update the right sidebar, update the logs panel and the new inspector panel to all imported from there. Then add a new running prop to the node icon, which we're now going to extract, that shows a spinner inside the accent chip, so it preserved the background color in place of the icon, and use it in the logs list. So a running step spins inside its colored chip instead of as a bare spinner, which is precisely the issue I have right now. So we've now extracted the component node icon from right sidebar into its own node icon component inside of features workflows. And as instructed, we now have a running prop, which simply switches the icon for the spinner, but preserves the entire colored accent background. So if we test it out on a new run, the spinner should now look exactly as in the canvas. The last problem I have is the fact that these two panels aren't resizable. So the culprit is inside of the console panel, because this is where we maintain the selected step. So when a step is selected, all we do is we render a div which renders the inspector panel, and we maintain 50/50 layout using flex. So now I'm going to prompt to replace this with resizable panels. So inside of the console panel component, replace the plain flex split between logs and the inspector with a horizontal resizable panel group and the drag handle from our components UI resizable. Keep the inspector rendered only while a step is selected. And there we go. I can now resize either my logs panel or my inspector panel. And the console panel code now uses resizable components from chassis and UI. So we established a new resizable panel group, and then we render the logs panel inside of one resizable panel and inspector panel inside a dynamically rendered other resizable panel. So now let's go ahead and git stage, git commit, and git push our changes. So we've now developed the console panel, which displays all steps from individual runs. But one thing we cannot use the inspector panel for is to review the replay of the entire workflow. And that is something that Browserbase actually offers under their observability API. Now, even though we added Browserbase skills in the chapter where we set it up, those skills actually only refer to the browser CLI usage. It doesn't actually refer to API or SDK programmatic usage of Browserbase. So because of that, what I'd recommend is that you learn your way around Browserbase documentation and go ahead and find their observability right here. So make sure that you have access to the URL of the observability and find specifically session replay as well. So make sure you can find those two documentation pages. To let our agent know exactly which documentation it should look for while we build the session replays, let's go inside of our agents.md and let's add a new block here. So I'm gonna add Browserbase observability. Session recordings, replays, live view, and logs come from the core Browserbase SDK, and then we name that package, not stagehand. Before building any observability feature, consult Browserbase's observability documentation, and then I paste the overview of the observability. So that's this URL. Session replays specifically, retrieving a session's recording as an HLS playlist is documented here. And then I pasted the session replay documentation. So when you copy and paste this from my agents MD file, just make sure that the URLs haven't changed and that they don't point to 404. And we also just give it some additional info. The retrieval needs the secret API key, so it must be proxied server-side. This is also an important hint. Given that the session replay API provides us with an HLS playlist, we need to install a dependency called hls.js. So where do we start developing this feature? Well, the answer is inside of our run workflow task. So similarly as to how we updated this long-running task previously for our console panel with all the relevant information like node type, node title, status, duration in milliseconds error, and the output, we now have to add one more thing to this long-running task, and that is the session ID every time stagehand is initialized. But here's the thing. So far, we've only been adding properties to individual steps, but the session replay is the same for all steps because session replay is tied to the entire workflow, not just for individual steps. So unfortunately, yes, we cannot see a replay of every single step. We cannot just see a replay of OpenURL. We cannot see a replay of only agent node. But we can see a replay of the entire thing and how it went together. So let's go ahead and construct a prompt to modify our run workflow to make that work. As always, I've prepared all the prompts that we're going to use in this chapter inside of the chapter 22. You can also find the agents.md, you can find what we have to install. So let's first capture the session ID and let's review this prompt. A run records its steps, but not the browser session that it drove. So there's no way to replay what happened. So inside of our run workflow.ts, capture the browser-based session ID when the run opens its session and return it alongside the steps. Then surface that session ID on each run inside of our workflow's run provider. So remember, that's our data flow. It starts with the run workflow long-running tasks, and then the workflow's run provider optimizes it or basically makes the data compatible with what we need in our UI. So a panel can read it, in other words, right? It only exists once the run has finished. The recording lags on the session close. So read it from the run's final output, not in the live metadata. So this part right here is, if you remember, long-running tasks from Trigger give us an option to read the data either from the final output or from the live metadata. So we need to choose which one we're going to use depending on which one is available. But for the session replay, we have to rely on the final output because it's not going to exist during the run because it's not yet finished, it's not yet created. So that's why we explicitly write this. Let's go ahead and run this and let's look at the changes. So the first modification you should have is inside of the run workflow file. So alongside initializing stagehand, we should now also initialize the Browserbase session ID. And then once get stagehand runs and once we initialize it, all we do is we extract the Browserbase session ID and we store it inside of that new variable we've created, Browserbase session ID. And all we have to do in the end is return it alongside the steps. That's it. That's everything needed modified inside of the run workflow. And inside of the workflows run provider, again, it depends how your agent is working with this provider. I'm pretty sure agents have various ways of achieving this, but as long as you can now see that your provider is accessing the Browserbase session ID, everything should be fine. You don't really have to worry about how it's doing that, and it doesn't need to be exactly the same as mine. So here's how mine did it. In this use console runs, which it developed for me, it added a new property, Browserbase session ID. So automatically all of my components which use this hook now have access to the Browserbase session ID, and it looks like it generates that using the session ID for run. And in here, it specifically goes through my run and then through the output. So that's that hint that we gave it, right? Don't look through the live metadata, use the final output. So the output variable in the trigger run is what's finished, while the metadata is used to see if something is live, right? That's why you can see how sometimes we look through metadata and then fall back to output if it doesn't exist. But as long as you can now see the Browserbase session ID within your workflow runs provider, it means that it's been added here. Now in the same conversation, let's construct the API endpoint, which is going to serve as a proxy for fetching the HLS playlist, because we cannot directly just access this Browserbase session replay. We need to create a proxy from our own server to achieve that. So given a Browserbase session ID, play back that session's recording. Browserbase serves the recording as an HLS playlist, and fetching it needs the secret API key, so it has to be proxied server-side. Add a route at app folder API replays and then dynamic session ID that retrieves the session's replay playlist through Browserbase SDK and returns it, available only to the currently signed-in organization. That's also why we need to create our own endpoint, to make sure that no one can hijack another organization's workflow replay. That would be a very big breach. Our agents.md file, which we modified at the beginning of this chapter, points to the Browserbase documentation for the retrieval API. So that's why I told you to add that. The recording isn't ready the instant the session closes. Browserbase answers with a not ready status until it is. Have the route pass that through and build a session replay component in the workflow components folder that polls the route until the playlist is ready and then plays it using new dependency which we've added, hls.js. So this prompt is both going to create the API endpoint and a new session replay component which we're going to use to render in the console panel. And we also say, don't wire it into the console yet. Just get playback working from a session ID. Okay, so no wiring of this component yet. I just want to see it created. Because we pointed the agent to our agents.md file, you should now see web fetches to those URLs which we've added. You should now have a new API endpoint under API replace session ID. In here, we import auth from clerk, not found error from Browserbase SDK. And here's one thing that perhaps your agent didn't do. So my agent decided to create a separate lib for Browserbase. And it's just a simple initialization of Browserbase. So I actually saw during its output, it took a look at how Liveblocks and resend was initialized, and it decided, okay, I'm gonna do the same for Browserbase. So if your agent didn't do that and instead it initialized it here inline, it's honestly okay, because it's actually the only place where we initialize Browserbase like that. In our run workflow task, we need to initialize it in a function because it needs to be preserved through the entire task, right? So however your agent decided to add the Browserbase SDK in this API endpoint, is correct. In here, I have a small comment about what this actually does. So it's important that this is a get function. We skip the first param, which is the request, and then we go into the actual params from which we can extract the session ID from its URL actually. Then we use clerks auth to extract the user ID and organization ID and make sure to throw if it's not available. We extract the session ID from the params here, and then we simply use the Browserbase API to retrieve the replays. And then here's how it decided to find the exact replay we need. So it found the first page. If it's not available, it threw. And then it found the playlist itself. I'm guessing using the first page variable from above and then passing the page ID along with the session ID. Then it turned that playlist into text, which got us this constant right here. And then all we do is we return that back with content type application and then this specific value inside, cache control, no store. So I'm assuming this is a mix of knowledge of Next.js and how it's supposed to return things, and our agents.md, which pointed it to the documentation page. So if your agent didn't add any headers, perhaps ask it, do we need any headers for the M3U8 HLS playlist? And then it will maybe add the correct headers, but maybe it can work without headers as well. And I also happen to have a catch error here, and in case it's not found error, we simply return this status. So that's how my agent developed the API route. Yours can of course slightly vary, but as long as you can see browser-based session replace, retrieve page, and something like this happening, it's probably correct. Now let's go inside of the second modification, which is a new component called session replay inside of the workflow components. So in here, what the first thing you should see is that it uses the import from HLS, and however your developed, the polling is okay. So mine decided to set up a poll interval for every 2 seconds because the endpoint, which we just developed, the API replace session ID, might not immediately be available. So when the user renders the session replay, what it's going to do is inside of the use effect here, it's going to wait for playlist. And I'm guessing this will repeat every 2 seconds until it reaches it. And make sure that you have, if you do have that kind of polling, make sure that you have a proper cleanup function like this one. Great, so we have that. We use the HLS library here to attach the media to the video, which I'm guessing is a component like this one. So make sure that you just have some kind of component which renders the HLS here, and then perhaps you did the loading status, perhaps it did the error status, perhaps it did the unsupported status, maybe it didn't. You can slightly nudge it if you want that to appear. Perfect. So you should now have at minimum these 2 changes, new API endpoint and a new component, and maybe even a third change if your agent decided to separate the browser-based client initialization. So now how do we surface that new session replay component inside of our console component? Well, my first idea was to have it available in every node that we click on. We cannot really make it only available for one node because, again, the replay is for the entire run, not just for a single step, okay? So my idea is to add a dummy node at the bottom called replay. Pretend like it's a step, and it's always going to be the last step of any workflow we create. And then once we click on that new step, which we're going to create, which we're going to kind of mock, instead of formatted output or formatted error, we're just going to render that session replay component, which renders the video, right? I think that's a good idea because then it is encapsulated and scoped per run, and the UX isn't confusing, and every user will see that there is like an additional step for every run that they do. And since we're going to name it replay, it's kind of going to make sense. So let's go ahead and create a prompt for that, once again in the same conversation, so your agent has all the context available. Each finished run has a recording now. Let's surface it to the console. So inside of our logs panel component, add a single replay row under each run that has a recording. Its session ID is present and the run has finished. So that is the criteria for displaying this fake step which we are developing. It sits with the step rows and is selectable the same way, but it stands for the whole run, not one step. So exactly what I was just explaining. This replay step is essentially just a good user experience so that it makes sense for them. Okay, how do I see this runs replay? Obviously, it would have been easier if we had an option to see the replay of an individual step, but unfortunately we don't, so we have to figure out a solution like this. Selecting it should play that runs recording in the output panel. In the inspector panel.tsx component, render the session replay for the run session ID instead of a steps output when the replay row is selected. So exactly what we said we want. When you click on that new row, let's render that new component of ours and not the output or the error. The console currently tracks the selection as run ID plus node ID. That's the console panel. Extended so a selection can be either a step or a runs replay with only one active at the time. Perfect. That should wrap up this feature. So now go ahead and create a brand new workflow. Remember that every time we do some modifications in the run workflow task, since we don't really do backwards compatibility at this point, perhaps some older workflows might have some errors. So you're just going to have to clean those up. But your new workflows shouldn't have any errors at all. So go ahead and create something that opens the URL and perhaps maybe calls an agent. Then make sure that you have your dev server running and your Next.js server running and click on run. And now you should see a brand new step row after the usual nodes which you would expect. This is the replay row, whose purpose is to load that proxy API route we've just created and then display the HLS video replay of what just happened. And then go ahead and git add, git commit, and git push your changes. Now let's learn how to monetize our app using clerk billing. Let's run the following prompt. Using the clerk billing skill, turn on clerk billing for this app. It's organization-based, so enable it for organizations and add a pro plan that orgs can subscribe to. And let's also add a safeguard. This is configuration only. Enable billing and create the plan, nothing else. Don't write any app code or build a pricing or billing screen yet. We'll do that next. So with this first prompt, we just want to enable clerk billing and create a pro plan. And we can do that using the clerk billing skill, which has access to the clerk CLI. Depending on the agent you have, it might ask you a question about the pro plan price. In my previous runs of this prompt, when I was just testing it out, it actually didn't ask me and it simply set the price to be $20. So if your agent didn't ask you, that's perfectly fine. If it did, choose any amount you think it's fair for this project. Once the agent finishes, you shouldn't see any code changes in your project because this was pure configuration. So billing is now enabled for organizations within our project, and a pro organization plan has been created with a slug pro and a $20 per month price. So if your agent failed to do this, don't worry, you can do that manually by going inside of your project in Clerk and head to Billing tab. Since I just enabled billing using the skill, if I refresh, this page is no longer going to show onboarding, but instead it's going to show this. So if that's what you see, it's configured correctly. Otherwise, go inside of the Configure tab, and in here you will also find billing. Make sure that Enable Organization Billing is selected. From here, you can also manage the plans. The free plan is here automatically. The one you should have added is the Pro plan. What's important here is that the key is Pro, as this is how you can programmatically reference this plan. The description doesn't really matter, make sure it's publicly available, and then just go ahead and set any price you want. Now let's build the UI and a reusable hook which we can use to tell us whether the current organization is in a Pro plan or not. So once again, using the clerk billing skill, build the pricing page. Put it in the app's dashboard route group so it sits inside the dashboard layout. Show the organization plans and let them subscribe and check out. We are about to gate a few things behind Pro, so also add a reusable hook in the workflow features hooks folder that tells a component whether the active organization is on Pro and can send someone to that pricing page to upgrade. You should now have two files created. The first one being the actual billing page located within the dashboard route group. You can now visit that page by going to localhost 3000 billing. The UI can of course differ depending on the agent that you are using, but as long as you can see the pricing table being rendered and a prop for organization, it means the implementation is correct. The second file your agent should create is the use pro plan or any similarly named hook, which is used to verify whether the currently active organization is subscribed to the pro plan or not. The implementation of this hook can differ, but what's important is that you can find the logic which extracts the has util, which we can then use to check for the actual plan property. And we should check for the pro key because that's exactly what we named our plan. So if you gave your plan another key, make sure to add it here. But if you're doing all of this in the same conversation, your agent will be aware of the name of your plan. And if this plan is not active, it should redirect the user to the newly created billing page. Now it's a personal preference whether you want this billing page to be accessible through the sidebar as well. Perhaps your agent already added it here. There is another way users can access the billing configuration without visiting this page, and that is through the actual organization settings. So they can now find the billing in here. So that's why I feel like it's not necessary to create an actual sidebar item. Believe it or not, that's everything we need to pretty much progate anything you can think of. For example, how about we make the agent node, our most expensive node, only available to premium organizations? Let's try the following prompt. The agent node is our most expensive node, so make it premium. Only organizations on the Pro plan can add it to the canvas. Every other node stays free, so anyone can still build workflows. So I tell the agent, go inside of the right sidebar, where the toolbar lists every node you can add. For a non-pro organization, the agent node shows as locked, and clicking it sends them to the upgrade instead of adding it. Use our new pro gate hook. The output should look something like this. Inside of your toolbar, when you find the agent node, you should have some kind of indicator that it's currently locked for a free organization. So what my agent did is it added a simple lock on the right side, and clicking on the agent doesn't add it to the canvas, but instead redirects me to the billing plan. There are many ways your agent could have implemented this. For example, my agent opted for a very simple set of premium nodes maintained inside of the right sidebar. Personally, I think it might be more modular to modify our node registry and then maintain which of these nodes is premium from here, because then we can also gate it on the backend. But that is for further discussion with your agent. What I wanted to show to you is that you can now reliably use agentic coding with just a very simple setup and a set of clerk billing skills. Now go ahead and proceed with the checkout and then go back inside of your canvas, and once you try adding the agent node, everything should work fine like it did initially. And then verify whether this is actually scoped per organization by switching to another organization and try creating a new workflow. And in here, you should see the agent being locked once again, unless you go back to the previous organization in which you are on the Pro plan, which makes the agent node available to everyone in the team. Now that you've learned how to protect the agent node, you pretty much have limitless options as to what else you want to monetize with clerk billing. For example, try asking your agent to only allow a total of 5 free workflows for every organization before being prompted to upgrade. Or maybe allow an unlimited amount of workflows, but limit every canvas to a certain amount of nodes. Or maybe try to find attractive features like session replay and make that only available for premium organizations. The only limit is your imagination. And that's the whole point of agentic coding. A combination of being completely in control and saving ourselves from doing some tedious work by asking the agent to do it inside of a stable code base, which means it's going to produce deterministic results. I would highly advise you to try and experiment and protect some feature yourself. For example, I really like the idea of a session replay only being available to premium organizations because I feel like that's a premium feature. So I'm gonna try it out using the following prompt. I wanna show you one useful trick you can do with clerk billing. Go inside of your billing tab and find the organization in which you have subscribed to the Pro plan. Usually it can be a bit tedious testing out if a plan cancels or if it ends. Luckily, Clerk gives you a super simple end subscription now, which can basically simulate unsubscribing so you have a clean slate once again and don't have to create new organizations over and over again. And here's the result of the prompt which I ran. The replay row now also has the lock icon. And when I click on it, I'm redirected to the billing page. Here's another idea. So even though the agent node is technically locked, if I have an older workflow, which already has the agent nodes, I can still run it. So let's create a prompt to fix that. Inside of my actions, stop the run workflow action from running a workflow that contains an agent node unless the organization is on the Pro plan. Throw for a non-Pro organization. Do this check in the action, not the run task. The action has the clerk session and the has API util. The Trigger.dev task has no auth context. Use the clerk billing skill for the plan check. So now even if you try running a workflow from previous session where you had access to the agent node, it's going to throw an error. The agent node requires the Pro plan. Once you're done monetizing your features, go ahead and stage, commit, and push your changes. It's time to prepare our app for production. So let's go ahead and add Sentry to our project. Using the link on the screen, you can get a special offer where you and your team can get Sentry for 3 months completely for free, as well as 150,000 errors included. Now let's use Sentry's Agentic setup. So instead of creating a new project, head into the resources where you can find documentation. And up in the toolbar, go ahead and find AI. And select the agent plugin documentation. Now let's run their setup command inside of our project. Now go ahead and choose which coding agent you are using. By default, all 3 are selected: Claude Code, Codex, and Cursor. If you want to, you can leave it like this, so whoever in your team uses a different coding agent will have the same Sentry AI setup. Then go ahead and restart your coding agent, or if you're using it within IDE like I am, go ahead and reload window. Then confirm that within your coding agent, you now have a bunch of Sentry commands available. For the next step, I'd actually recommend going inside of the command line interface rather than using a graphical interface. Then go ahead and search for MCP servers. Then scroll down until you find plugin Sentry and then select Authenticate. The reason I'm telling you to do this through a command line interface rather than through a graphical interface is because I've had several unsuccessful attempts at authenticating an MCP server through the graphical interface, but through the command line interface, it worked on the first try. Make sure that you select all of these options and click approve, and then approve once again. Once you've successfully authenticated the Sentry MCP, go ahead and run Sentry get started. Since we switched from a graphical interface to the command line interface, we have to manually approve tool use. Or you can use Shift Tab to switch to auto mode here. So you can see it written in the lower left corner, which is the equivalent of what we had in the graphical interface, which is gonna let Claude Code automatically approve tool use. The Sentry agent will now find your team and it's gonna look through your projects. And it's probably gonna ask you to create a new Sentry project. Since it read the browser automation directory name from my codebase, it will probably provide you with the name of your codebase as well. And that's what I'm gonna choose, browser automation, as my new Sentry project name. You should now have Sentry fully set up in your project, and you should have a brand new project added in your Sentry dashboard. My agent also developed a temporary API Sentry check endpoint, and it attempted to throw an error within it. So now, if I go inside of my issues, I can actually see that error being handled. So from now on, every single error we have in our application will immediately be monitored in the Sentry dashboard. The actual Sentry setup should consist of files like Sentry Edge config, Sentry server config, the global error, a modification to the proxy, so now it includes the monitoring, package.json, which includes the Sentry package, next config, which includes the with Sentry config with your Sentry information. And you should also have additional files like instrumentation. For example, go ahead and use a free organization to run a workflow which uses premium nodes. As you know, that throws an error in our app, which is now actually visible in Sentry. So every single error that gets thrown will eventually surface in the Sentry. And you can see the exact stack trace, exactly what made that error happen, helping you debug and categorize whether this is a bug or expected error. This is a pretty good place to create a checkpoint with a commit. Now you can run prompts like this. Add Sentry logging to all relevant places in our codebase, but avoid adding it to the tasks folder, as that is run in Trigger.dev, which is a separate environment. We can connect the two later. So essentially what I want now is the Sentry agent to go through our entire codebase and to add relevant places to invoke Sentry logger. Sentry logging is another feature of Sentry, as useful as their errors, and in fact they go hand in hand together, because just seeing the error is useful, but it would have been more useful if we had proper logs in place which then connect in this stack trace, and the logs will tell you exactly which user tried something or which team tried something, whether the team was on the pro plan, on the free plan, whether they were trying to add an agent node or some other node. So that's what logs are extremely useful for. So instead of adding it to our codebase ourselves, let's just use the agent to do that. So add Sentry logging to all relevant places in our codebase, but avoid adding it to the tasks simply because that is run inside of Trigger.dev, which currently doesn't have access to Sentry. So I'm purposely leaving it out. With such a simple prompt, we've now improved the logging and monitoring in our app, making it that much safer and ready for production. Let's take a look at the actions file. This is where all of our server actions are developed. A new Sentry import was added. Let's take a look at the create workflow action. At the beginning of the action, Sentry is setting the attributes and defining which action this is, create workflow action, as well as adding the current organization ID to the scope. So every subsequent log which gets monitored will have that previous scope as well. Now let's scroll a bit down. Take a look at everything that's being logged. For example, if a user attempts to delete the workflow and it wasn't found, Sentry agent has added a log here, workflow delete skipped, not found. At first, this doesn't seem like such useful information, but if you start noticing the same ID and an invalid organization ID who doesn't belong in that workflow, all the time in your dashboard, it might indicate that something is wrong with your UI and somehow it's deleting the workflow from another organization. That's why it's so useful to have these types of information, because you will see anomalies. Scroll a bit down and you will find all kinds of interesting information added. For example, whenever we throw an error that the agent node requires the pro plan, Sentry now warns us about that as well. So we can see exactly which errors appear more and which appear less. And if you scroll down, you will find even more useful information. And this is just in the actions file. Take a look at our API endpoints. All of them now also have the attributes and another useful logging here. Session replay denied, pro plan required. So we are basically on top of every single thing that's happening. Every time that we successfully serve a session replay, we load the exact session ID for which organization on which page count of the browser-based session that was. Now take a look at the Liveblocks. We did the same thing here. If we attempt to authenticate with Liveblocks with incorrect user IDs, we simply throw an error here as well, but now we also warn it in Sentry. So every single thing that's happening in your app is now logged and you are aware of it. So if you now go ahead and just use your app, you don't even have to do anything special, and then go ahead and revisit your Explore logs. In here, you will start to notice every single thing happening. So I ran a few workflows, triggered a few errors, and now I'm gonna go back to the logs page. Take a look at this. You can actually see how your app breathes now. Every single thing that happened, every time a Liveblocks user was identified or resolved, every time a workflow run was denied, we keep track of everything. Now let's go ahead and stage and commit these changes as well. At this point, we're using Sentry to track some of the most important parts of our app, but we're still not tracking the actual background run. So let's go inside of Features, Tasks, Run Workflow. It would be great if somehow we managed to log every single thing that's happening inside of Trigger.dev. Now we have to be careful here because Trigger.dev is a separate environment, not in our current Node.js or Next.js server. So how exactly do we connect the two in that case? Go ahead and search for Sentry and Trigger.dev, and that will take you to Trigger example Sentry error tracking. And what you can do here is simply copy the entire page. Then go ahead and tell your agent to integrate Sentry with Trigger and paste the entire documentation you just found. So what should happen right now is a new dependency being added, Sentry node, and another one called Sentry sbuild plugin. Then you should have a trigger config modified, which uses those new dependencies to modify the build property, add extensions, sbuild plugin, and then use the Sentry sbuild plugin. You should recognize your organization and your project. The only thing we have to obtain is the Sentry Auth token. You should now also find init.ts inside of the features. Now this isn't the best location for it. The reason it put the file here is because inside of Trigger.dev, if you remember, let me find it, my apologies, Trigger.config, we set the features directory to be the one where Trigger is initialized. So technically, yes, this is correct place to put it, but perhaps it would have been better if it's inside of tasks. But for now, it's okay if it's here. And as you can see, we have registered trigger tasks so that every single time a failure happens, we log it to Sentry. For example, an open URL node with an invalid URL is now getting logged to Sentry as well. So every single thing that happens in your trigger run will now be logged in Sentry. So you have one unified place for all of your errors and all of your monitoring. To obtain the Sentry Auth token, go inside of Settings, Organization, and scroll down until you find Organization Tokens, and go ahead and click Create New Token. Give this a name, Trigger.dev, and then Create Token. Then go ahead and copy it, and then go inside of your .environment.local and add a new field, Sentry Auth token, and paste it here. The rest of the environment properties like Sentry DSN and Node Environment already exist in your project. So these are the ones mentioned inside of init.ts, which I just mentioned, it's awkwardly put in the features folder. So the only one we actually have to take care of is inside of the Trigger.config, which is the Sentry Auth token. So just make sure you didn't misspell it and that your agent actually uses this environment variable and added it here. It might be a good idea to restart your development server and to restart your Trigger.dev server. Now go ahead and purposely add an invalid URL to the open URL node. This is the easiest way to make this node fail. And let's go ahead and run. Now go inside of your Trigger.dev dashboard, and in your recent run, you should see a failing task. Cannot navigate to invalid URL. And because we have connected the two, the same error now appears in Sentry. So you officially have one place with all errors, monitoring, logging, and observability. Now let's go ahead and stage and commit our changes. It's been a while since we updated our Railway deployment with our newest environment variable keys. So let's make sure that we copy the latest ones and add them to our Railway service. Those will be recent API key, next public Sentry DSN, Sentry DSN, and Sentry Auth token. So go inside of variables, raw editor, and the last one, as you can see, is Browserbase API key. So let's simply add resend, next public Sentry, Sentry, and Sentry Auth token, and then deploy. And if you haven't already, make sure that you push your newest changes. Before we do the final deployment and officially end this tutorial, let's tie up a few loose ends. So this empty page, no workflow selected, currently doesn't create a new workflow when you click on the button. That's the first thing I want to fix. And then the second thing I want to fix is the ability to stop a workflow. So we are able to start a workflow by clicking on the run button, but there is actually no way of stopping it. The only thing I can do once I start the run is actually start it again. Instead, this should turn into a stop button and then cancel the run. Luckily for us, we already have the cancel workflow run action developed, as well as the workflow runs provider, which keeps track of the latest live run. The run button component is located inside of the right sidebar. So make sure that you can find run button inside. This is where we have to implement that dynamic toggle. Once it's started, it shouldn't display run and the play icon, but instead it should say stop and a stop icon. So just make sure you can find this run button component. Let's construct the following prompt. The run button in our right sidebar component can only start a workflow. There is no way to stop one that's running. Make it a toggle. While a run is in flight, it becomes a stop button that cancels that run. And when nothing's running, it's run as before. Then we mention the workflow runs provider and say it already tracks which runs are live. And instead of our workflow's actions, we have an action that cancels a run by its ID. At most, one run is live at a time. Let's go ahead and run this prompt. My agent decided to add a new function, use live run, instead of the workflow runs provider. It extracts the run and simply finds the exact run which is currently live. Then, instead of the right sidebar component, it found the run button, and it uses the new hook to find the live run and dynamically render between stop, which calls the cancel workflow run action, and leaves the usual one, which is run otherwise. So go ahead and construct a workflow with an agent node and make it search for something. That should give you enough time to test whether stopping the workflow actually works. So let's click on run, and then let's click on stop. Once you stop, inside of your console panel, you should see that it didn't manage to complete OpenURL1. As you can see, this step is now infinitely stuck in waiting to finish, and agent 1 wasn't even run yet. So we can now officially stop our runs. You can make the stop button look slightly better by using the destructive variant instead of secondary one. So let's take a look again. There we go. This looks like a destructive action because it's going to stop the run. And now let's fix our empty state. So inside of our dashboard page, the new workflow button in the empty state doesn't do anything yet. Wire it to create a workflow. Keep it simple. A direct call to create workflow action inside of our actions. No optimistic update. Give the new workflow a generated name the same way the sidebar's new workflow button does. My agent decided to fix this by developing a new client component called new workflow button, so it can leave the actual page component a server component. If your client simply added use client and then developed the entire logic here, that should also work just fine. But for example, my agent created a new component, new workflow button, in which it uses use transition to call create workflow action with a generate slug function. So let's test it out. Inside of localhost, I'm gonna click new workflow, and there we go. We have a new workflow created. Congratulations on implementing the last code change we're gonna do in this tutorial. Remember to git stage, git commit, and git push your changes. Now it's time to do the final deployment configuration to make this application work in production. So first things first, go inside of your Railway service, go inside of settings and find public networking. If you haven't already, go ahead and generate a domain. If it asks you for a port, put 8080. That should generate you a domain. Now the domain should work as expected, with one big problem, and that is that every time you try to run a workflow, it will never actually execute it, and instead it will simply stay as queued. So go ahead and try and running any workflow. You will see that I can't even stop a workflow, right? So obviously something is not working right. What we have to do is we have to follow Trigger.dev deployment instructions. You can find that under the deployment section and click on the overview. So first, let's go ahead and run the deploy command within our code base. This deployment will probably fail with errors like these: missing API keys. Right now, what we have to do is we have to transfer all of our environment variables, which are used within our long-running tasks, into the Trigger cloud platform. So let's go ahead and copy this entire file, environment.local. And then let's go inside of our Trigger dashboard. In here, you will find the environment variables, and go ahead and click Add New. You can see that there's a tip. Paste all of your environment variables at once into this form to populate it. There we go. Not all of these are needed, but it's a quick and easy way to add all the ones that you need. So then go ahead and mark this both as development and production. Obviously, you should have different variables for both of those, but since it's just easier to demonstrate how to go to production this way, I'm going to use the same variables for both. And then I'm going to hit save. Once you have all of your environment variables stored, go ahead and try running Trigger deploy again. Now you should have a successful deployment. So go inside of your Trigger dashboard and make sure that you switch your environment to production. Once you are in production, go ahead and scroll down until you find API keys. And you should see a big label, production API keys. Now go ahead and copy this API key. And the place where you're going to add this is in your deployment service. So not here. Do not change the development secret key. This needs to stay as the development environment. But instead, you need to change one variable inside of your raw editor here. So go ahead and find the Trigger secret key and replace it with a production one. Click Update Variables and deploy. Once you have a successful redeployment, go ahead and refresh your live URL and then attempt to run the app again. And this time you should see live feedback and actual execution happening. And if you go inside of your Trigger dashboard in the tasks or runs, you should also see your first production run being executed. Amazing, amazing job, and congratulations on your official deployment of this project. It's been an absolute pleasure building this project with you, and I hope you had as much fun as I did. If you have any feedback or recommendations about what I should teach you how to build next, feel free to leave a comment below. And if you like the video, remember to leave a like and subscribe. See you in the next tutorial.